Hello guys, good morning everyone. Welcome to the session and welcome to the India's most comprehensive preparation platform, that is the BYJU'S exam prep. And yes, we are live with the Republic Day special mock test, because especially is a mock test for electronics, and electronics as well as electrical examination is just on the next Sunday, that is 5th of February. So right now, yes, all occasions are important, but for the GATE aspirant, what is the most important thing right now is just preparation, right? And that is why periodically we are bringing you, rather than regular practice sessions, periodically we are bringing you the mock test as per the GATE exam pattern. Of course, undoubtedly it's a practice also for you, but it is not only a simple practice, it is exactly as per the GATE pattern. So very good morning all, and let me see how many of you are joining quickly. Okay, so that let us start the mock test and let us try to complete that also very quickly, isn't it guys? Just a moment. All right, so yes guys, a very happy Republic Day as well once again to all of you. It's a big day for all of us. It's a big day for the nation. All right, chalo guys, to quickly update all your friends that the session is live. They can now join and let us get started with the session. All right, chalo, done. Morning everybody. Good morning, happy Republic Day. इसको थोड़ा सा सेट करना पड़ेगा अभी. Yeah, I think this is fine. Chalo, let's get started. Okay, let's get started quickly. This is the GATE mock test. This is about me. This is Rakesh, and I've secured All India rank 9th in the GATE, completed my Masters from Indian Institute of Science, Bangalore. And yes, guys, if you are a GATE 24 aspirant, or if I think your juniors, your colleagues, anybody in your touch is going to prepare for GATE 24, so on this Sunday, that is 29 Jan, at the time of 12:30 p.m. I bring you a mega workshop which is going to be conducted on the app, and it's undoubtedly free workshop on app, where we'll talk about 7 golden rules to secure a single digit rank in the GATE examination. All right. Yes guys, still a GATE exam is just round the corner. Still, if you are missing on the very important thing, that is the GATE virtual calculator, still if you are missing out, then the last chance, again on the Sunday only, again on the Sunday 29th Jan at 10 p.m. I bring to you, okay, the final session, the tips and tricks to use the GATE virtual calculator. Still, if you're not aware about all its features, including the powerful memory features, I bring to you this session Sunday 10 p.m. a crisp and a brief session to give you all insights about this particular calculator once again. And yes guys, immediately from tomorrow 27th of January on this BYJU'S exam prep YouTube channel where you're watching this session for ECE, IN and CS, we bring you the Super 11. Yes guys, so do not forget to subscribe to the channel in case you're not subscribed, so that we'll be discussing top 11 questions of every subject in this session. Every subject, top 11 questions to be discussed, right? Join live from tomorrow. Tomorrow itself is the first session that I'm going to take for digital electronics. Super 11 questions of digital electronics. Yes guys, here it is guys. And now we all know that GATE exam is also there, as I told you. For ECE, it's on the 5th of February. For mechanical computer science, it's 4th February. And the entire team of BYJU'S exam prep is going to come live for the exam analysis. Yes, guys, 4th and 5th February. Okay, EE, ECE and computer science. We bring you computer science, of course, on 4th, ECE on 5th, right? At the times of forenoon session 1 p.m. and afternoon session 6 p.m. You can join us live so that you can see what is the answers you have marked, and what is the difficulty level, what can be the expected cutoffs, what can be the topper marks. I'm all good. Thank you everyone. Once again, very good morning and a happy Republic Day to all of you. Now let's get started quickly within no time. Okay, so this is exactly a quick insights about the rules. This is exactly GATE exam pattern. So there will be questions of GA. Okay, there will be 10 questions of GA, 5 1 marker, 5 2 marker. Then there are going to be 55 questions of the technical EC, which of course includes maths. And as again after the pattern, 25 into 1, 30 into the 2, right? There will be questions of MCQ, NAT and the MSQ types. MCQ, NAT and the MSQ types. Students are required to keep a pen and notebook ready so that whenever you see a question on the screen, I will also solve parallelly. One simple advice I will give you: whenever a question is there on the screen, for the immediately you can mute the video. Just keep playing it, but mute it so that when I am discussing, you don't listen to me. You start solving, but I'll also start solving parallelly because we want to make it to a crisp session. Okay, आप mute करो, आप solve करो. By the time you solve, maybe by the time I solve, and then you can match up your answers, right? Again, please use only virtual calculators and keep a track of your marks, like how much you are scoring in plus or how much in minus. Every question, write down the mark, whether you have scored 1 or 2 or 0 or minus 1/3, minus 2/3, whatever it is, and a sheet of paper so that at the end you can evaluate what was your total marks out of the 65, sir. Clear hai everybody? Okay, so let's get started. Let's get started with the non-tech. Okay, I'll be first taking general aptitude, then going to the digital. So here it is, guys. General aptitude. First question quickly. The ratio of the amount for 2 years under CI annually and for 1 year under SI is 6:5. What is the rate? When the rate of interest is same, what is that rate of interest? What is that rate of interest? What is given to you? Okay, the ratio of the amount for 2 years, okay, under CI is same as the amount for 1 year, but under SI, and that ratio is given to you as 6:5. So let's do this quickly. What is the amount at the end of second years? In the compound interest, P 1 plus R by 100 whole square. P into 1 plus R by 100 raised to the power T. Okay, compounded annually only by default. Okay, yeah, annually mentioned bhi hai. Divided by amount. Now, in the case of simple interest, normally students remember the formulas. Okay, the formula is simple interest formula, PRT by 100. But amount, principal plus the additional interest. So amount is P plus PRT. T is equal to 1 because only 1 year SI. Amount after 1 year. So PR into 1 by 100, and this is equal to the 6/5. Okay, so sir, this is very simple. P common. 1 plus R by 100 ka whole square divided by denominator P common. It is simply 1 plus R by 100. Okay, this is 6/5. P cancel, 1 plus R by 100, one time it is cancelled. So what is 1 plus R by 100 is 6/5. So R by 100 is 1/5. Solving it, I am going to get R is equal to, dear, R is equal to the 20%. Is that okay, everybody? So correct answer is C. Check your answers, what you have tick marked. The correct answer is C, that is the 20%. The correct answer is C, that is the 20%. That is the 20%. Chalo. All right, next question. Read the following information and answer the questions given below. Answer the questions given below. I think less number of students in this mock test today. Okay, let's see how many more are joining here quickly. Okay, so read the information given below and answer the questions given below. Okay, it's a coded relation. Relation say A plus B means A is the daughter and etc. Some codes are given to you. And then there is one question. P into Q minus S. Which of the following is true? P into Q minus S. Okay, sir. What is the meaning of P into Q? Into means son. Into means son. That means P is the son of Q. P is son. Son bole to male. So we know the gender. Son of what? Q. So Q down P. Okay, it is the Q down P. Then I have next Q minus S, and minus means wife relation. So Q is known as the wife of S. Okay, so Q becomes the wife. That means female, and the wife of S. S is the husband. So of course male. Which of the relations is very correct now? Which of the relations is very correct now? Let us track that. Let us track that. Okay. So S is the wife of Q. No, Baba. S is the husband of Q. S is the father of P. So S and Q are married. They are both the parents of P. And S being the male, S is the father of P. The very correct answer is B. Okay. Yes, Abhishek, correct answer. Yes, Satvika, correct answer. Very correct answer is B. S is the father of P. Correct? S is the father of P. P is not the daughter, P is the son clearly. Q is the father. No, Q is the mother already, it was told. Okay, so B is the correct answer. Simple blood relation question of the 1 marker. Yes, Ravi, correct answer is B. Okay. The correct answer is known as the B. If you have any doubts or if you have any confusions, please let me know here. Okay, please do not forget to let me know that confusion. Okay, so that we can rectify that. Okay, let's move ahead to the next. Right. Okay. So, very honest, like we have done in the previous mock test, since I usually don't deal with verbal, so let us not spend time also in verbal. Let us spend the time in aptitude and digital, and then rest of the technical subjects coming. Aptitude, I'll just talk about the answer key. Okay. A very simple statement it is. If the athlete had wanted to come first in the race, he should have practiced. Very simple question of sentence completion. He should have practiced. उसने इतना practice करना चाहिए था. Okay, every day. Okay, so he should have practiced several hours every day. Okay, he practiced, that goes to the past tense. If he had wanted, it's talking about future. Okay, he should have practiced. Okay, ऐसा करना चाहिए था. He had practiced means उसने ऐसा कर लिया. That's a different thing. Okay, चलो. B is the correct answer. Next one, choose the grammatically incorrect statement. They gave us the money back less the service charges to the 300 rupees. This country's expenditure is not less than that of Bangladesh. This also looks okay. This country's expenditure is not less than that of the Bangladesh. That of Bangladesh मतलब that of का भी use करेंगे. Okay, when we want to refer to the previous statement, expenditure. So it's not less than the expenditure of Bangladesh. Okay, looks good. The committee initially asked for a funding of 50 lakh rupees but later settled for a lesser sum. Okay. This country's expenditure on educational reforms is very less. Okay. A is not the proper correct answer. Okay. A is not the proper correct answer. Even for the previous one, when some of you gave the correct answer, that is the B. Okay. Then again, there is some statement given. Which of the following can be logically inferred? This is also a very common type of question in the GATE examination. Okay, a statement, a particular paragraph is given, and which of the following can be inferred from the above statements. And again, I'm telling you, verbal pe time spend nahi karte. Let's go to the aptitude and the digital electronics part. So correct answer for this is going to be the answer number A. Clear? The correct answer is going to be answer number A. Okay? Engineering world, please post any of your doubts in the Telegram, because otherwise it will spoil the speed of the mock test. Okay, you can drop this personally to me on the Telegram also. Maybe in the group or maybe personal DM also will be okay. Next question, guys. Yeah, let's come here. What is the remainder? What is the remainder when 7 की power 74 minus 5 की power 74 is divided by 4? 7 की power 74, it's a 2-mark MCQ question. Minus 5 की power 74 is divided by what? Is divided by the 4. तो इसको देखते हैं. Okay, इसको देखते हैं. 7 की power 74 minus 5 की power 74. All right. Acha, let us talk about the first one. Question is actually remainder when 7 raised to the power 74 minus 5 power 74 is divided by 4. If you apply the remainder theorem, okay, when two numbers are added or multiplied or subtracted, you can find a remainder, net remainder, by calculating the individual remainders separately. So remainder when 7 की power 74 divided by 4 minus remainder when 5 की power 74 is divided by 4. Let's do this separately. Now, the second case is actually very simple. How the second case is simple? इसको देख लेते हैं यहाँ पे. In the second case now, I've taught you all this. Even in the marathon sessions I have taken, I have given you these explanations how this works. So you can either find the pattern. So there are some good predefined two important patterns. देखो, number one, what is the remainder of 5 की power 74 divided by 4? This is of the form remainder when a plus 1, numerator 1 greater than denominator, a plus 1 power n, and this is always equal to 1. When numerator just 1 greater than denominator, when the numerator is just 1 greater than the denominator, answer is simply equal to what? Answer is simply equal to 1 for any value of n, right? It is 1 for all n. You can even try now. You can even think and try, but at least two important patterns you must know. Okay, so 5 by 4, remainder will be 1. 5 square, 25 by 4, remainder is still 1. 5 cube, 125. So 124 is divisible, na? Remainder is still the 1. Okay, take any value of n, remainder is always going to be 1. Okay. Now, next, remainder of 7 की power 74. First of all, dear, what is the remainder when 7 divided by 4? That is 3. That is 3. This is what we know. So now I need the remainder when 7 power n divided by 4. Again, the number 7 can be replaced by its individual remainder. So 3 power 74 by 4. Now 3 is 1 less than numerator. Again, the case when numerator denominator are having a difference of 1 unit, but numerator 1 less. Okay, this is of the form remainder when a power n is divided by a plus 1. And you know what is the pattern for this? Remainder when a power n divided by a plus 1. Ravi says A, Shrija says C. Let us check what is the correct answer. You know what is the remainder when a power n divided by a plus 1. Denominator is just 1 greater than the numerator a. This is equal to a, right? This is equal to a for odd n, and this is equal to 1 for even n. Here only even odd you have to check. Here only even odd you have to check. Clear everybody? Right. Now, right now, this is 7 की power even पे remainder 1 होगा, minus 5 power anything by 4, remainder will be 1. So net answer has to be 1 minus 1, which is the 0. Net answer is 1. Okay. It is 0. It is the 0. Correct answer is option number A. Correct answer is known as the option number A. Clear everybody? Okay, sir. Next question. So Ravi got it correct. Shrija, it's going to be A. Just recheck your calculation. It's a good question based on remainder. It's a good question based on remainder. Okay, if you want to learn all of this, already I have taught this in the marathon sessions. You can still go through it if you haven't gone through. Let's go to the next. In a hockey championship, there were 153 matches played. 153 matches played. Every two teams played one match with each other. Okay, यहाँ पे full stop होना चाहिए. Hockey championship, there were 153 matches played and every two teams played one match with each other. The number of teams participating in the championships is how much? Number of teams participating in the championship is how much? Morning, Payush. Tell me, number of teams participate. It's a very simple question for 2 marks actually. Okay, there are 153 matches. That statement is given कि total 153 matches have been there. Every two teams played one match with each other. Okay, let the total number of participating C. Okay, let the number of teams be N. Okay, for one match you need two teams. Okay, for one match, very simple logic it is. One match, select any two teams, right? For one match, select any two teams, right? So total number of matches. So sometimes very simple for 2 marks. Total number of matches. It's selection of any two teams out of N. Any two teams out of N. That is NC2. And this is given to you. Okay, this is a given number to you. So what is given? NC2 is equal to 153. What is NC2? N minus 1 divided by 1 into 2. This is 153. So N minus 1 is 306. Now, your choice, either you take it as a quadratic equation and solve it. Why to take it as the quadratic equation? You can solve it very simply, na? Why to take it as the quadratic equation? N minus 1 equal to 306. You can just match the options. You'll just match it up. 18 is gonna be correct. 18 into 17 will be 306. 18 into 18 minus 1, that is 17, will be 306. Very simple. So no need to go for quadratic equation and solving it. Okay. Whatever you are getting the correct marks, please keep writing your answers in the keep writing your marks in a sheet of paper, as I told you earlier also. Chalo, next question. Yes, thank you, Payush. Happy Republic Day to you, as well as to once again all who have just joined the session. In a marriage party, ice creams of 3 different flavors, that is vanilla, strawberry and chocolates, are served. Among the guests, 100 have eaten vanilla, 150. Achha, it's a 3 picture case. So let me quickly draw the Venn diagram for this. Logical Venn diagram based question it is. Okay, so let this be vanilla. यहाँ numbers लिखते जाते हैं. Let this be vanilla. Next one is strawberry. Next one is chocolate. Okay, 100 have eaten vanilla, 150 have strawberry, and initially I can write down this as A, B, C, D, E, F, G. There are 7 regions and H outside. Okay, this is the sample space where I have total number of guests. अब ध्यान देना, whatever information I get, I will. Okay. Sure, Abhishek, sure. Will not stop. We'll actually keep adding sessions only. Don't worry. Okay. So when I say 100 have eaten vanilla, it means this particular region, entire A plus B plus D plus E, right? 100 have eaten vanilla. So it includes everything, only vanilla, vanilla plus chocolate, vanilla plus strawberry, and vanilla plus chocolate plus strawberry. Everything it includes. Okay. Then similarly 150 strawberry, 170 chocolate, 50 guests have eaten. कुछ typo errors हैं. They have eaten vanilla and strawberry ice cream. 60 have eaten chocolate and ice creams. Chocolate and vanilla and chocolate. Okay, so there should be chocolate and strawberry ice creams. And 30 have eaten vanilla and chocolate. 20 have eaten all three. चलो यहाँ से start करते हैं. 20 have eaten all three flavored ice cream. And 80 have not eaten any ice cream. So I clearly get, guys, I will just, if you solve it equation by equation, that is also okay, but that is going to be lengthy. One by one statement, that is how logically you have to solve. Okay, not arithmetically, logically you should solve it up. So 20 have eaten all three flavor and 80 have not eaten, right? 80 have not eaten, matlab 80 are outside this, and ye common wala mil gaya mujhe. 80 is the number here, and what is the common? 20. Everybody listen, this is 20. I hope you are able to see. This part is the 20 common. Now, once I get the common, I'll keep solving it. Now, dekho. 50 have eaten both vanilla and strawberry. 50 have eaten both vanilla and strawberry. Come to the vanilla. Everybody, vanilla and strawberry, total 50. This portion, this is total 50. Are you getting it? If this is 50, out of the 20 is common to all three. So what is the portion common to only vanilla and strawberry? That should be equal to 50 less 20, that will be 30. 50 minus 20, that is going to be 30. That is going to be 30. So I'll just give you a hint. How this is solved? 50 minus 20. That is 30. Clear? Similarly, next. So dekho, what is used? This is used. Next, 60 have eaten chocolate and strawberry. Chocolate and strawberry. This one is total 60. Total 60. Clear? Out of which 20 is already available. So this part is 20 minus 60. That should be 40. So here I placed 40. Okay, so this statement is also used. And then 30 have eaten vanilla and chocolate. Vanilla and chocolate. This is total 30. This is total 30. Out of which 20 is already occupied. So only remaining 10 will be the D. Okay, now I can get others as well. How I can get the others? Now I can get the others. So Satvik is saying 260. Let us check. It's a NAT type question. Thank you, Guram Akshay. Happy Republic Day to you as well. Okay, vanilla. What is that vanilla? 150. Nahin. How much is vanilla? 100. 100 is vanilla. Out of that 30, 20 and 10. 60 is already gone. The 40 will be exclusively only vanilla wale people. Okay. Then how many for chocolate? 170 for chocolate. Out of 170, 50 and 90 is gone. 80 will be left here. Correct. And then you have 150 for strawberry. Sorry. 170 for chocolate, na? 170 for chocolate. Chocolate yahan pe hai. So this is 70. So this should be 100 actually. Yahan pe aayega. This is 100. And then I have 150 for strawberry. So 150 mein se this was 90. So this is 60. Clear now? Everything is written in front of you. Everything is written in front of you. Okay. So how much is this? Let's just add it up totally. Na? So this part becomes 70, 130, 150, 200, 300, 380. Just check it out once again. 70, 130, 150, 200, 300, 380. Okay, just check it out. I'm getting it as 300. You can also just check it out once. 380. 380 is the total I'm getting. 80 have not eaten. 20 tha. 50 minus yeah, I guess 60. One of them was 40. 30 minus 20, 10. And then this was 100 for vanilla. So out of that 60 gone, the 40 left. Strawberry, let me recheck once again. How many for the strawberry? Kahan gaya data so much? 150 for the strawberry. So out of the 90 gone 60. And then for chocolate 170, 170 means 70 gone. This is 100. Okay. So again, just I'm checking. 7, 10, 100, 200, 300, 380. Correct? Eh? Yes, it's all good. Yes, Ravi, Payash, Krishna, you also say 380. The correct answer is 380. Sum of all, na? This is sum of all of this. The total number of guests looks to be 380. The total number of guests looks to be 380. I think that's sorted now. Correct, Chanu. Okay, Chamu. I'm sorry, correct. Yes, engineering world, I told you, right? Please post any of your personal doubts in the Telegram. Let's go ahead to the next. Okay. Chalo, a pie chart question. A line chart question. Okay, on the following line chart, the question is based on the following line chart, which shows the profit percentage earned on three products ABC over the years 2002 through 2007. If the selling price of the product be in 2003. So now selling price, they're talking about product B. There are three different products, but I want to focus on B, and that too in the year 2003. So DI question is always like that. There will be a lot of data and then there will be one question relevant to it. You have to figure out what data you have to extract. There can be a huge amount of data, but I only want the data of product B in the year 2003, and the SP of that is 3.9. Then what was the profit earned? Acha. Here profit percentage is given, right? B is this one, circular 2003 mein jo circular hai, that is 30%. Clear everybody? 30%. So we know that percentage profit is given to you, and this can be SP minus CP divided by CP is whole multiplied by 100. So what is that percentage profit? So that is the 30% given to me. Clear? And that is equal to SP by CP minus CP cancelled 1 into 100, right? So it is very simple now. SP by CP kitna hua? This is 0.3 plus 1, 1.3. Okay, 100 divide kiya, 1 add kiya, 1.3. So what should be the CP? That is SP. Now how much is the SP given to you? 3.9 lakhs is the selling price. So 3.9 lakhs divided by 1.3. So this is 39 by 3. This is as simple as 3 lakhs. So now what is the net profit? Percentage profit to given tha. What is our net profit? It is the selling price minus the cost price. So the profit is 0.9 lakhs, or that is 90,000. That is a 90,000. D is the very correct answer. A simple question. And I'll tell you, mostly DI questions with respect to the calculations and concepts is very simple. Only thing is you should be correctly able to interpret the given data, what is required, and put it into action. It's a very basic question based on percentage, or you can say simple interest, compound interest. Sorry, profit and loss. I misread it. It's a profit and loss calculation, not simple interest, compound interest. Clear? Chalo, cool. Next question, let's get moving ahead with the next question on the screen. Okay, here it is. Once again, a verbal based questions. Once again, a verbal question, the arrangement of the options. So better again, as I'm telling you, verbal, let's not discuss. Let's put it at the answer. The answer for this is going to be C. Yahan pe kya given hai? The number, the first and sixth statement. Okay, I'll tell you the essence. The first and last, that is 1 and 6, they are at its own place. But rest, 2, 3, 4, 5, they are jumbled. They are jumbled. Okay, you have to read and arrange, give a logical arrangement to all of this. Okay, what is a logical sequence to make a passage, and choose the correct sequence from the given options. Choose the correct sequence from the given option. ठीक है sir? Done है? बढ़िया. Okay, choose the logical sequence from the given options. Okay sir. Okay, so answer is going to be C. First statement is fixed. On Diwali, the family rises early in the morning. Next, children let off fireworks. Children let off fireworks later in the night with their friends. Nahi. Ek second. I think not C. I think maybe I've not marked it correctly. 5. Sorry, it's going to be B. Hai na? Father, mother and children visit relatives and exchange gifts and sweets. Okay, then the whole family, including the young and old, enjoy this. At sunset, ab sunset ki bari aayegi, the lamps are lit and the family performs various rituals, and children later in the night they let off some fireworks. It's going to be B actually. It's going to be B. Correct. B is the correct one. I think I wrongly tick marked that. B. B makes the more logical sequence. B makes the more logical sequence. क्योंकि यहाँ पे सबसे पहले children lets off firework later in the night, that doesn't go, that is the last event ना. Okay, चलो done है, ठीक है. So it's going to be B. It's going to be B. And now guys, a quick update before we go forward, that yes, 24th January to 30th January, the All India. So this is the live mega mock on YouTube that you're attending right now. But rather than that, if you want to appear in the All India Open Mega Mock, competing yourself between thousands of students, okay, knowing your rank, knowing your performance, knowing your mistakes, everything you want to know, okay, as per the real GATE atmosphere. So this is a free All India Open Mock test, which is available on our app. 24th January, that is already started. It is going to be live till 30th January. Okay. Do not forget to register for this and prove yourself. Okay, and again guys, 27th January, that is just tomorrow. that is just tomorrow, Super 11 series is going to start, where we will discuss top 11 questions of every subject. So do not forget to subscribe the channel in case you're not subscribed, so that you get all the updates regarding to this series as well as other sessions going on. And 4th and 5th February, the exam analysis, okay, live on the YouTube. Now let us get started with the digital electronics. And as I told you, digital electronics tomorrow at 9 p.m. you have the Super 11 of digital electronics also. Super 11 questions. Super 11 questions of digital electronics tomorrow at the same channel, 9 p.m. Tomorrow is the first day of Super 11 series. First it will be digital. Okay, now let's come to a question of digital here. Question number 11. A flip-flop has a 3 nanosecond delay from the time the clock edge occurs to the time output is complemented. So this is always known as what? T clock to Q. Whether the output has to be complemented or it has to be set or reset, anything, there is some change in the output required, and we call the delay normally of a flip-flop as T clock to Q, the time from the clock edge up to the Q. Okay, and that is equal to TPD. That is the propagation delay, and that is given to you as 3 nanoseconds. Okay, now TPD, let's also call it as T flip-flop. That is for a single flip-flop, 3 nanoseconds. What is the maximum frequency for a 10-bit triple counter? Now for a 10-bit triple counter, what is the worst case delay? Okay, for a 10-bit triple counter, what is the worst case delay? It is given by NTFF. If it was synchronous counters, it is the delay of single flip-flop. But if it is the ripple counter, it is 10 times, yeah, n times. Okay, n times the delay of every flip-flop. Okay, so how much this data? This is 10 multiplied by 3 nanoseconds. This is total 30 nanoseconds. Okay, that is the worst case delay. Okay, that is known as the worst case or the maximum possible propagation delay for the ripple counter. So from here, guys, what is the formula for clock frequency? Now, guys, it's a mock test atmosphere. Let's not derive and discuss. Let's only use our concepts. This is application oriented session. Okay, not explanation session. But yeah, we have covered this somewhere in all our previous YouTube sessions, which is related to the flip-flop or the ripple counter theory. Okay, so the maximum clock frequency for a ripple counter is given by 1 upon TPD, that is 1 upon T flip-flop, 1 upon NT flip-flop. So this is 1 upon 30 nanoseconds, 30 into 10 power 9 is 9. NAT question answer is expected in megahertz. So 10 power minus 9 goes above and split it into 10 power 6 and 10 power 3. 10 power 3, 1000 by 30, that is 100 by 3. 100 by 3 will be 33.33. 10 power 6, I will write it as mega. So correct answer is here 33.33 megahertz. Simple question. Correct? Yes, Rupesh, Payash, Pankaj, Ketki, correct answer. So correct answer is the 33.33 megahertz. Done? Eh? 33.33 megahertz. megahertz. Okay, all is sorted, and now we have the next question. Okay, MSQ question, a 1 marker MSQ question is here. In a 2-bit magnitude comparator, A and B represent the 2-bit binary numbers. Number of, now, okay, it's a 2-bit magnitude comparator. If it is n-bit, now what is the total number of combinations? Simple logic. If it is an n-bit comparator, what is the total combinations? What is the total combinations? Right. See, you have 2 n-bit numbers. N-bit comparator means you have 2 n-bit numbers to be compared. Right. So total number of combinations will be how much? Total number of bits will be 2n. It is 2 ki power 2n. So here it will be 2 ki power 4 actually. Here it will, not 2 ki power n, 2 ki power 2n. So here it's going to be 2 ki power 4. A and B are 2 binary numbers. Both are 2 bits. So total 4 bits. So total combinations are 16. So C is correct. Okay, C is the correct. Okay, now out of which how many are equal cases? How many are equal cases? How many are equal cases? For 2-bit, how many equal cases? 0, 0, 0, 1, 1, 0, 1, 1. For every one combination, there will be equal combination of the other, right? So 2 power 2, that is 4 combinations are correct. This is okay. Number of A and number of B. In general, 2 power n. In general, 2 power n. Are you getting it? In general, 2 power n. Right. Take any 1 to n-bit number. What is the number of combinations of a single n-bit number? 2 power n. right? For every combination of A, there will be one number in the set B which will be equal to A. Simple logic. So 2 power n, right? Then how many unequal? Of course, how many unequal? 2 power 2n minus 2 ki power n. Out of that unequal, 50% will go to the greater than, 50% will go to the less than, right? So how many for A greater than B? And how many for A less than B? Both will be equally divided here. How many for A less than B? So 2 power 2n minus 2 ki power n divided by 2. It's a simple question based on comparator. So out of the 16, 4 are equal, 12 are unequal. Out of the 12, 6 will be less than, so this is wrong. And 6 will be greater than, this is the correct. D is the correct answer. It's MSQ, but a very simple question, so 1 mark I've put it for this. It's a MSQ 1 mark question, right? The correct answer is A, C and D. The correct answer is A, C and D. Done, eh? Okay. Next question, guys. The next question, guys. Correct answer is the A, C and D, and here it is. For the 4 cross 1 mux shown below, it implements the function summation f 3, 4, 5, 7, 10, 11 plus summation of don't care 1, 6, 15. What is the input I0, I3? So it's although a 4 cross 1 mux used. Okay. 4 cross 1 mux will have only 2 select lines, we know. Okay. But it's a 4 variable function. If it was a 3 variable function, 2 goes to the select line, anyone on the input line, we can directly draw the implementation table. Okay, but for 4 variable, I'll give you a simple tabular method rather than implementation. Ekdam simple logic se isko solve karenge. Okay, for no need to, if you have 2 variables on the input line, then no need to go for the complicated implementation table. I will give you a logical answer for this, and it's a MCQ 2 mark question. It deserves 2 marks. Okay, so there are 2 select lines here. Right, and the inputs are W and Z on the select lines. These 2 are on the select lines, so these 2 are on the input lines. These 2 are on the input lines. Acha, the function has what all minterms? 3, 4, 5. Let me write down the minterms. 3. Now 3 means 0, 0, 1, 1. 0, 0, 1, 1. Let me write down the minterms first. 4, 5, 7. Okay, then 4, 5, 7. 3, 4, 5, 7 and 10, 14. 10, 14. So 4, 0, 1, 0, 0. Right. 5, 0, 1, 0, 1. 7, 0, 1, 1. 10, 1, 0, 1, 0. And 14, 1, 1, 1 and 0. This is 14. Then we have 3 don't cares. 1, 6 and 15. 1, 6 and 15. 1, 0, 0, 0, 1. Right, 6, 0, 1, 1, 0, 0, 1, 1, 0, and 15, 0, 1, 1, 1, 1. 15 is the 1, 1, 1, 1. Okay? 15 is the 1, 1, 1, 1. Now, W and Z are there as the select lines. Okay, for the first possibility of WZ 0, 0, right? WZ 0, 0 means W bar Z bar. Now, when you look into the W bar Z bar, listen to me. When you look into the W bar Z bar, where will be the W bar Z bar? 4th mein aayega. So you need X, Y bar. Bhai, what is the functionality of the mux? W bar Z bar into the I0. W bar Z bar into the I0. Clear na? 0, 0 pe I0. 0, 0 means W bar Z bar. So what should be I0? That I'm trying to decode very simply here. So W bar Z bar, W bar Z bar, W bar Z bar. This is only one case. Now don't care is in your hand. Optional. If it reduces a variable, you can use. Otherwise, you can skip it up. So any W bar Z bar here, yes. Okay, so plus XY. And if you add plus XY, yes, it is reducing a variable. Yes, it is reducing a variable. And what is that? Y bar plus Y. X will be common. Y bar plus Y will be 1. So that X will be equal to the I0. So that X will be equal to the I0. Okay. Next combination is W bar Z. Next combination is the W bar Z. Okay, got this logic? Got this logic? So W bar Z pe aa raha hai 3. So X bar Y. W bar Z, then XY bar, W bar Z, here also plus XY. Okay, no more else. Now W bar Z is available here also. If I use this X bar Y bar, now see, with respect to 2-bit, with respect to 2 variable, these are all the 4 combinations, right? You have 0, 0, you have 0, 1, you have 1, 0, you have 1, 1. So sum of them will be 1. So if you don't use the don't care, please pay attention. If you don't use the don't care, you will get an expression which will be like OR gate. I think this is going to represent OR gate, X plus Y. But if you use that don't care, it simply becomes 1. So no hardware required. So don't care, that is how you use don't care. This is going to be 1 and that is going to be the input line I1. Okay. Next is WZ bar. WZ bar, so where is WZ bar? WZ bar, ये है 10 पे, X bar Y plus WZ bar XY, right? WZ bar, no, it's not there and don't care. So, ठीक है. But midterm, this is compulsory. This is not optional for you. All of this is compulsory. इसको compromise नहीं कर सकते. This is optional. Okay. So now next, what is this? What is this? In this, Y will be common. X bar plus X is 1. So this is Y and that will be equal to the I2. And last case, that is W into Z. That is W into Z. Where is W into Z? Not here, not here. Now only, it is not here and not here. It is not there in the midterms. Now WZ is available in the 15th. If you use it, suppose, if you use this don't care, you will write down XY. But don't care is not compulsory. If you don't use it, XY will require one AND gate. Now, but if you don't use it, means it is 0. WZ is not available in the midterm list. So 0 means no hardware required. It's a ground connection. So simple. Let's not use the don't care here. Got this? So this is what is going to be, sir. This is what is going to be I3. So sequence is X1, Y and 0. X, then 1, Y and 0. It is the option number C. Is that clear, everybody? The correct answer is the option number C. X and 1 and Y and 0. X and 1 and Y and 0. Okay. That is the correct answer. C. Let's move ahead to the next question. Okay. A latch can be constructed, some latch known as RH latch, some random latch is there. It can be constructed from an OR gate and an AND gate and the inverter as shown here. What is the characteristic equation for the latch? So before we write down the characteristic equation, let us understand what are the different combinations, whether it is set, reset, complement, toggle, what is happening in this latch by taking the combination. So देखो, if I take the RH 0, 0, please pay attention. If I take the RH equal to 0, 0, so output is Q as clearly specified. Output is equal to Q. We want the next state for the Q. Okay. So ध्यान देना. If H is equal to 0, यहाँ पे. If H is 0, this is always 0. AND gate output is 0. If AND gate output is 0, R is also 0. 0 plus 0 will be 0. So next state is going to be 0. Clear? Next state is going to be the 0. Next, 0, 1, 0 ले लेते हैं पहले. अरे, what happened here? Just a moment, है ना? Yeah, now it is okay. Let us take 1, 0 because whenever H is 0, it is a simple problem. H is 0, output of the below AND gate is 0. Okay, so यहाँ पे 0 आया, 1 plus 0 will be 1. So if RH is equal to 1, 0, what is the next state? Q plus next state will be 1. That is set. Now let us take the other two combinations 0, 1 and 1, 1. 0, 1 and 1, 1. So let's take the 0, 1 now. 0 and 1. H is equal to 1. Okay, so this is Q. If H is equal to 1, the output of AND gate is always Q. Q into 1 is Q. Now, Q plus 0. Q plus 0 is Q. So next state remains the same. This is the same state condition. Last combination 1, 1 ले लेते हैं इसको. So R is 1. Okay, ये Q है. 1 into Q is that definitely Q. Q comes here, but Q plus 1 in Boolean will be 1. So next state will be set. Next state will be set. These are the four possibilities. These are the four possibilities. So now if I make the characteristic table, this is the understanding of this latch. Now if I make down the characteristic table to get the characteristic equation, let us make that characteristic table here. Let us make that characteristic table here. And what is that characteristic table? Q, inputs are R and H. Q, R, H, and with respect to that next state. Okay, there are three input variables, including the current input. So there will be 8 combinations. Let me write down those 8 combinations first. Okay. Now, RH 0, 0, 0, 0 pe it's 0. So look into this. Whenever RH is 0, 0, next state has to be 0. So please write down 0. Okay. When RH is 1, 0, 1, 0, the next state is set. So at 1, 0, it is always set. At 1, 0, you look, it is always set. Even at the 1, 1, it is set. पहले 1, 1 को deal कर लेते हैं. So it is set. See, 1, 1 and 1, 1. RH 1, 1, so next state is set. That is equal to the 1. Okay. What is left? If RH is 1, 0, next state. Sorry, 0, 1 बचा है. Next state is same. 0, 1. Okay, this is 0, 1. This is 0, 1. So 0 remains to be 0. 1 remains to be 1. Clear? So just I will copy the current state, 0 ka 0, 1 ka 1. So definitely when I feed this to the K map to simplify this, so it's a decent question on design on a random large given, and you need to answer the characteristic equation. There's a 3 variable boolean RH, then I have to fill it up 0 0 1 1, then 0 1 1. I will pair it up. Okay sir, this is completely a quad, this comes under R, and then there is a pair which comes under Q as well as H. So what is the next state equation? That is R plus QH. R plus QH should be the answer, sir. The next state is R plus QH. The next state is R plus QH. It is the option number C. R plus QH. It's the correct answer, which is equal to the C. Done, eh, sir? The correct answer is equal to the C. R plus QH. Okay, fantastic. R plus QH. Next, a flow rate sensing device. A flow rate sensing device used on a liquid transport pipeline function. It's a good comprehension question. Understand? Let's understand. Okay. Understand. To ensure that, okay, I'll tell you that also round 2, why it is not gate for. To ensure that, you know, that the both outputs are always the toggle of each other. And you can test the state of P. I have only given you the state of Q because we wanted the characteristic equation. For every combination, if you test the state of P, you should be able to find that it is the complement of the Q. That is the actual intent of using the inverter in the previous gate, in the previous question, okay? A flow rate sensing device used on a liquid transport pipeline functions as follows. The device produces a 5-bit output, first of all, where all 5 bits are 0 if the flow rate is less than 10 gallons per minute. The first bit if 1 is the flow rate is at least 10. The first and second bits are 1 if the flow rate is at least 20, right? So when it increases in 10, 10, 10, the bits keep on increasing 1. Now these 5 bits are represented by logical variables A, B, C, D, E, and they are used as input to a device. Now this further will be input to a device which will produce 2 outputs Y and Z. What is the minterm expansion of Y? We only want the minterm expansion for Y. If we want Y to be 1 if the flow rate is less than 30 gallons per minute. So I'll have to actually write down 3 columns here, sir. I will actually write down the 3 columns here. Number 1, flow rate. Okay. Number 2, okay, based on the flow rate, the device will produce 5-bit output, which is A, B, C, D, E. A, B, C, D, E, and these 5 bits go to another device that will produce 2 outputs Y and Z. Okay, Y and Z, but I only want Y right now. I only want Y right now. It's a part of a question where Z can also be given, but I only want to talk about Y. Whenever the flow rate is less than 10 gallons per minute. Okay, less than 10, let me write down that, let me specify that by default the flow rate is in gallons per minute only. Flow rate in gallons per minute. Okay, if it is less than 10, all 5 bits are 0. Like that, let's work out. Like that, let's work out. Okay, so it's a good question based on the digital. Just a moment, है ना? Hanji guys, let's continue. Now next is the first bit if 1 is the flow rate is at least 10. At least 10, greater than 10. But when it is at least 20, the next bit will also be 1. So let's write down only the range 10 to 20. The first bit is 1. If it is more than 20 and so on. So 20 to 30, next 2 bits, next bit also 1. So first 2 bits are 1, first and second. If, of course, and so on, the same pattern, if it is more than 30, but more than 30 but less than 40, so first 3 bits are 1. If it goes beyond 40, so 40 to 50, it will be first 4 bits 1. And if it is 50 to 60 or anything greater than 50 now, I can say anything greater than 50, all 5 bits are 1, because whether it is 50 to 60, 60 to 70, anything above that, all 5 bits are already 1. Okay. Now, we want minterm expansion for Y, where Y should be 1 if the flow rate is the flow rate is less than 30 gallons per minute. Okay. Flow rate is less than 30 gallons per minute. So is this less than 30? Yes. 10 to 20 less than 30? Yes. 20 to 30 less than 30? Yes. 30 to 40. Now this is not less than 30. All these are greater than 30. The Y should be low. Y should be 1 if the flow rate is less than 10 gallons per minute. Is less than 10 gallons per minute. So isn't it a simple question now? Okay, Z is not specified to you, but what is the Y? Y contains some minterms. Acha, what is that minterm? 0, 0, 0, 0, 0. That is 0. 1, 0, 0, 0, 0, 16. And 1, 1, 0, 0, 24. You can convert to decimal quickly. 16, this is 16 plus 8, 24. Y is high only at these combinations. Acha, let me add on one more thing. Y is 0 only at these three combinations. These are 5, for second and third table, if you see, this is the input. 5 variable input, 32 combinations are there. Several are unused. Okay, several are unused, they don't occur. So there will be some don't care list. There will be some don't care list, but that is not required in the question. You don't bother. Only thing that this question demands you is a comprehension reading of the question. Rest, the solution is a very minimal solution. Solution is a very minimal solution. You should just have the habit of completely understanding the problem, and according to me, it's a simple. The only difficulty in the exam time that I think students will face is, "Itna bada question hai, leave it." They'll just leave it looking into it. Aisa nahi karna hai. Solution looks extremely simple. I don't want the don't care. I don't want to minimize. If I use all don't cares, then it becomes a little more lengthy. But it's a very minimum time taking. But if you only have to give the time on reading the problem. So 0, 16, and 24, sir. 0, 16, and 24. So it should be the C, which is the correct answer. It should be the C, which is the correct answer. Yes, Ravi and Ketaki. Okay. So be prepared, whether it is digital or any technical subject or even sometimes aptitude, you get this comprehension question where the solution is very simple and minimal, but problem has to be read. Bilkul, you don't have to worry about the length of the problem. You should worry about correct concepts to be applied. Yes, Rituparna, correct answer. Okay. So digital is done with this. Okay, and Ankit sir will continue with signals, mathematics, all those things will be coming up immediately for you. Okay, these are 5 questions of digital. So weightage of digital was 3 for 2 marks plus 2 questions for 1 mark, 8 marks digital, 15 marks aptitude. So 23 marks are done. Analyze how much you have scored at least in the 23. Okay, so guys, a quick update that I'll meet you once again live on the app on this Sunday. Okay, 7 golden rules to secure single digit rank in the GATE, a free mega workshop on the app. Register for the event on the BYJU'S exam prep app. I am coming live Sunday 29 Jan at 12 p.m. And also guys, 27 January we are live with the GATE Super 11 top 11 questions of every subject for ECEE, IN and CS. And tomorrow, that is Friday. Okay, that is 27 Jan only. Okay, the first session is on digital logic only, right? Digital electronics. The time is going to be 9 p.m. So stay subscribed, and tomorrow join me live at the 9 p.m. Okay, I shall just in a moment share you the link as well for the session. Tomorrow 9 p.m. I am coming live with the Super 11 of Super 11 of digital electronics. Let me just see if I have the link ready. Let me see if I have the link ready. Yes, we do have the link ready here. Yeah. So those who want to join the Digital Electronics Super 11, last moment, everything prepared. 11 expected top questions. Okay, this session is going to provide to you. This is the link of the session. You can set the reminder as well as like the session if you're interested for it. Okay, guys. Okay, guys, and also guys, GATE and ECE test series where very minimal cost, including all full-length test, subject test, is available on the BYJU'S exam prep app. The link is in the description. You can join it up. And now I'll invite Ankit Joshi sir to continue from here. Just a moment, guys.
Morning students, how are you? This is Ankit Joshi. Once again, welcome to this session. Students, after digital circuits, very important questions for this mock. I will be starting the questions from signals and system and followed by engineering maths. So students, yes, happy Republic Day to all of you. Students, very happy Republic Day to all of you. So it's a day of honor for all of us. So let's proceed. Student, this is the brief introduction about me. I have been teaching in this domain since many years, and my subjects of interest are engineering maths, signals and system, and analog circuits. Hence, I am taking here questions from engineering maths and signals and system. One common question to all of you, am I audible to all of you? Is audio and video all fine? Great. So let's proceed. Students, let me remind you about the mega workshop that will be conducted by your favorite Rakesh Talreja sir, and this will be conducted on 29th of Jan 12:30 in the afternoon. But yes, the platform will be BYJU'S Exam Preps app, so you need to download that app. And student, this is relevant for GATE 2024 aspirants, so you can share this information among your juniors. So students, let us start the questions from signal sense system. Meanwhile, I welcome all of you, Ketki Verma, Payesh Kumari, Dreamer, Dr. Science, Rupesh Reddy, Ravi Shankar. All of you welcome to the session. Stay tuned for next 45 minutes to cover the questions from signal sense system and engineering maths. So students, I just request all of you that marks, I have introduced marks along with the questions, so you just note down the question numbers 16 17 from 16 to 28, question number 16 to 28, and just put the number of marks you are getting ahead of this. Okay, so आपको कितने marks मिल रहे हैं वो आप question number के सामने जरूर से लिखिएगा, so that at the by the time I will be leaving this session you would be able to reply me how many marks you scored in my section. Okay, yes, so just note down question number 16 and up to question number 828. Okay, so here are the questions, and just after attempting the question, if you got it correct, put the marks here. If you have not got it correct, just put a cross mark. Okay, yeah, so let's proceed. Students, here comes your first question. So this is an MCQ, it is of 1 mark. The graph of the function g of t rect 4t convolution with 4 times delta 2t. So students, we know the graph for rect t, rect t, rect t, rect t. When rect t is time scaled by a factor of 4, then you will be getting rect 4t. It means rect 4t is the compressed version of rect t. Rect 4t is the compressed version of rect t. So rect t is available from -1 by 2 to +1 by 2. Rect t is available from -1 by 2 to +1 by 2. Okay, amplitude is 1. So this -1 by 2 is divided by 4. You will get -1 by 8 to +1 by 8. -1 by 2 divided by 4, it is -1 by 8, and 1 by 2 divided by 4, it will be +1 by 8. Amplitude will remain same. So this is the graph for rect 4t. But 4t is involved with 4 times delta 2t. Let us simplify this. So the next step will be 4 is already out, and delta twice t can be written as 1 upon 2 delta of t. Delta twice t can be written as 1 by 2 delta t. Correct? This is the time scaling property of delta function, impulse function. Now we are convolving rect 4t with this. Okay, yes. So students, 4 by 2, that will be 2, and whenever a signal is convolved with delta t, result will be rect, that's adjacent signal only. So 2 times rect 4t, 2 times rect 4t should be my answer. So rect 4t is this one. If you multiply it by 2, amplitude will become 2. So this should be the graph. This should be the graph. Option A is the correct answer, students. So those who have got option A as the correct answer, they can just put 1 mark against question number 16 in your list, and those who have got this question wrong, just put a cross ahead of this. Okay, so let's proceed. Let's proceed for the next question. Now I will be hiding myself so that you would be able to see the entire question. Here there is an LTI system given. X of t is the input, y of t is the output, h of t is the impulse response of this system. Consider an LTI system with impulse response h of t delta t minus 2. Okay, input signal x of t to this LTI system is shown below. Okay, this is the input signal. Okay, so what will be the output? Students, we all know that output signal y of t will be x of t convolved with h of t. What is h of t? Tell me. H of t is delta t minus 2. So by time shifting property of convolution with impulse signal, what we can say? The answer will be x of t minus 2. Okay? Yes, sir. So you can just generate x of t. X of t. There is a step signal at 0. Then there is a step at 1. Then there is a step at 2. Step at 2. Now coming on to their coefficients. If you are moving upward, so coefficient will be plus 1. Again we are moving upward by 1 unit, so again the coefficient is plus 1. But at this point of time we are falling by 2 units, so minus 2. Now we want to find out x of t minus 2. We want to find out x of t minus 2. So u of t will become u of t minus 2. U of t minus 1 will become u of t minus 3. And this minus 2, u of t minus 2, further minus 2 will be u of t minus 4. Now tell me which one is the correct answer. This is my final answer. So u of t minus 2 plus u of t minus 3 minus 2 times u of t minus 4. T minus 4 chahiye, correct. So this should be my correct answer, option B. Those students who have got option B, they can just put 1 mark ahead of question number 17. If you got it wrong, just put a cross mark. You will definitely get the PDF of this session as well. My portion you can collect from my Telegram group, Electronics by Ankit Joshi. Next question. See this question. If you observe this graph, this is y of t. So this y of t multiplied by 9. So here at this position, the signal will be 9 times y of t. This is the signal entering here at this adder. Now y of t is the result after integration. So before integration it should be y dash t. Okay, so y dash t is the signal here. Before this integration it should be y double dash t. Okay, now at this adder what is happening? What is actually happening at this adder? इस adder circuit पर क्या हो रहा है? X of t is coming with a plus sign. 9y of t is coming with a minus sign. And the output of adder is y double dash t. So students, y double dash t plus 9y of t equal to x of t. This is actually our input output relation. This is the differential equation representing the input output relation. Understood everyone? Yes. So if you take, see, they have already given that initial conditions are all set to 0. So when you take the Laplace transform, Laplace of y double dash t will be s square y of s, 9 times y of s equal to x of s, correct? So students, if you take y of s common, it will be y of s upon x of s, it will be 1 upon s square plus 9. 1 upon s square plus 9. Comfortable? Yes, sir. Now, this is nothing but h of s. This is the transfer function. Okay, sir. Okay, we are interested in output only, na? Output. So y of s multiplied by x of s. Okay, sir. Now, what is x of t? X of t is having amplitude 1. Rupesh Kumar, previous year we have seen MSQs from engineering maths also. So x of t, can express this in the form of unit step signal, u of t minus u of t minus 2. Just take the Laplace. इसका Laplace ले लीजिए. So Laplace of u of t is 1 by s. Rupesh Kumar, don't speculate wrong things. You do not have the knowledge about the previous year paper, it means. Previous year paper has got questions, MSQ questions from mathematics. I'm not saying about aptitude. Mathematics, engineering math section, there were MSQs previous year. So 1 by s minus e raised to minus 2s upon s. So this is x of s. You can put x of s here. So y of s is 1 upon s square plus 9. 1 upon s square plus 9, and after taking LCM you will get 1 minus e raised to minus 2s by s. This is y of s. Okay, what you want now? क्या चाहिए आपको? See here. Then the Laplace transform of the output of the system at s equal to 1. At s equal to 1 we want Laplace, so it means we want to calculate y of 1. 1 minus e to the power minus 2, and s is 1, so 1 plus 9 will be 10. So 1 minus e to the power minus 2, 1 minus e to the power minus 2 divided by 10. So my answer is 0.0865. So those who have got this answer, at least first 3 digits after decimal, they can put 2 marks for this question. Okay, question number 18, 2 marks. Question number 18, 2 marks. So those who have got this answer 0.0865, they can put 2 marks ahead of their answer. If not, put a cross mark ahead of question number 18. Okay, yes. Next question, students. A system has an impulse response h of n. What is h of n? H of n is 1, 2, 3. Great. Output response y of n. Output response y of n 1, 1, 2, minus 1, 3. Now, let us say the length of h of n is, let us say the length of h of n is m. 1, 2, 3. 3 is the length. Okay, sir. Let us say the length of x of n is L. So length of y of n will be L plus m minus 1, correct? So L plus m minus 1 is given as 1, 2, 3, 4, 5, 5. So students, can you find out L from here? क्या आप यहाँ से L निकाल सकते हैं? So L will be, m is 3, 3 minus 1, 2, 5 minus 2 will be 3. L is 3. L is 3. X of n is unknown for us. We are just assuming it to be ABC. X of n is unknown for us and we are assuming it to be ABC. X of n हमारे लिए unknown है. हमने इसे मान लिया ABC. Okay? Comfortable students? Now, we'll just do the convolution here. Discrete time convolution. What is H here? H कितना है? H is 1, 2, 3. Okay. And X is ABC, correct? Okay, sir. So A, 2A, 3A, B, 2B, 3B, C, 2C, 3C. Just group them together. So you have got your y of n. So y of n's first sample is A, second sample will be 2A plus B, third sample is 3A plus 2B plus C, then we have 3B plus 2C, and at last you have 3C. Now what is the y of n given in the problem? Y of n कितना दिया है? Phi of n is given as 112 minus 13 minus 1. Now student 3c is 3. You can compare. First comparison. 3c is 3. So c will be 1. C is 1. Now A. A is 1. Second comparison. Third comparison. 2a plus b is 1. We want to find out b. So 1 minus 2a. 1 minus 2. B will be minus 1. So x of n is ABC. ABC 1 minus 1 1. And here is the position for 0 pointer. 1 minus 1 1. 1 minus 1 1. 1 minus 1 1. Option B is the correct answer. Option B is the correct answer. How many students have got it correct? Just put it 2 marks ahead of question number 19. Just put it 2 marks ahead of question number 19 if you have got option B as the correct answer. Let's hit the like button if you have not done so. Let's hit the like button if you have not done so. Next. See, Sai Srivastav is asking for the 0 pointer. Student, when 0 pointer is not mentioned in any of the signal, it means 0 pointer is position at the first place. If nothing is mentioned, it means it is at the first place. Oh my God. 1 minus 1 1. Yes, option A is the correct answer. I missed it. I have not seen the 0 pointer. Option A is the correct answer. A is the correct answer. 0 pointer will be at the first position. I actually have missed it. This is the 0 pointer. Here the 0 pointer is at second position. This is wrong. Option A is the correct answer. Option A is the correct answer. If 0 pointer is nowhere mentioned, 0 pointer will be at the first position. See, I marked it here. Okay. While marking the options, I missed out that. So those who have got option A, they have got +2. Next. See, it is an MSQ question for 2 marks. This is the transfer function of a discrete time system. Now, clearly we can say that the pole position is at by 3. Pole at 1 by 3. And 0 at 3. Only one 0 which is at 3. So student, since the pole is at, see, if nothing is mentioned, we are bound to assume it to be causal. We are bound to assume it to be causal. Causal means right-sided. Nothing is mentioned, we have to assume it to be causal. So where is the pole? Pole is at 1 by 3. Pole is at 1 by 3. Pole is at 1 by 3. So if this circle is mod z equal to 1 by 3, system is causal, so ROC will be moving outward. ROC will be moving outward. So we can say that ROC includes unit circle, so system is stable. ROC includes unit circle, so system is stable. ROC includes unit circle, therefore system is stable. Now, what is the 0? Where is the 0? How many zeros are there? Only one. So we can say that this 0 is outside the unit circle. If the 0 is outside the unit circle, that is a maximum phase system. If the 0 is outside the unit circle, it is a maximum phase system. If the 0 is outside the unit circle, it is a maximum phase system. So if you have got option A and B as the correct ones, you can put it 2 marks for this MSQ. Understood, students? Next. Maximum phase can also be called as non-minimum phase. That is also the correct answer. Maximum phase can also be called as non-minimum phase. That is also the correct answer. So A, B, and D. A, B, and D are the correct answers. But it cannot be minimum phase. I was just waiting for this comment. Why not D? That's great. Super. So yes, Rupesh Reddy. Very good, beta. Shabash. So A, B, and D are the correct answers. Very nice. So A, B, and D will give you 2 marks. Next. Student, I just want to remind you that All India Open mock test for GATE 2023, 24th Jan to 30th Jan. Okay. Yes, you can register for this. Don't miss out this opportunity. Assessment is very necessary along with preparation. And the big one, big one. GATE Super 11. GATE Super 11 series is starting 27th Jan. Tomorrow, Rakesh sir will be taking up the first session, and yes, he will be starting with digital circuits. Students, after your paper, you can just watch the exam analysis on our YouTube channel. The dates are 4th and 5th Feb as per your branch paper, and the timing is 1 p.m. and 6 p.m. Timing is 1 p.m. and 6 p.m. Now it's the time to cover the questions from engineering mathematics. Okay, students, question number 21 to 28 will cover 13 marks. So I just remind you to put question numbers 21 to 28 on a piece of paper and marks you scored. Okay, yeah, if it is wrong from your side, put a cross there. Okay, yeah, that's it. Let's proceed. So this is a numerical answer type question for 1 mark. If the particular integral of the differential equation d2y by dx square plus 4y equal to sine 2x is kx sine 2x, the value of k is, yes, so students, we'll just write this in d form, d square plus 4 into y equal to sine 2x. Okay, now I will be writing down the particular integral. Particular integral is 1 upon f of d into right hand side function. This is case 2. Value of a is 2. A square is 4. Minus a square is minus 4. You have to replace d square by minus 4. So once you replace d square by minus 4, it is 0 in the denominator. Case 2 fails. When case 2 fails, just go to the above step, multiply by independent variable x here and take the derivative of the denominator. So derivative of d square is 2d, derivative of 4 is 0, sine 2x. 1 upon d stands for integration. So integration of sine 2x. Integration of sine 2x. Integration of sine 2x. Minus cos 2x upon 2. So you will be getting minus 1 by 4 x cos 2x. So minus 0.25 x cos 2x. You can compare this with kx cos 2x, whatever is given in the problem. The value of k is minus 0.25. So minus 0.25 answer. Numerical answer type question for 1 mark. Those who have got minus 0.25, okay, put 1 mark ahead of question number 21. Next. Proceeds. The mean the mean and variance of a binomial distribution are 4 and 4 by 3. अच्छा जी, so mean is 4 and variance is 4 by 3. Mean is 4, variance is 4 by 3, correct? Okay, sir. So when you put NP equal to 4 here, then you will get Q equal to 1 by 3. If Q is 1 by 3, it means P will be 1 minus Q, that is 2 by 3. So NP is 4, P is 2 by 3. So put P equal to 2 by 3 here. N into 2 by 3 equal to 4. So N will be 12 by 2, that is 6. So we have got the value of N, P and Q. N, P and Q. N, P and Q. N, P and Q. So N is 6, P is 2 by 3 and Q is 1 by 3. So by binomial distribution, P of X will be 6Cx 2 by 3 raised to 6 minus x. 2 by 3 raised to 6 minus x and 1 by 3 raised to what? 6 minus x. 1 by 3 raised to x. Now see the first part. We want the probability for x greater than equal to 1. X greater than equal to 1. This will be 1 minus probability for x equal to 0. This is 1 minus probability for x equal to 0. When you put x equal to 0 here, you will get 6C0, that is 1. 2 by 3 raised to 6 and 1 by 3 raised to 0. So 1 minus 2 by 3 raised to 6. 1 minus 2 by 3 raised to 6. So I guess both of these options are wrong. Option A and option D both are wrong. Now, next we need probability for x equal to 1. Probability for x equal to 1 is involving 1 by 4 raised to 6. This is also wrong because we have 3 in the denominator. Now we go for probability for x equal to 0. So probability for x equal to 0. Probability for x equal to 0 is 6C0, that is 1. 2 by 3 raised to 6 and 1 by 3 raised to 1 by 3 raised to 1 by 3 raised to 0, that is 1. So 2 by 3 raised to 6. So students, we have to manipulate one answer here so that at least we'll get one correct answer. So if this is 2 by 3 raised to 6, then this will be the correct answer. Okay. Moreover, if you wish to manipulate, you can manipulate this option also. From my side, I'm just correcting this. If this is 2 by 3 raised to 6, then this is also correct. Have I done it? Render? अरे मेरे बच्चों, it is NCX. एक minute, we'll make it as it is. That was a blunder from my side. So P of X, a lot of maths going on. P raised to X, Q raised to N minus X. So P of X, N कितना है? 6 Cx. P is 2 by 3. 2 by 3 raised to X. Q is 1 by 3. 1 by 3 raised to 6 minus X. Yes. You're all superb. So now P of X greater than equal to 1. P of X greater than equal to 1 means 1 minus P of X equal to 0. 1 minus P of X equal to 0. 1 minus P of X equal to 0 will give you what? 6C0. 2 by 3 raised to 0 is 1 and 1 by 3 raised to 6. Now this is correct. This one is wrong. Now this is by default, this is wrong. This is 1 by 4. Now P of X equal to 0. P of X equal to 0. P of X equal to 0 कितना होगा? 6C0 will be 1. 2 by 3 raised to 0 is 1. 1 by 3 raised to 6. So Options C and D are the correct ones. Yes, Arnab Malik. Yes, Ravi. Options are correct. So options C and D are the correct ones. Options C and D are the correct ones. Those who have got C and D, they can just push ahead. Okay. Binomial distribution formula. Initially done the mistake. I have written p raised to n minus x. That was a blunder from my side. So C and D are the correct ones. C and D are the correct ones. How many of you got this C and D as the correct answer? Just put 2 marks ahead of question number 22. Now see this. Directional derivative of the function f x square plus y square along a line directed from 0 0 to 1 1. Okay. So d vector will be 1 minus 0, that is I cap, and again 1 minus 0, that is j cap. Now take the gradient of this del f. Del by del x of I cap, del by del x of f, and j cap del f by del y. Z component is not there, so no need to write it. Derivative of x square will be twice x. Derivative of y square will be twice y. And you need to do it, calculate x equal to and y equal to 1. So when you put x equal to 1 and y equal to 1, you will get 2y plus 2j. Correct? Now directional derivative is del f dot d cap. So 2i plus 2j. This is del f at the desired point, and d vector dot product with d cap. So I plus j and its magnitude will be root 2. Correct? Now 2 into 1 is 2. Again 2 into 1 is 2 upon root 2. So 4 upon root 2 means 2 root 2. 2 root 2. .828. Numerical answer type question for 2 marks. Those who have scored this, they have got it. Just put ahead of question number 23. 2 marks if you have got this answer. Next. See this question. This is an MCQ for 2 marks. If the curve C is given by mod of z minus 3 equal to 4, then the value of this integral. Okay. So by Cauchy's residue theorem, I can write this as 2 pi I sum of all the residues. Sum of all residues. Okay. Now mod of z minus 3 equal to 4. Z is x plus iy minus 3 equal to 4. So x minus 3 whole square plus y square equal to 4 square. This is the equation of circle. This is the equation of circle. Okay. Now we have to draw this circle on z plane. We will draw this circle on z plane. This is a question from complex variables, complex integration. So circle's center is at 3, 0 and radius is 4. So center is at 3, 0. This point is 3. Radius is 4. So 4 units left side will be minus 1 and plus 7 plus 4 will be 7 here. So these are the points. Now see this function. Where are the poles? Poles are -2 and +3. -2 and +3. -2 will be somewhere here outside, and +3 is here. So z equal to 3 is inside. Z equal to 3 is inside. Okay. So clearly it indicates that option D is the correct answer. Reason is my answer is not involving pi. Okay. And here options, my answer will involve pi, but these options are not involving pi. Anyways, I will solve it. So z equal to 3 is the singular point. Z equal to 3 is the singular point, correct? So we will be calculating the residue for z equal to 3. Anyways, I will just provide you the solution, right? So not only the answer. So z equal to 3, z equal to 3 is the singular point. So we will calculate residue of a given function is f of z at z equal to 3. Now this z equal to 3 is having index 2, n will be 1. Formula to calculate the residue is 1 upon factorial n limit z tending to a. Here a is nothing but 3, and here you should write d by dz. If it is n plus 1, then nth order derivative will be here, and z minus a, or you say z minus 3, we just write a here. Later on we will put the value of a to the power n plus 1, and then you have to write f of z. So factorial n is 1, a is 3, this can be solved ऐसे भी कर सकते हैं ना. Partial fraction means contour, that is Cauchy's formula. This is Cauchy's residue theorem. So d by dz, z minus 3 whole square. What is f of z? F of z is this entire function, e raised to z upon z plus 2, and z minus 3 whole square. Now 1 upon factorial 1 is 1, limit z tending to 3. Now differentiate this. So quotient rule will be applied. Denominator as it is derivative of numerator, then numerator as it is derivative of denominator upon denominator's square. Now put z equal to 3. So 3 plus 2 is 5. E raised to 3 minus e raised to 3. 5 e raised to 3 minus e raised to 3. 3 plus 2, 5. 5 square is 25. So 4 e cube upon 25. This is the residue. So integration's answer should be 4 e cube by 25 multiplied by 2 pi I. This should be our answer. So as none of the options are matching here, we'll just put here none of this. How many have got this answer? None of this. Next question. Now this is a question from partial differential equation. So you just compare the second order derivatives with the standard format. So del square p upon del x square, its coefficient is a. So a is 1. Del square p by del x del y, its coefficient is 3. So b is 3. Del square p by del y square, its coefficient is 1. So a, b, c are 1, 3, 1. Okay. Now we will calculate b square minus 4ac. 9 minus 4, that will be 5. 5. So according to EPH concept, 5 is greater than 0. It means hyperbolic solution will be there. Hyperbolic. Option C. Option C will be the correct answer. Option C will be the correct answer. So those who have got this question correct, 1 mark for this, 1 mark MCQ. Next question. This is a question from definite integral involving some basics of calculus as well. Now see here, just equate this argument to 0 and find out the breakpoints. It means 0, 1 and minus 1. These are the 3 breakpoints. These are the 3. We'll just draw a wavy curve here. Minus 1, 0 and plus 1. Okay. Rightmost side is positive. Now see, this is x cube minus x. Positive here, negative here, positive and again negative. So students, we have the range of integration from minus 1 to 2. Minus 1 says 0, 0 say 1 and 1 to 2. So you can break this range of integration from minus 1 to 2 into 3 parts. Minus 1 to 0, 0 to 1 and 1 to 2. So mod function in the interval minus 1 to 0 is positive. It will open as x cube minus x. In the interval 0 to 1, it will open as negative. So x cube minus x will be followed by a negative sign. Minus is taken outside. In the interval 1 to 2, it is again positive. Now integrate this. Integration of x cube is x raised to 4 by 4 minus x square by 2. Limits are minus 1 to 0. Then put a minus here. Again x raised to 4 by 4 minus x square by 2. Limits are 0 to 1. Then x raised to 4 by 4 minus x square by 2 and 1 to 2. Comfortable? Ituparna Das is asking for why 2. 2 is the upper limit, but upper limit of integration. Minus 1 to 2. 2 is the upper limit. So for 2, I mark this point. For the upper limit, I mark this point. Okay. Here upper limit is 0. So this part will vanish. Lower limits minus. Put x equal to minus 1. So minus 1 raised to 4 is 1. 1 by 4. Yes, Ravi Shankar, it is wavy curve. Then minus 1 square is 1. It is 1 by 2. then again 1 by 4 minus 1 by 2. Then lower limit is 0. Lower limit is 0. No need to write. See here, x equal to 2. 2 raised to 4 is 16. 16 by 4 is 4. 2 square is 4. 4 by 2 कितना होगा 2. This is upper limit. Now lower limit, x equal to 1. 1 by 4 minus 1 by 2. Okay, see here. 4 minus 2 is 2. 1 by 4 minus 1 by 2. It is minus 1 by 4. So minus 1 by 4 is appearing 3 times. एक बार, दो बार और minus 3 by 4. And outside we have minus sign, so this will become plus. Yes, minus 1 by 4, outside we have minus sign, so plus 3 by 4. So 2.75 should be the correct answer. See here. In order to solve this mod function, first of all, what you need to do? You need to first find out the breakpoints of the argument. Argument means the function written inside this mod sign, the x cube minus x. So after equating it to 0, I got the breakpoint as 0, 1 and minus 1. So I will draw a big x axis. In this, I will just mark these points in the ascending order. First minus 1, then we have 0, and then we have 1. Okay. Now, so starting from the rightmost side, just draw the wavy curve. Wavy curve. This is wavy curve is not the graph for this function. It is just to mark where we have positive, where we have negative values. Like this. So here we have positive. Here we have negative value of the function. Again we have positive, and again here we have negative. So our range of integration is from minus 1 to 2. So we splitted the range of integration from minus 1 to 0, 0 to 1, and then 1 to 2. So 2 will be somewhere here. Now the question arises, in which interval this mod function will be positive and in which interval the mod function will be negative. That idea you can take from this wavy curve. So in the interval minus 1 to 0, it is positive. Here positive. In the interval 0 to 1, it is negative. So here you have to put a negative. In the interval 1 to 2, it is again positive. Okay. So student, the correct answer is 2.75. Those who have got 2.75 as the correct answer, just put 2 marks ahead of question number 26. Next. See this question. My pleasure, Ritu. The matrix A has 4 distinct eigenvalues and one of the eigenvector is 1 1 1 1. Okay. Student, this matrix, find out A transpose. Find out A transpose from this matrix. Convert row into column. 1 2 3 4 will be the first column. Areva, same. Second row into second column. 2 1 4 3. Very good. Third row 3 4 2 1 to third column. Same. So can we say that this matrix is having A transpose equal to A? Since this matrix is having A transpose equal to A, it means it is symmetric matrix. Okay. If a symmetric matrix is having distinct eigenvalues, if a symmetric matrix is having distinct eigenvalues, if a symmetric matrix is having distinct eigenvalues, then its eigenvectors are mutually orthogonal. Okay. So this is x1. x1 transpose into x2. This should be 0. When you have a symmetric matrix, when you have a symmetric matrix having distinct eigenvalues, then its eigenvectors are mutually orthogonal. So x1 is already given. You need to find out that option such that x1 transpose into x2 is 0. Student, if I select option B, then this matrix transpose into this will be 0, correct? See here, 1, 1, 1, 1. Multiply this. This is x1 transpose and this is x2. 1, 1, minus 1, minus 1. The product will be 0. It means option B is the correct answer. Option B is the correct answer. And now the last question from my side. Student, those who have scored, those who have got option B, they can just put 1 mark ahead of question number 27. Here comes the last question from my side. This is an MSQ again from linear algebra, 2 marks. Let A be a non-singular matrix of order 3 cross 3. N is 3. Determinant of A is 3. Determinant of A inverse. I just assume that B is A inverse. So determinant of A inverse will be 1 by 3. Correct? Now, students, adjoint A determinant is determinant A to the power n minus 1. So 3 to the power 3 minus 1, that will be 9. Adjoint A determinant is 9. Option B is the correct one. Now, adjoint of A determinant. Determinant A to the power n minus 1 square. Determinant A is 3. N minus 1, that is 3 minus 1 is 2. So 2 square. So 3 raised to 4. 81. Option C is also the correct one. Now, A inverse adjoint means adjoint of B. So its determinant will be determinant B to the power n minus 1. And determinant B is 1 by 3. 1 by 3 to the power 3 minus 1, that is 2. So 1 by 9. So adjoint of A inverse determinant. Adjoint of A inverse determinant is 1 by 9. Okay. Determinant of adjoint of A is 1 by 9. This is wrong now. So A, B, C are the correct answers. A, B, C are the correct answers. Kate Verma has got it correct. So those who have got it correct, put a 2 marks ahead of this. Now, students, don't go away, because after mathematics, Saket Verma sir will be taking up the questions from his subjects, communication and communication systems and EMFT. Stay tuned. Just a moment. See here, students. First, tell me in the comment box how many marks you have scored. Just put a total, and out of my 13 plus 8, 21 marks. How much marks you have scored? Just comment in the comment box. Students, GATE and ESE test series is already on. Link is given in the description box. You can take the advantage of the same. These are the various features of the test series. 60 plus tests, detailed mock analysis will be there. Virtual calculator utility is also there. More than 4,000 questions. And yes, this test series is being designed by GATE experts in this domain. Thanks a lot for being with me, students. Saket Verma sir will be joining me immediately. Stay tuned. Like this session if you have not done so, and subscribe our channel. I'll just connect with Saket sir. Thanks a lot, students. Thanks a lot.
Hello, good morning everyone. So, welcome to BYJU'S exam prep. So, I hope that you are enjoying this mock test. So, the voice is clear. Yes, happy Republic Day to all of you. I hope that, and this is Basant Panchami also, that is the Saraswati Puja. So, happy Saraswati Puja to all of you also. Yes, Sahil, good morning, Ketki. So without wasting the time, let's start with the questions of EMFT and communication. Okay, so I'm going to discuss with the questions of EMFT and communication, and there will be six questions. Okay, five questions from EMFT and the seven questions from the communication. Right? So are you guys ready? So I'm giving you the first question. So this is the first question for you guys, and I'm giving you 2 minutes for it. Okay, I'm giving you 2 minutes for it. Yeah. So this is the timer for you. Solve this question within the 2 minutes because you are already spending so much time on this mock test. I don't want to waste your time. So we will quickly wrap it up so that in the next 25 to 30 minutes you will start the new subject, that is EDC and analog electronics. So the electric field intensity of a wave is given, one is given in the form of cos, another is given in the form of sine. Good morning, Chinmay. This is Z, na? This is Z. So last 40 seconds. Good morning, Dreamer. So we are having the MSQ session tomorrow, right? So both of you means some of you have got the answer. Amplitude are same, then the circular will come. No, sir. Okay, so all of you are giving answer as C. Okay. So because all of you are giving the answer C, I am stopping it here. And I would like to tell that this is the wrong answer. The correct answer is linearly polarized. The correct answer is linearly polarized, guys. Okay, how? So first of all, you have to convert the both of the signal in the same form. The first one is in the written in the form of a cos, and second one is written in the form of a sine. So you cannot calculate it directly. So first of all, you have to convert it into the form of a cos. So when I will convert it in the form of a cos, then it will become minus beta x and minus pi by 2 plus pi by 2. So the phase will become 0, right? Okay, so sine 90 minus theta is cos theta, so you will write it in that form. Okay, and from here you will say it is nothing but a cos of omega t minus beta x and az cap. So the amplitudes are different. Yes, so the amplitudes are different, that E naught, uh, E naught y is not equal to E naught z. So it may be either linear or elliptical. Okay, it may be either linear or elliptical, that's correct. But if I talk about the phase, then the phase of the z is 0, the phase of the y is also 0, the phase shift is phi z minus phi y, which is 0. So it is integer multiple of pi. Okay, it is integer multiple of pi, hence it is linearly polarized. Okay, hence it is linearly polarized. Yes, so got that. So option A is the right one. Next, now solve the next question. The point P 10 pi by 6 and pi by 3 is converted in the cylindrical coordinate is given by. It is given in the cylindrical coordinate. You have, means it is given in the spherical coordinate. You have to convert it into the cylindrical coordinate. Okay, this is nothing but a spherical, and you have to convert it into cylindrical. So that is r, that is theta, and that is phi. R, theta, and phi. Option D. Yes, option D. Okay, so I will substitute the value of r, theta, and phi, and I will get the value as 2.5. The value of y, when I will substitute all the values of r, theta, and phi I have written, and the value of z I will get 8.66. So once I will get the r, theta, and phi, I will apply the rho is equal to x square plus y square, that is 2.5 square plus 4.33 square, you will get 5, and phi is nothing but a tan inverse y upon x, you will get 60 degree or pi by 3, and the z will remain same, so that is 8.66. Okay, so that is your 5 pi by 3 and this one. So correct answer is option D. Okay, so correct answer is option D. Very simple. First of all, you can convert it into the normal Cartesian coordinate system, and from Cartesian coordinate system, you can convert it into cylindrical coordinate system. Next question. So two isotropic antenna are separated by a distance of 2 times of wavelength. So the given data I am writing 2 lambda is given. If both the antenna are fed with the current of equal magnitude and phase, that means the phase is 0. The number of lobes in the radiation pattern, that is the maximum lobes, maximum radiation you have to find in the horizontal plane. In the horizontal plane. Okay, that means in the horizontal plane means you want to calculate in H plane. So first of all, you will calculate xi, which is alpha plus beta d cos phi. Because it is H plane, I am writing cos phi. So this is 2 pi by lambda, and 2 lambda cos pi. So this lambda lambda will get cancelled and we will get 4 pi cos phi. What is the maximum radiation pattern? The maximum radiation pattern you get when you draw the normalized array factor. So that is nothing but a cos xi upon 2. So when we will put it, we will get cos 2 pi cos psi. Yes. So Dreamer has got the answer. For phi equal to 0, we will get array factor as 1. And then for phi equal to 60 degree, for phi equal to 60 degree also we will get the normalized array factor as 1. Then phi is equal to 90 degree cos 90, that is 0. So cos 0 become 1. So here also we will get 1. So these are giving us the maximum radiation. So you have to check it with the different values of phase where you will get the maximum value. So array factor, you should get the maximum to get the maximum peak or maximum radiation. So for this also, this is minus 1 by 2, so cos pi which will become 1. And then for 180 degree, it is cos pi minus 1, cos 2 pi 1. So here you will get, because we are calculating the mod values, right? So here we have the cos 240 degrees, so normalized array factor as also 1. And now we are having the phi equal to 270 degree. Here also we get normalized array factor as 1. And finally we get the 300 degree, where also we get the normalized array factor as 1. So we are getting total number of 8. 8 times we are getting. Yes. Abhi, Ravi, Ketki, Chinmay, Dreamer. Yes, all of you are correct. So moving into the next question. Read the question. What will be the time delay for a signal to reach the end of a 20-meter long rectangular waveguide with the dimension 2 cross 1.5 centimeter square excited in a dominant mode at the operating frequency of 10 gigahertz? At the operating frequency of 10 gigahertz. 4D upon lambda. Why you want to apply 4D upon lambda? Number of lobes you want to say? Okay. Yes. So that can also be applied. 4D upon lambda can also be applied. Yes, yes. Number of loops, the maximum number of loops, we can find it by 4D upon lambda also. Okay, so let me write one equation for all of you guys. Number of loops, if you want to calculate, then you can apply this formula also, 4D upon lambda, if there is a isotropic antenna. Okay, so 4D upon lambda, that directly give you value 8. Okay, now as we know that the time is equal to distance upon velocity, and we have to calculate the velocity which is group velocity in the waveguide. We can consider the group velocity to calculate the time. So this is the distance which is 20 meter and the group velocity which is Vg. So first of all, we have to calculate the cutoff frequency for the dominant mode, which is TE10. So because it is nothing is given, so we will consider it as a air field. So this is C upon 2A. So 3 into 10 raised to power 10 into 2 into A. A is the longer dimension, which is 2. So this is 2. So we are getting as 3 by 4, which is 7.5 gigahertz. Now let's calculate the group velocity, which is Vp, phase velocity, root over 1 minus Fc upon F whole square. Vp is your 3 into 10 raised to power 8 and root over 1 minus cutoff frequency is 7.5. Operating frequency is your 10 gigahertz. So this is whole square and we are getting group velocity as 1.98 into 10 raised to power 8 meter per second. Okay, so now substitute the group velocity in this time delay. So this is 20 upon group velocity, which is 1.98 into 10 raised to power 8. So the answer is coming as 100 nanosecond. Yes, option A. Now moving into the next question. If you face any problem, then you just ask me, okay? Yes, 100 nanosecond is correct. The phase velocity we want to calculate. In the transmission line, phase velocity we want to calculate. Okay, so it is given that the phase difference between the 2 points is spaced as 2 millimeter apart. So we can calculate the value of beta. Beta is equal to phase shift per unit distance. Okay, so phase shift per unit distance. The phase shift is pi by 4 and the distance is 2 millimeter. So we will get pi by 8 into 10 to the power 3. This is radian per meter. Now we want to calculate the phase velocity. Phase velocity is omega by beta. Okay, so omega is your 2 pi into f. F is frequency. Frequency is 10 gigahertz. So this is 10 into 10 raised to power 9 divided by beta, that is equal to pi by 8 into 10 raised to power 3. So the phase velocity is given as 1.6 into 10 to the power 8 meter per second. So that is our answer, option C. Okay. Now next question. Okay, next question is from communication. So solve this question. Yes, correct, correct. Now solve this next one. No, Abhishek, not correct. So signal to quantization noise ratio is directly proportional to L square. And we know that the bandwidth depends on the number of bit. Bandwidth depends on the number of bit. So this can be written as 2 to the power 2n. Okay. Now think of it. How do you get the relation for the number of bits? Because bandwidth is related to the number of bits. And I am asking you what would be the percentage increase in the transmission bandwidth? Okay, so I am taking this as SQNR new. Okay, I am taking the ratio as SQNR new divided by SQNR for old is equal to L, that is in the new case, and L in the old case. So signal to quantization noise ratio, new and old, we can write new one is 10 raised to power 4.8 and old one is 10 raised to power 3.6. It is equal to the new one means I can write 2 to the power n new divided by 2 to the power n old. Okay, so 12.47, no, not correct, not correct. So I can write it as 10 to the power 4.8 minus 3.6 divided by 2 is equal to 2 to the power n new number of bits in the second case and number of bit in the old case. New means we want, you know, for the desired SNR 48 dB, the number of bit required will be the new one. Okay, so if I take the log, then it is log of 10 to the power 4.8 and this one will be 0.6. Okay, and it is nothing but a n new log base 2 I am writing, okay, minus n old. Is it correct up to this point? So this 0.6 and log base to 10 is your number of bits in the new case minus number of bit in the old case. Now you want to calculate the percentage increase. Okay, so percentage increase, that percentage increase we want to calculate is, because we know that the bandwidth is proportional to the number of bit. So the percentage increase is number of bits in the desired case and number of bit in the old case divided by number of bit in the old case multiplied by 100. So new one is 0.6 log base to 10, the difference, and the old one is given as 12 bits. So this is 12 bits multiplied with 100. So when you are calculating it, yes, 16.67% is the right answer. Okay, Ravi. So that is normal, dB. How do you convert in normal value from absolute value from dB? That is very simple. If something is given in dB, okay, if something is given in dB, then it is 10 log of SQNR, right? So this is given in the 48 dB. So this is 10 log of SQNR. So from here you will get SQNR is equal to 10 to the power 4.8. Coming to the next question. In an angle modulated signal, the modulated frequency is increased from 15 to 30. Then how the signal bandwidth will change? You are increasing the frequency. So very simple. The bandwidth is given by 2 times of maximum frequency deviation plus FM. So whatever will be the delta F, okay, this is suppose first equation, okay, and the new bandwidth, let us suppose bandwidth dash, the frequency is increased by 15, okay, because it is increased from 15 to 30, so it is increased by 15. So now when you will write, this is 2 times delta F plus FM, delta F max plus FM plus 30. So this is the bandwidth plus 30. So that will increase by 30 kilohertz. Very easy. Okay, this is the bandwidth and this is the new bandwidth when you increase the frequency from 15 to 30. So previously the frequency was FM. Now we have increased by FM plus 15. So the bandwidth will increase by 30. Yes, option C. Now solve this. See, this is a MSQ question. Okay, here I have already mentioned that it is a MSQ question. So because it is a wide sense stationary process, because the mean is constant and the autocorrelation is given as function of time, so we can calculate the value of power at tau equal to 0. So at tau equal to 0, we will get the power as 61. Okay, and we want to calculate the AC power. So AC power, we know that it is nothing but a variance. Variance is equal to mean square value minus mean whole square. Mean we calculate at tau equal to infinity. When tau tends to infinity, it is mean. So this is 61 minus 36. Okay, so mean whole square is nothing but limit tau tends to infinite and autocorrelation. So this is 61. So here you will get 25 watts. So the correct answer is option D. And it is a wide sense stationary. So answer is option C and D both. Yes. Okay. Because wide sense stationary we have directly seen the mean is constant and the autocorrelation is function of time delay. Next one. Consider the following cascaded binary symmetric channel. Determine the channel capacity. Okay, is it okay now? So what is the channel capacity for binary symmetric channel? For binary symmetric channel, we know that this is 1 plus P log base 2P and 1 minus P log base 2 1 minus P. So we have to calculate the overall probability. So overall probability is 1 minus P, P, P and 1 minus P, right? So here how, because these are the binary symmetric channels, so we can directly multiply it to calculate its overall channel matrix. So when we will multiply, this is 0.7, this is 0.3, 0.3 and 0.7. When we will multiply, we will get the 0.62, 0.38, 0.38 and 0.62. Okay, so from here we can see that the probability is P is 0.38 and 1 minus P is obviously 0.62, and substitute these values in the channel capacity, which is 1 plus 0.38 log base to 0.38 plus 0.62 log base to 0.62. So when I calculate this, I get the answer as 0.042. The channel capacity is 0.042. Okay, so if you have forgot the concept, then just go and revise because you have already notes with you. Then just go and revise. Now solve this question. So first of all, we are converting the analog signal into digital, and that digital signal is transmitted using the M-array PSK technique. So we know that when we use the PCM technique to convert the analog signal into digital, then the bit rate is given by NFS, and because the number of quantization levels are 16, so we will require 4 bits and the sampling frequency is 40, so we have 160 into 10 raised to power 3 as bit rate, bits per second, 160 kbps. And because we are now transmitting it through the M array PSK, so the bandwidth requirement for the M array PSK with the raised cosine is RB and 1 plus alpha. Okay, so we have the 2 RB and RB is replaced by RB by 2 1 plus alpha. Then this is log base 2M. So the bandwidth is given as 110. So this is 110 into 10 raised to power 3 and the bit rate is 160 into 10 raised to power 3 and 1 plus the roll off factor is 0.3 again, and here we have the log base 2M. So we want to calculate the minimum number of M. So the value of M here is, when you calculate, you will get M is equal to 4. Okay. So how I have got this formula? This is M array PSK for raised cosine. Remember that I am writing it for the raised cosine because this is raised cosine pulse is given. Yes, 4 is the right answer. Absolutely right. Next. This is a numerical answer type for 2 marks. Okay, let me give you some more time for it. One seven four nine. Yes, Rupesh, absolutely right. Okay, so first of all, you have to calculate in such type of question. You know that if the q of root 20 is given, that means definitely this will be the probability of error for certain value, right? So we have probability of error here. So nothing we have to do here. We know that the expected number of bit errors. So expected number of bit error is nothing but a probability of error, the probability at which you are making an error, and the rate at which you are transmitting the data. And because it is bits per second, so in one day you want to calculate in one day, so how many seconds are there in one day? So this is 86,400. So the probability of error is 4.05 into 10 to the power minus 6. Bit rate is 5000 and this is 86,400. So the answer is coming as 1750, approximately 1750. Okay, 1750 rupees. Yes, because we know that in such type of question, because when the q function is given, then we know that this will only be coming as probability of error, because when you calculate the probability of error by q of root over 2 EB upon TB, 2 EB upon N naught, then at the end you will get q of root over 20. Okay, so you can calculate the EB, right? EB is nothing but a square TB by 2. So this is a square TB by 2, or you can write a square upon 2 RB. So you can calculate the value of EB. N naught is directly given. When you will substitute all the values, you will get Q of root 20. Okay, so that Q of root 20 is probability of error, and its value is given as 4.05 into 10 to the power minus 6. That is why we can directly use it to save the time. Next. So because in this question we want to calculate the transmission efficiency, and you know that the transmission efficiency is given as k square Sx upon 1 plus k square Sx, where Sx is the signal power and k is the value of constants, right? So the k in case of standard square law modulator is given by 2 times a2 upon a1. A2 is the coefficient of square term, so that is 2, and A1 is the coefficient of linear term. So here we get 1 upon 2, and the Sx is the signal power. The message signal has the power 16 watt. So this is 16 watt. So when we calculate eta here, this is k square, which is 1 by 2 square, into Sx, which is 16, divided by 1 by 2 square into 16 plus 1 multiplied with 100. So when you calculate it in the percentage, you will get 80%. Right? So the answer will be option C. Okay. So this is how you have to solve the questions of communication in EMFT, and yes, option C. So that formula we have already learned. So now we will meet tomorrow with the session of MSQ. Okay. So there is a MSQ session tomorrow at 9 p.m. So there we will be solving the questions of communication again. So come live tomorrow. Okay. So this is the Super 11 series that we are going to start, and this is starting from tomorrow. And here also I will be taking 31st January. Okay, I will be taking the Super 11 series on the 31st January. So 31st January timing you will see in the channel itself. So don't forget to subscribe the channel right now, because we are coming with the Super 11 question. Now, and you also know that there is a GATE 23 exam analysis in the channel. So when you will come from the GATE examination, you can also put your questions in the comment section when we will be coming live. So you guys can tell us the questions which you can remember during the exam, and you can also cross check your answer. Okay, and there is a GATE and ESE test series running. So the link is given in the description. So you can go there and check everything with whatever you want. Everything is there in the description. Okay. So thank you for watching this session. And now the Sanjay Rathi sir will be coming live with the questions of EDC and analog. Okay. Thank you.
Hello everyone, very good afternoon and happy Republic Day. Welcome to the BYJU'S exam prep, India's most comprehensive app for all exams. Let me know that sound quality, picture quality, everything is fine. Very good afternoon, Ravi Shankar, Chinmay Roy and Ketaki. How are you? And thank you, Saket sir. Yes, now I think the sound quality, picture quality, everything is fine. Okay, guys. And now I am here to discuss what questions from EDC and what analog. And we are going to discuss very important numericals from EDC as well as from analog. All type of question, that is what MCQ, numerical answer type question, and multiple select question, that is MSQ. Okay, Ketaki. Now, already you have solved questions from what digital, apti, and what signal and system, and now communication. Now, time for what EDC and analog. Okay, so this is a GATE mock test. Now, electronics and communication engineering, we are here to discuss 100 marks question, 30 questions from 1 marks, 35 questions from 2 marks. So please everyone like the session, share the link of this session, and most important, subscribe our channel so that you will get the notification, all the PDFs and all the links is given in what description box. Okay guys, and this is my introduction. Myself Sanjay Rathi. I am having around 21 plus years of teaching experience. I have qualified and selected for engineering services exam that is conducted by UPSC, AIR 16 in ESE 2005, AIR 21 in ESE 2008. अब इसमें मॉक टेस्ट का क्या रोल है, राइट? तो मॉक टेस्ट will play a crucial role in your selection. Okay, with mock test we are getting idea about the time management, which are our strong points, which points are weak points, so that we can go through detailed notes, short notes, and we can work on it. Okay guys, so let's start. And this is a mega workshop, 7 golden rules to secure a single digit rank in GATE 2024 by Rakesh Talreja sir, MTech from IISc Bangalore, your favorite, 11 plus years of teaching experience. तो अपने जूनियर को बोलिए ऑन 29th जनवरी एट 12:30 PM. ओके, आप कोई भी प्रिपरेशन स्टार्ट करने से पहले एक जान लीजिए कि स्मार्ट वर्क क्या है. तो यू विल गेट द आइडिया अबाउट द 7 golden rules to secure single digit rank in GATE 2024, and this is very important workshop, right guys? Now I'm going to start what electronic devices and what circuit and important numericals. Now first one, please everyone find the value. This is 1 mark question. I'm going to start what timer. Okay, so take your 1 minute. I'm giving you 1 minute and give me the answer in comments box, everyone. For a given circuit, ID is equal to 80 microampere for fixed value of R and VD. Let NMOS has VT is equal to 0.6 volt. Mu n COX K and S is equal to 200 microampere per volt square. L is equal to 0.8 microampere. W is equal to 4 microampere. The value of R is equal to. Okay. Everyone try to give me the answer. Dreamer, Ketki, Ravi. And questions on all the topics. MOSFET, BJT, PN junction, semiconductor. Okay. Operational amplifier. Then try to give me the answer. Okay, everyone. Take your time and give me the answer. Give me the answer. What is the answer for this question? This is a simple MOSFET. Drain is connected to gate and this is a E-MOSFET, okay? Because the threshold voltage is given here and it is called insulated gate field effect transistor. And new students, please watch our session on what MSQ, multiple select question, right? This is a new pattern, that's why they will give you some easy questions on what theory, but if you have the idea about each and every point regarding particular topic, important topic, then you will be able to solve what MSQ. Shruti, very good afternoon. Now, everyone tell me what is the answer for this question. 1 minute already over. Next 1 minute. No comments. Everyone, please try to give me the answer. For the given circuit, ID is equal to 8 microampere. Anyone? Next 30 seconds. $26.5 and Rupesh Reddy is given 14.25. So Ketki Verma and Rupesh. Any other student, please give me the answer. Okay. Now time up. Already 2 minutes gone. Now, what is the solution for this question? First of all, watch this diagram. Remember, this is in what? In saturation. Why? Because drain is connected to what? Gate terminal. When the new students, please try to understand, when the drain is connected to gate terminal, always remember VD is equal to VG. Means VD is equal to VDS is equal to what? VGS. Or if these two are equal, definitely we can say VDS is greater than what? VGS minus VT. And if this condition is satisfied, then we can say it is in saturation. Second, suppose you can say, sir, it may be in cutoff. Yes. If suppose we are saying that it is in cutoff, let cutoff. Then what is the ID? ID will become 0. When ID will become 0, what is the drop across the R? 0. Then it will become VDS is equal to VGS will become 3 volt and 3 volt is greater than VT. 3 volt is greater than VT and that's why it is not in cutoff. So Vishal has given the right answer, I think. Badri, Vishal Badri, yes. So it is not in cutoff because when I am taking a ID is equal to 0, the VDD, that VDS, this is called VDS, will become 3 volt and that's why the VGS will become 3 volt and this is greater than what? VT. That's why it is not in cutoff. Now VDS is equal to VGS and therefore it is in saturation, not in triode. So first condition, let it is in saturation. What is asked here? You have to find the R. R means if you have the value of VDD, you have the value of VDS upon what? IDS. Then you can find the value of R. So we have the value of VDD 3 volt. We have the value of IDS that is given 80 microampere and then we have to find the value of what? Only VDS. Or VDS is nothing but VGS. Now you can write the formula for current. IDS is equal to half of mu n COX W by L VGS minus VT the whole square. That is the formula. What is the IDS given? 80 microampere. Half of. What is the mu n COX? That is the K and dash is given as 200 microampere. 200 microampere. What is the W? 4. What is the L? 0.8. You have to find the VGS. That is nothing but VDS minus 0.6 square. Now from this you can find the value of what? VGS. Now what is the precaution here? Try to understand. This is the 100. This is what 400 divided by, that is what we can say simply 400 divided by 0.8. 10 cancel out, and then you will get please everyone calculate VGS minus 0.6 square is equal to what? 0.16. When I am taking the root of that 0.6, it will become plus minus 0.4. Now what is the value of VGS? We are going to get the two values of VGS, 1 volt and what? 0.2 volt. Always remember, since it is not in cutoff, we have to drop one value. We have to drop one value. Which value? You have to drop the 0.2 because it is less than what? Threshold. Less than the threshold value. That's why drop the 0.2, consider the 1 volt. When I am considering the 1 volt, then what is the value of R? This is the 3 volt minus 1 volt divided by what? 80 microampere. 80 into 10 raised to power minus 3 milliampere. 2 into 1000 divided by 80. Now you can calculate 200 divided by 8 is nothing but 25 kilo. No need to use the calculator. No need to use the calculator, virtual calculator, not required. So Ketki, why you are confusing? Sir, Kn value was confusing 1 by 2 factor. My dear friend, Kn dash it is given now. So what is the standard formula? Kn dash, that is nothing but mu and COX. That's why it is written in bracket, and this is 200 microampere per volt square. 200 microvolt per volt square. Otherwise, remember, they will mention you the formula. They will mention you the formula. By default, you have to take this formula. Otherwise, they will mention like this. K VGS minus VT the whole square. That is the formula. In that case, K will become half of mu n COX W by L. Complete K. That is the K is the constant. That is a half of mu n COX W by L. They will definitely mention in the question. Don't worry about that. Okay then. Next one everyone. Next question. This is a very, very important one. Second question. Okay, I think no doubt 25 kilo ohm, no doubt. You got the idea about the cutoff. You got the idea about the saturation. You got the idea about the triode region. Some question taking 0.5 into K and S2, sir. Yes, Vishal. Means kya hai? Means I'm giving you. Normally, where is the confusion? For example, 1 minute. Give me 1 minute. Give me 1 minute. Yes. Okay. Now everything is fine now. Okay. Sometimes they will mention like this. You are saying that, sir, Kn include, but it is written as what? Kn. This is half of mu n COX in that case. Or sometimes they will include what? W by L. So don't worry about that, no doubt. In the previous year, sometimes there is an ambiguity. Okay, Vishal? Ambiguity. So don't worry about that. This time they will mention. Otherwise, marks to all. Marks to all type of question. Marks to all. Second thing, empty ho jayega. Second one, sometimes if it is a MCQ, they will provide you the 4 option. According to the 4 option, if it is MCQ, not in numerical answer type question, not in MSQ. In MCQ, they will provide you the ABCD. Only one option is correct. If suppose I am taking the K and S, K and S is equal to only what? Mu and COX. Or some student will take the K and S is equal to half of mu and COX. So my dear friend, when I am taking this value, if I'm not getting the 4 options, then you have to choose this value. Then you have to choose what? This value, because in this case, what will happen? You have to choose what? Best answer. Best answer. Or in my question, there is no confusion. Why no confusion? Because already it is given. Mu n COX, that is equal to K n des. Half is not written here. That is equal to K n des. Okay, next question. Next. Consider a bar of n-type semiconductor on which light is incident, such that in steady state there is a spatially uniform generation of electron hole pair. Okay. If the generation rate is 3 into 10 raised to power 21, and if the whole lifetime is 3 microsecond, that is the normally in yesterday I have discussed MSQ, where I have given the range of what? Lifetime, mean lifetime. So that is in the range microsecond. Determine the excess hole density in the semiconductor. Everyone, this is a numerical answer type question. Numerical answer type question. Everyone, try to give me the answer. What is the answer for this question? Yes, please. बोलिए जरा क्या होगा? सॉरी, देखिए जरा आप कितना टाइम लगाते हैं. आई विल गिव यू 1 मिनट. बस फॉर्मूला बेस्ड क्वेश्चन. 9 into 10 raised to power 15. Okay. We can solve within 30 seconds. Yes, Ketki. We can solve this question. It is a, consider a bar of n type. Simply it is a bar is given. Everyone try to solve this question. That this is a bar on which light is incident such that steady state there is a sparsely uniform generation of electron hole pair. We are giving the light. This is the light. And there is a generation. What is the generation rate into lifetime? So what is the excess hole concentration? That is represented by this. Excess hole concentration is given by generation rate into what? Tau p. Generation rate into tau p, or simply we are saying that generation rate is excess hole concentration upon what? Tau p. So what is this? 3 into 10 raised to power 21 into 3 into 10 raised to power minus 6. So it will become 3 into 10 raised to power 15. 3 into 10 raised to power 15. So what is that? The excess hole density in the semiconductor is. That is what? 3 into 10 raised to power 15 centimeter per centimeter cube. That is the answer. I think now it is clear, everyone. Yes, please. Now it is clear. Okay then. Next question. तो आपने कितने लोगों ने दिया आंसर? कितने लोगों ने दिया भाई? केतकी वर्मा, your answer is correct. So everyone please try to give me the answer in comments box. Very simple question. You have to simply multiply and use this formula. Next one. Yes, that is the question. Everyone try to solve this one. The longest wavelength that can be absorbed by silicon, which has the band gap of 1.12 electron volt, is 1.1 micrometer. That is about the silicon 1.1 volt, 1 micrometer, 1.1 micrometer. That is called cutoff wavelength. If the longest wavelength that can be absorbed by another material is 0.95 micrometer, then the band gap of this material is. Very simple formula for band gap. Everyone please try to give me the answer. Think about the formula, right? Cutoff wavelength. Cutoff wavelength. और एक बार जरा भाई अब स्टार्ट होगा एडीसी का मेन इंपॉर्टेंट क्वेश्चन. ये तो दैट इज जस्ट फॉर वार्म अप. नाउ एक बार जरा आप सभी अपने दोस्तों को बुला लीजिए, शेयर कर लीजिए इस लिंक को, और एक सब्सक्राइब कर लीजिए हमारा चैनल. नाउ द लॉन्गेस्ट वेवलेंथ दैट कैन बी एब्जॉर्ब्ड बाय द सिलिकॉन which has the band gap of 1.12 electron volt, right? Ketki has given the answer 1.27 electron volt is the unit is what? Electron volt. Okay. 1.24 by lambda. Yes. Now, normally we are saying EG, HC, H nu or HC by lambda. This is the formula, my guys. Okay. And when we are putting the values of Planck's constant, values of C, that is 3 into 10 raised to power 8 meter per second, Planck's constant, and then we are getting what? EG is the band gap in electron volt. So when we are converting it, we are getting the answer. But remember here, two things is given here. One is given band gap and one is given what? Wavelength, right? But other, no need to use the constant. You can use direct constant, and directly we can say what is the relation between lambda and EG. So in second case, 0.95 lambda is given. So EG is equal to, proportional to what? Lambda. We can say EG2 by EG1 is equal to what? Lambda 1 by lambda 2. Am I correct? Am I correct? EG2 by EG1 is equal to lambda 1 by lambda 2. Now, in first case, what is the lambda 1? 1.1 micrometer. Yes. Upon, what is the lambda 2? 0.95, means decreases. 0.95. If it is decreases, then EG2 will increases. So what is the EG2 will become 1.1 divided by 0.95 into EG1. And what is the EG1? 1.12 electron volt. 1.12 electron volt. Simply multiply. Directly use this formula. Okay. तो चलिए कैलकुलेटर यूज कीजिए और आगे आंसर आपका सबका. What is the answer? Guys, that is the method. Okay. Okay, everyone, you are getting the 1.3 nearly equal to, then right. That is right. And Rupesh, you have given the formula. That is true. When we are saying EG, that is in electron volt, or sorry, lambda cutoff, when we are saying 1.24 divided by what? EG. Here EG you have to use in electron volt, and lambda will be in micrometer. Lambda will be in micrometer. This is called cutoff wavelength. Right, cutoff wavelength. Okay then. Next question. Now tell me, if alpha is equal to 0.99, please read question carefully, na? If alpha is equal to 0.99, beta is not given. VBE 0.7 volt, the value of R1 in the circuit shown for an emitter current of I minus, it is minus given, minus 2 milliampere. So what is the direction of the I? Upward. Direction of IC upward. IB inside, IC inside, I inside. And this is the NPN transistor. I is given. What is the question? The value of R1 in the circuit shown for an emitter current I is kilo. Neglect the reverse saturation current. Means in this question simply you have to find the value of R1. Value of R1. And everyone tell me, what about the transistor? It is in cutoff, it is in active region, or it is in saturation region? First question, give me the answer. It is in cutoff, active, or saturation. Then you can solve this question. Simply you have to find the value of R1. Cutoff, active, or saturation. Ravi Shankar, beta is equal to alpha upon 1 minus alpha. Is it required? Is it required to find the alpha or beta? You have to find the value of R1. Everyone take a screenshot. I'm going to start timer. Take your time. I'm going to give you the 2 minutes. Okay. देखो, this is just like an exam hall. In exam hall, we can't every time we can't stop what we can't start what stopwatch, but we can keep eye on what or a watch. So they will positively it will count. 30 second over, 1 minute over, or 2 minute over, and that is the counting. Everyone. So within 2 minutes you have to solve this question. Take your time, maintain accuracy. Yes, please. Okay, 20. You are giving the 20. Okay. If the alpha is equal to 0.9 and VB is 0.7, the value of R1 in the circuit shown for an emitter current IE. Now already 2 minutes over. Now I am going to solve. Everyone, if try to solve and give me the answer. Give me the answer in comments box. Okay. Then try to understand. To solve this type of question, first of all, watch this question. R1 is required. If a known resistor is required, you have to find the voltage at this point. And this voltage is called VC. This is because it is a collector terminal, and this voltage is called VB. This is called base terminal. Now, try to understand. What is the current here? IC. What is the current here? IB. Let this current is I1. I1 is the current through the R1. And let this current is I2. I2 is the current through the R2. Then you have to find the value of VC. You have to find the value of VB. And divided by what? I1. Divided by I1, you will get the value of R1. That is the method. First equation. Now, what is given? IE. IE is given as minus 2 milliampere. Yes, in NPN transistor, in NPN, the direction of IE is actually outward. Base current inside, collector current inside, emitter current outside. But it is given inside, and that's why its negative value is given. So already I have given the hint in the diagram, the 2 milliampere outside. Yes, that is the right direction. So 2 milliampere outside. So we can say IC plus IB is equal to what? 2 milliampere. IC plus IB is equal to 2 milliampere. 2 milliampere. IC plus IB is equal to 2 milliampere. Now, my dear friends, in active region, there is one equation. What is the equation? IC is equal to what? Alpha I. But this equation is valid when the direction is given downward. When the direction is given downward. But actually, what is the given direction? Upward, and that's why we have to use this formula, minus alpha I. Minus alpha I. So what is the alpha? Minus 0.99 into what? Minus 2. Minus minus it will become plus, and IC is equal to 1.98 milliampere. 1.98 milliampere. No need to find the beta. Directly you can find the alpha, and that is the right direction. 1.98. So what is the value of the IB? IB will become 2 minus IC, that is nothing but 0.02 milliampere. 0.02 milliampere, that is the value of the base current IB. Once you will get the value of IC, once you will get the value of IB, okay, no issue. Now, what is the voltage at this point? The question in given VB 0.7 volt. So 0.7 volt, this is the value of VB. So what is the voltage at this point? What is the value of the VB? Now you can find the VB is equal to VB 0.7 plus 2 into, always convert it into kilo ohm, 0.1 kilo ohm. 100 ohm means 0.1 kilo ohm. 0.7 VB plus what? 2 into 0.1. You will get 0.9 volt. That is the value of what? VB, base terminal voltage VB. In this equation already we got the VB. Now, once you will got the VB, you can find the value of I2. What is the value of the I2? VB minus 0 upon 20 kilo ohm. It will give you the I2. So what is the value of the I2? VB minus 0 or VB minus 0 upon R2. This is nothing but 0.9 divided by 20. You will get 0.045 milliampere. This is the value of I2. This is I1. Okay. Now, what is the I1? IB plus I2. So, I1 is equal to IB plus I2. That is 0. What is the value of the IB? 0.02 plus 0.045. And now I1 is equal to 0.065 milliampere. 0.065 milliampere. Okay. Now second, I1 got VB. This is the VB 0.9. And what is the I1? This is the I1 0.065. Now what is required here? VC. What is the voltage at this point? VC. Now we have the two methods to find the VC. You can apply the KVL from this point to this point, but we have no value of the R1, no idea about the R1. You can apply the KVL from this point to this point, but we have no idea about what VC. We have no idea about the VC. Then my dear friend, what is the current here? We have the current IC plus I1 here. This is the IC and this is the I1, the current. And that's why we can say VC is equal to 12 minus 3.3 into IC plus I1. So this is the IC plus I1 and this is the VC. So what is the VC is equal to 12 minus IC plus I1 into 3.3. And then it will be called 12 minus, what is the value of the IC? 1.98. 1.98 plus, what is the value of the I1? 0.065 into 3.3. Everyone check this value and give me the answer. I think you will get 5.25 volt. Nearly equal to 5.25 volt. Check my calculation. That is the calculation part. Right. Sorry, VB, sir, VB is equal to 0.5 volt means Sibu. Which 0.5 volt? VB. Why 0.5? 0.9, no? 0.7. This is the 0.7. 0.7 plus 2 into 0.2. That is the 0.2. So this is adding. We are adding. We are applying what? KCL. We are applying the KVL. Sorry, from this point to this point. So 0.7 plus 0.2, it is the value of VB. It is the value of VB. Now it is correct. Why you are subtracting? Why you are subtracting? You have to add this value 0.7 plus. Okay. What is the value of I? Minus 2 milliampere. If suppose you are writing in opposite direction again, minus 2. What about the direction? I is given in this direction. So I is minus 2 milliampere means what is the current in downward direction? In downward direction it will be 2 milliampere. In downward direction it will be in 2 milliampere, my dear. It's symbolic, it is correct. Okay, there is a, okay everyone, first of all 5.25. Yes, there is a problem. Try to understand. If this is given in BJT, for example, if it is given IC, right direction, it is given IB, right direction, it is given IE, right direction. This is the 2 milliampere. Okay, no problem. But in the question, what is the direction of IE is given? This is the direction is given IE. And that's why IE is given as what? Minus 2 milliampere. So what is the direction of the current? Actually it is downward like this. It is the downward. And that's why we are saying that it is 2 milliampere. I think now it is correct. Now it is correct. Because in NPN transistor, it will not allow the current in opposite direction. It will not allow the current in opposite direction. Okay. Then 5.25. Now we have the value of the VC, we have the value of VB, we have the value of I1. So what is the value of the resistor? VC 5.25, VB 0.9, 0.065. Everyone give me the answer. Very, very simple question. Around you will get the 62 something. Please check and give me the answer. So that is the method. In this way we can solve this particular question. Right? Okay, next question. Next one. That will be in kilo ohm, na? That will be in kilo ohm. So sometimes they will not provide you this one, na? They will not give you the value. This is not given. You have to decide. Only the value of IE is given. Value of IE is given, that is minus 2 milliampere. That means what is the downward current? 2 milliampere. Downward current 2 milliampere. Okay, then next one. Now next question on MOSFET, 2 marks question, numerical answer type. तो अपने marks भी count करते रहिए भाई. This is a self test. Write down your marks. You are getting yes or no. The PMOS transistor in the circuit in figure has VTP is equal to minus 0.5 volt. This is on PMOS. Again, that is the question on what? PMOS. Yes, please watch this one. This is the PMOS. RS. VDD is given as 1 volt. Here it is the VS. Here it is the VG. VG is connected to the ground. VD. VD is 0 volt. It is given. VD is given as 0 volt. Then ID. ID, this is the actually in MOS, this is the current of the ID. Current is not given, but always remember from source to drain. What is the ID? 0.1 milliampere. The PMOS transistor in the circuit in figure has VTP is equal to minus 0.5 volt. KP dash is given 100 microampere per volt square. W by L is given. Lambda is given. The value of RS is, again here KP dash. I am explaining you the KP dash is nothing but mu p COX. You have to use the half here. Mu p COX. Okay. What you are saying that, sir, for symbol we can identify? Yes, Sibu. If suppose nothing is given with the symbol, we can say it is what? PMOS. Now, what is the value of RS? You have to find the value of RS. Okay, guys. Now try to understand how we are going to find this value. First of all, you have to find the value of VSGP. This is called VSG. Once you will get the VSGP is nothing but VSG, that is the VS minus VG. That is nothing but VS. Why? Because VG is 0. Okay. Now, once you will get this value, you have the value of the ID. So, what is the value of RS? RS is nothing but VDD minus VS upon ID. VDD minus VS upon ID means we have to find the VS. Okay. Now, what is the value? Try to understand in case of PMOS. In case of PMOS, how we can judge whether it is in a triode region or saturation region? Because it is not in cutoff. Current is not 0. And that's why it is not in cutoff. So, how we can judge it is in triode region or saturation region? So, you have to check what is the value of VSG, right? And what is the relation between VSD? If VSD is greater than VSG minus mod of VTP, then we can say it is in saturation. Then we can say it is in saturation. Okay. So what is the value of VSD? VD is given as 0. VD is given in the numerical, it is given as 0. So what is the VSD is equal to VS minus VD, that is nothing but VS. What is the VSG? VS minus VG, that is again VS. It means VSD is equal to VSG. VSD is equal to VSG. So 100% sure that VSD is greater than what? VSG minus of mod of VTP. And that is the standard formula. You have to put the mod here. Means that condition is satisfied and that's why it is in saturation. Once you will find that is in saturation, directly you can use this formula. 1 minute. You can use this formula. ID is equal to half of KP dash W by L VSG minus mod of VTP the whole square. What is the ID is given? ID is given as ID 0.1 milliampere. Half KP dash. What is the KP dash is given? 100 microampere. Convert it into milliampere, 0.1 milliampere. What is the W by L? It is given 20. And when the lambda is 0 means early effect is negligible. early effect is negligible. You have to find the VSG minus mod of VTP. What is the mod? VTP is given minus 0.5. You have to use the 0.5, the whole square. Now from this you can find what? This is cancel out, 0.1, 0.1 cancel out. This is 10. It will become 1 by root 10 is equal to VSG minus 0.5. From this find the value of VSG. 0.5 plus minus, this is the plus minus 1 by root 10. You have to use the positive value, otherwise it will become less than what? Threshold value. Less than threshold value. So what is the plus? Use the plus value and you will get the value of what? VSG. Right? Everyone give me the answer. What is the value of the VSG? Okay. Once you will got the value of VSG from this formula, put here 1 minus VSG upon 0.1, you will get the value of RS. That is the method to solve this particular question. Okay. So how many students are able to get the answer? Okay, that method is clear. No need to convert it into what? NMOS. Simply you have to use the formula for what? PMOS. Okay, next question. Next, I think complete hint. Okay then. So my dear friends, this is the All India Open Mega Test for GATE 2023 is waiting for you, and this is the time to give what? 1 or 2 or 3 full length mock test, right? So that you will get the idea about your strength, about your weakness. You will how to maintain the accuracy. You will get the idea about that, and how to maintain the time. That is more important. So this is for you, All India Open Mega Mock Test for GATE 2023 on 24th January to what? 30th January. You can register on our official website on our app. Okay, you can register here. And my dear friends, we are going to take very important series, that is GATE Super 11, top 11 questions of every subject from 27 Jan 2023. Subscribe our channel now. Okay. So yes, Ketaki, you are getting the 8.16. Everyone, you are getting this answer. So calculation is your part. You can calculate it. Now next question. And this is, my dear friends, on from 4th and 5th Feb, from 1 p.m. to 6 p.m. complete a GATE 2023 exam analysis for electrical student, for electronics student, and for what? Computer science. Just after the exam, right? So subscribe our channel so that you will get the notification, and don't worry about the results. जो भी आपने क्वेश्चन बनाया है तुरंत उसके साथ ही डिस्कशन हो जाएगा, आपको पता चल जाएगा कितना आपका सही है कितना गलत है. बट अभी आप उसकी परवाह मत कीजिए, अभी तो आप पेपर देने पर फोकस कीजिए, मॉक टेस्ट दीजिए. ओके, ये डेट नोट कर लीजिए, सब्सक्राइब कर लीजिए, नोटिफिकेशन ऑलरेडी आपको मिल जाएगा. देन माय डियर फ्रेंड्स, आई एम गोइंग टू स्टार्ट व्हाट? एनालॉग इलेक्ट्रॉनिक्स. एनालॉग इलेक्ट्रॉनिक्स, यस 1.84. यस यस यस. अरे चेक करो भाई कैलकुलेशन, अदरवाइज मैं कैलकुलेशन करूंगा उसके बाद. चलिए मैं कैलकुलेशन कर लूंगा. प्लीज गिव मी द आंसर फॉर दिस वन एवरीवन. Ketki, you are giving the 8.16 volt. Then in that case, what will happen? I am having the 0.1 milliampere current, and the drop will become 0.8 volt, and then it will maintain the saturation region. Please check that. It will maintain the saturation region. Okay. Ravi Shankar sir, for afternoon session batch. हाँ, तो for forenoon as well as for afternoon we have one electrical, one electronics. So we will do the complete analysis in the same on the same day, Sunday. Okay. And Saturday I think CS, computer science branch. What is the answer? An amplifier with gain 1000. Only 1 minute. Only 1 minute. What is the answer, my dear friends? बताइए जरा. An amplifier with gain 1000 has a gain change of 10% due to temperature. What is the change in the gain of the amplifier with negative feedback and feedback factor beta is equal to 0.1? This is a simple MCQ, multiple select question on feedback. with feedback, without feedback, the gain is given as 1000. Change in gain with respect to what? Temperature. Is given as 10%. That is the variation. Very high variation. Very high variation. When we are saying that 10% variation means 1000 plus minus 100. 1000 plus minus 100. Very huge variation. And to reduce this variation, we are using the negative feedback. So what is the answer? What is the answer? Then what is the change in the gain of the amplifier with negative feedback and feedback factor beta is equal to 0.1? Okay. Now in this question, we will use time over. What is the change in gain with feedback is given by change in gain without feedback divided by desensitivity. So what is the change? 10% divided by what is the gain? 1000. What is the beta? 0.1. So it will become 10 divided by 1 plus 100. That is 10 divided by nearly equal to 100 because 1 is negligible. So you can say this is 0.1. So what is the DAF by AF? It will become 0.1% only. 0.1% only. A is the answer. Very easy question. Yes. This is a 1 mark question. Next one. Now, okay. This is the answer is 0.1%. Next question. Everyone read this question. Read this question. The avalanche diode regulates at 25 volt over a range of the diode currents from 5 to 40 milliampere. The supply voltage is given as 100 volt. This is the supply voltage, 100 volt. Supply voltage is given as 100 volt. The avalanche diode, this is the avalanche diode, this is a breakdown diode. Diode current from 5 to 40 milliampere. Diode current means this is the minimum current. Minimum current is also called knee current. Is given as 5 milliampere. And what is the maximum possible current? The rating is given as maximum current. It is given as 40 milliampere. This is called IZ max. Maximum possible current. Okay. The supply voltage V is 100 volt. For proper functioning of the diode, the minimum value of R. What is the minimum value of R? Okay, afternoon session. You are saying that, sir, one session for afternoon. Yes, from 2:30 to what? 5:30. 2:30 to 5:30 session. Okay, we will try to arrange one session. Okay then. Now, my dear friends, this is a general diode and you have to find the value of R. Now, take your time. जल्दी से दीजिए, बताइए क्या होगा आंसर? What is the answer? बोलिए जरा. Time I start. I will give you 1 minute only. Because it is a formula based question. Himanshu Rai given 1.8 kilo. Okay. 1.8 kilo ohm, that is the minimum value of R. Any other student? टाइम तो हो चुका है. जितने भी है आप आंसर दे दीजिए जरा. राइट, आप आंसर देते रहिए कमेंट्स बॉक्स में. एंड दिस इज अ क्वेश्चन बेस्ड ऑन व्हाट वोल्टेज रेगुलेटर. इट इज अ वेरी वेरी सिंपल वन. राइट, very simple question means when we want to find the minimum value of R, always use this formula. What is the IZ maximum? IZ maximum is given by I maximum minus IL minimum. This is IL. You have to find the minimum value of IL and this is called I here. I maximum you have to find. Then you are going to get the IZ maximum here. So what is the IZ maximum is equal to I maximum minus IL minimum. Now, worst condition is this current should be less than or equal to what IZ rating. And rating is given as 40 milliampere. So what is the I maximum? VI max minus VZ upon what R? What is the IL minimum? IL minimum will become VZ upon RL maximum. It should be less than or equal to 40 milliampere, that is the rating. Okay. But RL is not given, it is fixed. What is the value of the RL? It is not given in the question. RL is not given in the question. So you can say the data is insufficient. But my dear students, what is the worst condition? If suppose I am removing the RL, suppose RL become infinite, this will become open circuit. When it is open circuit, what is the value of IL? It will become 0. Then at the same time, this is reached to what its maximum value. Then the maximum current will pass through the Zener diode. So, but here the only fixed value is given. Otherwise, you have to take the maximum value. Suppose it is given a VI minimum to VI maximum. Then always you have to take the maximum value. For example, 50 to 100, that is the range. Then you have to take the 100 volt. Right? Otherwise, you have to take the 100 volt. So 100 volt. So 100 volt you have to use in place of maximum minus VZ, 25 volt it is given. Divided by what R, you have to find RL maximum, take infinite, that's why it will become 0. It should be less than or equal to 40. So what is the value of the R? It should be greater than or equal to 75 divided by 40. When what is the 75 divided by 40? You can find the value. 75 divided by 40, 1.875 kilo ohm. 1.875 kilo ohm. Up to 2 decimal place, give me the answer. 1.87 kilo ohm. This is the value. And take the RL. This is called worst condition. It should be greater than or equal to this value. So greater than or minimum value it is asked. 1.7875. Or my dear friend, otherwise always remember, sometimes up to 2 decimal places to up to 1 decimal places, you can't say 1.8. You have to choose a larger value. You have to give the answer 1.9. Best approximation is 1.9. Right, not 1.8. Next question. Next one. So that is on Zener diode. 1 mark question, numerical answer type. Now, MSQ, multiple select question, 1 mark. Read all the points carefully and give me the answer. I'm going to start timer. Okay. Within 1 minute. Only 1 mark question, theoretical question, MSQ. Which of the following will be true for a common emitter transistor amplifier if the emitter resistor value is made equal to 0? RE, you are making the RE is equal to 0. Emitter resistance RE is equal to what? 0. Then what will be the answer? Right. Its gain will increase, its stability will increase, its input resistance will decrease, its stability will decrease. Multiple correct option. One answer may be correct or more than one answer may be correct. One minute gone, everyone. Kate Kiwama is giving A, B, C. Right. Okay then. A, B, C. Try to understand, this is of, we are saying that true common emitter transistor amplifier, if the emitter resistor value is made equal to 0, means initially we have the value. Initially we have the value, means time over, that this is the common emitter with RE. This is called common emitter with RE. What is the role of RE? This RE will provide the negative feedback, and because of this negative feedback, circuit is stable. Circuit is what? Stable, and input resistance is very, very high. What is the input resistance? HIE plus 1 plus HFE into what? RE. But voltage gain is very low. What is the voltage gain? Only if effectively it will become minus RC by RE. Approximately it is minus RC by RE. Very low. But when we are making RE 0, negative feedback is removed. Therefore, stability decreases. Stability decreases because there is no negative feedback. When we are making RE is equal to 0, voltage gain will increase. There is no negative feedback, that's why the voltage gain will increase. But what about the input resistance? It decreases. Input resistance decreases. So Shibu Bhatnagar 0 marks. Ravi Teja ACD, its gain will increase, right? Its stability will increase, wrong. Its input resistance will decrease, right? Its stability will decrease, right? So answer is what? ACD. So if you are giving the wrong answer 0, Ketki 0 marks, Ravi Shankar full marks 1 mark, and Ravi Teja 1 mark, right? Otherwise 0 marks. There is no negative marking. Okay, then. So that is about the MSQ. So I have very simple only 1 mark question, theory question, that is on emitter, common emitter with RE. Next one. Okay. Now this is a very important MSQ 2 marks question. MSQ 2 mark theoretical question. So read question carefully. In order to obtain repetitive pulses of unequal mark space, one can use. This is a very important question. In order to obtain, right? बताइए जरा, read करो and think about that. Okay. We may expect this type of questions. Read each and every point and then which answer may be correct. This is about the how we are going to get the repetitive pulses of unequal mark space. Okay. Ravi Shankar Kirti, you have given the answer C and D. A monostable multivibrator fed with a square wave input and relaxation oscillator. Okay. And what is the relation between relaxation oscillator and astable multivibrator? Is there any difference? Why you are not giving the? What is the previous answer? Okay. Now, my dear friend, you have only 5 seconds. Time up. Time up. Now, try to give me the answer. One, Ravi Teja have given the answer AC. Ravi Shankar, previous answer is what? A, C and D. A, C, D. Now, try to understand. What is the meaning of this question? In order to obtain the repetitive pulses of unequal mark space means, my dear friend, we have on and off period, different on and off period. This is called on period and that is called off period. They are not equal. So this is on period is called mark, that is called space, then mark, then space, then mark. So mark and space. And this is the T on is not equal to T off. This is a asymmetrical square wave. How we can get the asymmetrical square wave? Actually, this is the question. Okay. My dear friend, what is an astable multivibrator? Square wave generator. So we can find the square wave generator by using what? Astable multivibrator. Yes. Unequal mark space. No need to give any input because it is oscillator. There will be the output without any input. So that is the right, and this is also right. What is the relaxation oscillator? Relaxation oscillator, my dear friend, already I have given each and everything about that. Other than sinusoidal signal, this is called relaxation oscillator. We are generating what is square wave with the help of this. Okay, relaxation oscillator, that is also correct. Now, what is the answer? Voltage comparator fed with a triangular wave signal and DC voltage. Try to understand this one. Now, my dear friend, if suppose one comparator is given, if one comparator is given and you are connecting a reference voltage like it is 2 volt, here you are giving the triangular wave. 10, this is a triangular wave, right? Now what is the reference level? DC level is, let's set at 2 volt. So what is the output of comparator? We have the two output only, plus Vset and minus Vset. When the positive terminal is less than 2 volt, minus Vset. It is greater than 2 volt plus Vset. Again we are going to get what is square wave. Again we are going to get the square wave. Okay. So that is the answer. Right. So this is 1 minute. This is the less than 2 volt. Input is less than 2 volt, minus Vset. Greater than 2 volt, plus Vset, minus Vset, plus Vset, and so on. Unequal mark space. On period and off period is different. We are getting that this one. That is right. Okay. So this is also correct. A voltage or comparator fed with a triangular wave. And finally, my dear friend, a monostable multivibrator fed with a square wave. Yes, in a monostable multivibrator, when we are giving the trigger, it will give the output. Again, we can generate the square wave. Monostable multivibrator means it is a monostable. I am connecting a square wave, like this is a square wave fed with the square wave. When I am giving the input like this, this is the input. Every time when monostable multivibrator get the trigger, it will switch from 0 to 1 and automatically 1 to 0. Again it will got the trigger 0 to 1, automatically 1 to 0. Again trigger 0 to 1, 1 to 0, and so on. So when we are giving the square wave input, this is a square wave, this is a pulse. You are going to get again the square wave. This is the output of the monostable. This is the input. It will also work. So which answer is correct, my dear friends? So everyone, happy Republic Day and happy बसंत पंचमी. बसंत पंचमी की भी आपको बहुत बहुत शुभकामनाएं. और आज तो आपका दिन है, तो अच्छे से आप पूजा कीजिए, सरस्वती जी से मांगिए आप हर एग्जाम में अच्छे से सेलेक्ट हो. हमारी दुआएं आपके साथ हैं, हमारे पूरे गुड विशेस आपके साथ हैं, राइट. और इस हैप्पी रिपब्लिक डे में याद रखिए, जितना हम नॉलेज गेन करेंगे और जितने हम अपने आप को तैयार करेंगे, उतना हम आज़ाद होते जाएंगे, राइट. ये बात ध्यान रखिएगा. तो ओके चिन्मय, नाउ टेल मी, in order to obtain the, yes, now I think all the answers are correct. You are getting my point. Very, very important theoretical question, guys. Okay. Then next one. Next question. Now tell me, what is the answer for this one? The transistor shunt regulator shown in the figure has a regulated output. This is a numerical answer type question, 2 marks. Transistor shunt regulator shown in the figure has a regulated output voltage of 10 volt. When the input varies from 20 to 30 volt, input voltage varies from 20 to 30 volt, the relevant parameter for the Zener diode and the transistor are, read this point, Vz is given as 9.3 volt, Vb is given as 0.7 volt, Rb is given as 2 kilo ohm. This Rb, this is called bleeder resistance. This is called bleeder resistance, right. And the beta is equal to 100. The maximum power dissipated in the transistor is, yes everyone. तो मेरे इस त्यौहार पे एक ही गुड विश है, एवरीवन ट्राई टू सॉल्व दिस क्वेश्चन. कि देखो भाई, पढ़ रहे हो तो रिजल्ट आएगा, और मान लो नहीं भी आया तो क्या हो जाएगा बताओ. सपोज अगर मान लो आप जैसा चाहते हो वैसा रिजल्ट नहीं आया, देन व्हाट विल हैपन? ऐसा भी तो हो सकता है ना। तो डोंट वरी अबाउट द रिजल्ट। जो आप ये नॉलेज ले रहे हैं ना, ये नॉलेज कभी वेस्ट नहीं जाएगा, ये नॉलेज सब आपके काम आएगा। अगर गेट का पेपर नहीं देते ना तो इतना पढ़ते भी नहीं आप लोग। तो गेट के पेपर के बहाने जो ये नॉलेज ले रहे हो, आप सर्किट को समझ रहे हो, एक भी अगर आपने सर्किट बना लिया ना तो बस आप पार हो जाओगे। देखिएगा अभी शार्क टैंक बाद में जब एग्जाम खत्म हो जाए तो एक उन्होंने हार्ट बीट चेक करने की एक डिवाइस बनाई है, एक अकेले चिप ने उसको पार कर दिया। उसमें 555 टाइमर का पूरा यूज है, आप देख सकते हो एप्लीकेशन। ठीक है ना, ठीक है उन्होंने नई टेक्नोलॉजी यूज की है, लेकिन ये बेसिक तो वही रहेगा ना। प्लीज गेट द नॉलेज अबाउट ऑल द डिवाइसेस। एनालॉग इज एनालॉग प्लस डिजिटल प्लस EMFT, सिग्नल एंड सिस्टम, कम्युनिकेशन, these all are very very important subject. VB is 0.7 volt, RB is 2 kilo ohm, beta 100. The maximum power dissipated in the transistor is. कितने लोगों को डर लग रहा है? Worried about the exam, everyone? एक्साइटमेंट है एग्जाम को लेकर? टाइम अप। Right. Now, dear students, this is a question on what voltage regulator by using transistor, that is a shunt voltage regulator. Shunt voltage regulator means because it is RL, here we are connecting the RL parallel to this. Transistor is connected parallel to RL and that's why it is called shunt voltage regulator. But in this particular question, RL is not given. The transistor shunt regulator shown in the figure has a regulated output supply of 10 volt. So what is the output voltage? 10 volt. Okay, then try to understand this one. 10 volt. What is the regulated supply voltage? Always remember in this circuit, this Zener diode should be in breakdown region and transistor would be in saturation region. So when we are giving the voltage from this point to this point, KVL, you will get the regulated supply voltage. That is, what is the regulated supply voltage? V0 is equal to Vz plus Vb. Vz is given as 9.3 plus 0.7, that is nothing but 10 volt. V0 regulated voltage is given as 10 volt. Okay, 10 volt. What is asked here? The maximum power dissipated in the transistor. Maximum power dissipated in the transistor means you have to find the value of the Vc. It is already given 10 volt. And then Vc multiplied with the IC. VCE multiplied with the IC. Then you can get the maximum power dissipation across the transistor. So VCE, what is the VCE? VCE is nothing but V0. VCE is V0, that is the 10 volt. Okay. Now you have to find the IC. IC means, try to understand, here we are having the current, like this is I. Now this current is divided into two parts, IZ and IC. IZ and IC. So you can write I is equal to IZ plus IC. Now, since the transistor is in active region, you can write beta IB. What is beta given? Beta is given as 100. It will become 100 IB. This is the value of the IC because transistor is in saturation. Active region. Now this IZ is divided into two parts. This IZ is divided into two parts. One current through the RB and one current is what? Base current. That this is the I1. So what is the IZ? IZ is nothing but IB plus what? I1. Now what is I1? I1 is, what is the drop from this point to this point? VB. So drop across the RB is VB. So I1 is nothing but VBE upon RB. VB upon RB. So what is the VB? VB is 0.7. What is the RB? 2 kilo ohm. So 0.7 divided by 2 kilo ohm. Everyone please find this value. I think 0.35 milliampere.
0.35.
Right? 0.7 divided by 2, that is what? 0.35 milliampere. Okay. Now 0.35 milliampere, it is the value of I1. Now what is the value of I? I means always when we have to calculate the maximum power dissipation, then take the maximum value 20 to 30. So you have to choose the 30. So when this voltage is 30, this voltage is 10 volt. So what is the value of I? I will become VI max minus V0 upon what? R. 30 minus 10 divided by 20 ohm. This is 1 ampere. 1 ampere current. Once you will get the I, now ultimately you have to find the IC. So you can write this formula. I is equal to IZ. What is the IZ? IZ is IB plus I1. IB plus I1. And what is the IC? Beta IB. Beta times of IB. So this is the formula. I, you have the answer 1 ampere. This is, remember, 1 ampere. This current is what? 1 ampere. And this is what? Milliampere. That is the difference. 1 ampere and 1. This is what? Milliampere. Always remember this one. Then IB. What is the IB? Plus beta. Beta is 100. Plus I1. 0.35 milliampere. Right? Now from this you can find the value of what? IB. 1 minus 0.35 into 10 raised to power minus 3 divided by what? 101. It will give you the value of what? IB. Once you will get the value of IB, please everyone calculate it. You can find the value of IC, that is the beta IB. 100 times of IB. Find the value of IC, and now you can calculate the power dissipation, that is the VCE into what? IC. 10 into IC. Put the value here. This is called power dissipation. Power dissipation. Okay. I think everything, this concept is clear. Okay then. This is IZ is equal to what? IB plus actually I1. So I1 is equal to VB divided by RB, and RB is given as 2 kilo ohm, and that's why it is the 0.35 milli and a very, very small value. You have to convert it into what? Ampere. Be careful about that. Right. Kar loge calculate? I think this is clear to you. The method is clear to you. Find the current here. Then IZ, I1 plus IB, and IC is equal to beta IB. You will get the answer for this particular question. Very practical question. Normally we are neglecting this RB. Sometimes you have to consider the value of RB. That is called bleeder resistance. यहाँ से जो extra current है ना, the extra current IZ will bleed off through this resistor, and the remaining current will pass through the transistor. That is the IB. And IB will control what? IC. IB will control IC. That may be the MSQ question. Next one. Now tell me. In the given figure, you have the idea about this circuit. What is the name of this circuit? This is the plus VCC. VCC is given as 10 volt. R1 is given as 4 kilo ohm. R2 is given as 4 kilo ohm. R3 is given as 10 kilo ohm. And my dear friend, this is the connection. If the dot is given, this is connected here, but there is no connection. This is a jumper here. If notice is here, this is connected here, this is connected here, this is connected here. You have to understand the question. RE is given as 2 kilo ohm. RE is given as 2 kilo ohm. It is a MSQ 2-mark question. Which statements are correct? The value of collector current, the value of VCE, the given circuit is called, it is used to overcome the decrease in the input resistance due to the potential divider biasing. Okay. भाई जल्दी से बताओ, उसके बाद आएंगे आप आशुतोष सर जो डिस्कस करेंगे क्वेश्चंस फ्रॉम नेटवर्क एंड व्हाट कंट्रोल सिस्टम. आशु जांगड़ा सर, राइट, योर फेवरेट. तो ही विल डिस्कस व्हाट क्वेश्चंस फ्रॉम control and net worth. So don't leave the session. Please subscribe our channel, and so that you will get the notification about all the coming session. We are going to take one important session, that is Super 11. Okay, please give me the answer. Now I have a theoretical question. What is the name of this circuit? The name of this circuit, the given circuit is called as bootstrap. That is right or wrong? This is right or wrong? You have the idea about that, then you can give the answer. This is a transistor, C is connected here, R1, R2, and this is the connection. And when we are taking the output from the emitter and input to the base, then common terminal is collector, and that's why it is a common collector. That's why it is a common collector. Common collector. I'm just asking what about the C and D, because it is a theoretical question. If you have the idea about the circuit, then it is very easy to solve. Otherwise, it will become difficult for you. Now, this is a standard circuit, and when we are facing the problem of what? Potential divider. Everyone, please take the screenshot of this. Please take the screenshot of this. This is a very simple circuit. This is called potential divider biasing in case of common collector. Right? And up to this point, the input resistance is very high for common collector. It is around HIE plus 1 plus HFE into RE. No need to revise the formula. Remember, for common collector, the input resistance is very, very high. But actually, what is the resistance C into what? What is the resistance C into Vs? Actually, we have to calculate the input resistance at this point. At this point, because of this potential divider biasing, during AC analysis, the input resistance will become R1 parallel with R2 parallel with Rin. R1 parallel with R2 parallel with Rin. And that is called the problem of what? Potential divider biasing. Potential divider biasing. And because of this, the input resistance decreases. Input resistance what? Decreases. And to solve this problem, we are using the circuit that is called bootstrap circuit. So it is actually it is a bootstrap circuit. The given circuit is called as bootstrap circuit. That is right. And what is the purpose? It is used to overcome the decrease in the input resistance due to the potential divider biasing. That is also correct. Theoretical question. Now it is a numerical based question. So if it is a numerical based question, then you have to solve. How we are going to solve this question? Try to understand this one. My dear friend, in this question, very simple, because only the DC current is required, IC is required here. IC is required here and VCE is required here. So simply try to, first of all, for DC analysis, capacitor act as open circuit. DC analysis, capacitor act as open circuit. Remove the capacitor, it will act as open circuit. Now watch this diagram. This point is connected to base. This point is connected to base. Like it is the X point, X and base, and this is the VCC, and that is connected toward ground. Then we have this type of diagram. This is base. This is R3. This is R1. This is VCC, 10 voltage is given, and this is the R2. R1 is 4 kilo ohm, R2 is 4 kilo ohm, and R3 is, what is the value of the R3? 2 kilo ohm. R3 is 10 kilo ohm and RE is 2 kilo ohm. Okay. This is the 10 kilo ohm. Okay. First of all, remove this portion. Remove R1, R2 and R3. Apply the Thevenin's equivalent. So what is the voltage at this point? So VTH you can find 4 divided by 4 plus 4 into 10, that is the 5 volt. At this point, Thevenin's voltage is 5 volt. What is the Thevenin's resistance? And this is the Thevenin's resistance. R1 parallel with the R2 in series with the RE. So what is the RTH? R1 parallel with the R2 plus R3. 4 parallel with the 4 plus 10, and that is nothing but 12 kilo ohm. 12 kilo ohm will become RTH. Now this question is very, very easy. Once you will got the VTH and once you will got the RTH, then finally apply the circuit. What is the RTH? 12 kilo ohm. What is the VTH? 5 volt. This is the VTH. Now connect the circuit because it is connected here. Base RE. RE is given as 2 kilo ohm. And this is the VCC, that is the 10 volt. Now this current is IC. This current is IB plus IC. That is nothing but 1 plus beta times of what? IB in active region. In active region. Okay. Then this is the VBE. Now you can write the KVL in this diagram. It will become minus 5 plus 12 times of IB plus VBE. That is nothing but 0.7. It is given in the question, VBE plus 1 plus beta times. What is the beta here? Beta is 49. It is given in the question. IB into RE. What is the RE? 2 kilo ohm. Right? From this is equal to 0. You can find the value of IB. IB will become 5 minus 0.7 divided by 12 plus 5 minus 0.7 divided by 49 plus 50, 50 into 2, 100, 100 plus 12, 112. So 4.3 divided by 112 milliampere. And this is the value of what? IB. This is the value of IB. Right? Then my dear friend, what is the value of the IC? So IC you can find beta IB. Everyone check this answer. 49 into 4.3 divided by 112. Okay. What is the problem? Sir, it took 4 minutes, sir, almost. Yes. In exam, how R3 is connected to the base, it is... No, Ravi, I want to say that if you have the idea, because it is a standard circuit, if you have no idea about that, it will take more than 10 minutes to solve this question. If you have the idea about this question, then you can solve within 3 minutes, because directly you can apply what? VTH and RTH. Okay, VTH and RTH. And that's it. Ravi Teja asking, sir, how the R3 is connected to the base? It is connected across the short circuit. And that is the problem. This is not short circuit, my dear. When this is connection is written here, it is not connected. It is just like a jumper. Suppose it is not given, then it is connected here. It is not connected. It is overlapping. It is connected here. It is connected here. The connection is given by the dot. Means it is not connected. It is just like a jumper, R1, R2. This is the base point. So now I can remove this. Base is connected X and R3, and that's why I am giving this type of diagram. This is the X, this is X, this is the base R1 and R2. Remove this diagram, apply the Thevenin's theorem, get the value of VTH, get the value of RTH, and get the value of IC. Yes, everyone. So this is the IC. Now how we can find the VC? Very easy. VCE, write down the KVL from this point to this point. So here you will get the KVL. VCC is equal to VCE plus IB plus IC, that is nothing but 1 plus beta times of IB. 1 plus beta times of IB into what? 2 kilo ohm. And from that you can get the value of VCE. 10 minus, this is 1 plus beta is nothing but 50 into 2 into what is the value of IB? 4.3 divided by 112. 112. Get the value of VC. Easy question, 6.24 volt. So what is this? What about this answer? Right, nearly equal to. Yes, we can say that is right answer. That is right answer, because you are using that, I am using that, you have to use what? 49 actually. What I have used here for IC. Yes, you have to use and nearly equal to. That is the right answer. Okay, nearly equal to. And you will get the IC, I think 1.88 milliampere. So all answers are what? Correct. Okay. This point is clear, my dear students? Now, so this is a standard circuit, bootstrap circuit. Next one. So, the recorded lecture will be available, the PDF will be available on my Telegram channel, and the Telegram channel link is given in the description box. Everyone please join that channel so that you will got the PDF of this session, complete PDF of this session. Next question. Consider the following circuit. For the circuit shown, which one of the following is the correct statement? Which of the following is the correct statement? Everyone, give me the answer. No, it is a question on what? Clipper. It is a question on clipper because we have limited time, and everyone please try to solve this question. Consider the following circuit. For the circuit shown, which one of the following is a correct statement? Okay. Two minutes. A read question, na? It is MCQ, simple 2 marks MCQ, only one answer is correct. If you are giving the wrong answer, there will be the negative marking. कोई भी भाई सेशन लीव मत करना, नेटवर्क एंड कंट्रोल सिस्टम के क्वेश्चंस होंगे. Array Chinmay, you are giving the BCD, it is a MCQ, multiple select question, only one correct answer. Only one correct answer. चलिए अब बनाते रहिए आप. तो डीजे को एक टाइमर है वन, ये इतने समय में इजीली बन सकता था. इट इज अ थियोरेटिकल, जस्ट लाइक अ वेरी बेसिक क्वेश्चन ऑन clipper. Okay, try to understand. Everyone please read the question carefully. D2 does not conduct for any value of Vi, means Vi is negative value as well as positive value. V0 is 10 volt for all values of Vi greater than 10 volt, means we have to increase the range up to what? 10 volt. V0 is 0 for all the values of Vi less than 0 volt, and V0 is 10 volt for all the values of Vi greater than 0 volt. You have to check which answers are right. Chinmay, you are giving all the options are correct. Now watch this. Okay, time up. Then my dear friends, in this question, very simple one. Now make proper table, that is the Vi. Now there are two diodes, D1, D2, and finally output V0. First of all, you have to choose the negative value, means Vi less than 0, because in one answer Vi is less than 0. When we are taking the Vi less than 0, you can choose any value like -10. Because of this -10, this diode is off. Because of this 10, this diode is off. Both the diodes are off. When both the diodes are off, it will act as open circuit. It will act as open circuit. Output will be 0. Why? Because there is no current through this 10 kilo ohm resistor. R. No current. So voltage, output voltage is 0. And the voltage at this point is also 0, and voltage at this point is Vi. So output voltage is 0 for Vi less than 0. Now, when I am increasing the Vi greater than 0, the D1 will on, because for D1, what is the voltage at this point? Vi, and what is the voltage at this point? 0. So when the Vi is greater than or equal to 10 volt, means 0 is less than or equal to 10 volt, D1 will on. But because of this 10 volt, D2 will remain off. D2 will remain off. Now, try to understand. Second diagram, this is on. This is off. what is the output voltage? This is nothing but Vi by 2. Voltage division rule. The voltage will divide it between what? These two resistors, Vi by 2. Now, when this D2 will on, the voltage at this point is 10 volt, voltage at this point is V0. The positive terminal voltage is V0, that is nothing but Vi by 2. And negative terminal voltage is 10 volt for D2. So, when the Vi by 2 is greater than 10 volt, when the Vi by 2 is greater than 10 volt, means Vi is greater than or equal to 20 volt, then the D2 will conduct. So, this is less than or equal to 20 volt up to 20 volt, and when the Vi is greater than or equal to 20 volt, this is on, that is on. When both the diode is on, this is at a short circuit, this diode is on, and that's why output is fixed at what? 10 volt. The highest value of the input voltage is 10 volt. And this diagram is valid when Vi is greater than or equal to what? 20 volt. Greater than or equal to what? 20 volt. Now you can check the answer, which answer is correct. D2 does not conduct for any value of Vi, wrong. D2 will conduct when the Vi is greater than 20 volt. V0 is equal to 10 volt for all the values of Vi greater than 10 volt, wrong. V0 is 10 volt for all the values of Vi greater than what? 20 volt. This should be 20 volt. That's why this is wrong. V0 is 0 volt for all the values of Vi less than 0 volt. Yes. Already we have solved. Yes. This is the 0 volt. That's why the C is the correct answer. V0 is 10 volt for all the values of Vi greater than 0 volt. Wrong. That is for 20 volt. Greater than 20 volt. This is again wrong. So which answer is correct? Only C. Negative marking. 2/3 mark negative कर लो अपना. जितने लोगों ने भी wrong answer दिया negative marking. और जिनका correct है 2 marks. This is the MCQ, my dear friend. It is very dangerous. We can lose our marks. Okay then. Then next one. Last question on from analog, and after that the Asu Jangra sir will join for network and control. So everyone please give me the right answer for this question. For the operational amplifier circuit shown in the figure, V0 is equal to minus 0.5 volt. Which answers are correct out of this? Right? Which answers are correct? Lavanya. Hi sir, can we have yes, we will arrange, and then definitely we will define, we will inform you about that. Electrical, you are from electrical branch, no? Okay. And remember, number of subjects are common. Okay guys, so first of all try to solve all the common subject. For example, analog, signal and system, and what digital, control, network. Just after that please try to attend that session, network and what? Control. For the operational amplifier circuit shown in the figure, V0 is minus 0.5 volt, if V1 is equal to V2 is equal to 1 volt, CMRR is 3.5 volt, differential gain 3.5, common mode gain 1 volt. Okay. अभी देखो, अभी तो टाइम ले लिया आपने. Now बताइए. Sibu, you are giving the ABCD. Himanshu, you are giving the ABCD. All. Please check the answer, my dear friends. Okay, no problem. I will check. Because in a previous 2 question in MSQ, all the 4 options are correct, and that's why you are giving or you are getting actually. You are giving or you are getting. Otherwise, it is a 1 minute we can solve this type of question. Okay, within 1 minute. Only C. Okay. ओनली सी ना, तो चलो देखते हैं। राइट, अब देखो जरा, this is a very simple circuit, it is a differential amplifier, right? Then time over. Very good afternoon pairs, how are you? 1 minute. Okay. Okay then. Now try to understand this question. Time up. Yeah, kuch to answer do. What is the answer? What is the answer for this question? Okay, some students have given all the ABCD. Now try to understand this question. Actually, it is a differential amplifier. Okay, guys, it is a basically it is a differential amplifier by using the op amp. Now, for this ratio, we have to check this ratio: RF, R1, R2, R3. Now, if this ratio is not equal, RF by R1 is equal to what? R3 by R2. First of all, check this equation. Check this ratio. No, not satisfied. 2 by 1 is not equal to 1 by 1. Not satisfied. Then directly you can write the V0 is equal to 1 plus RF by R1. 1 plus RF by R1 into voltage at this point. What is the voltage at this point? R3 by R2 plus R3 into what? V1. This voltage is called V1. I am giving you the general answer, and this is the V2. In this question, V1 and V2 both are 1 volt, but I am writing the general formula V1. And minus RF by R1 into V2. Minus RF by R1 into V2. That is the formula. Now, my dear friend, this is the actual formula is what? A1 V1 plus A2 V2. A1 V1 plus A2 V2. So, from this you can find the A1 and as well as A2. Now, when I am putting the 1 plus RF, 2 divided by 1 into R3, 1 divided by 1 plus 1, this is the value of A1 into 1 volt minus 2 divided by 1, this is the value of what? A2 into what? 1 volt. What is the answer? V0 is equal to, try to understand, this is the 3 divided by 2 V1 minus 2 V2. Just try to understand. V2. This is the standard answer. This is the A1 and that is the A2. Now from this you can find the value of 3 by 2 into 1 minus 2 into 1, that is equal to what? Minus 0.5 volt. Minus 0.5 volt. This is the output, and that's why this answer is correct. A is correct. Okay. Then how we can find the CMRR? How we can find the CMRR and so on? Now this is a standard formula. From this standard formula, what is the CMRR? A1 V1 plus A2 V2. Then always remember the AD is given by A1 minus A2 by 2. And AC is given by A1 plus A2. A1 plus A2. Now from this, what is the A1? A1 is 3 by 2. And what is the A2? Minus 2. Compare these two equations. Compare equation number 1 and equation number 2. So A1 is equal to 3 by 2 and A2 is equal to minus 2. So what is the AD? AD will become 3 by 2 minus of minus 2 upon 2. So you will get 7 by 4. This is the AD. And what is the AC? A1 plus A2. 3 by 2 minus 2. And you will get minus 1 by 2. Minus 1 by 2. Okay. This is the AC. A1 minus A2. That is the minus 1 by 2. Then finally, what is the CMRR? Common mode rejection ratio is nothing but mod of AD by AC. Tell me, 7 by 4 divided by 1 by 2. It will become 7 by 2. That is nothing but 3.5. 3.5. 5. So 3.5 CMR are right. But what is the differential gain? Differential gain, the mod is not 3.5. It is what? 7 by 4. Wrong. And it is what? 1 by 2.5. Again the ratio will be 3.5. This is wrong. This is wrong. You are giving the wrong answer, everyone. AB. Are you getting my point, everyone? AB is the correct answer for this question. So you are making the silly mistakes. AB only, my dear Ravi Shankar, not D. Only AB. Because AC is not 1. What is the AC actually? Common mode gain is, what was the common mode gain? 1 by 2. Minus 1 by 2, I am giving the mod of that. Mod of that. This is the standard formula for AD and AC. This is the standard formula for AD and AC. And what is the actual output? V0 is equal to AD VD plus AC VC. And here VD is equal to V1 minus V2 and VC is equal to V1 plus V2 by 2. And from this we are getting the V0 is equal to A1 V1 plus A2 V2. When we are comparing all this, you will get the AD. And what is the AC? Okay, I think everything is fine now. Okay, then AB is the correct answer. So hope so you enjoy the session. Please stay tuned, right? Because Asu Jangra sir will join within 1 minute. Important information for you. GATE and Engineering Services Exam Test Series get unlimited access to full length mock test, subject test. Link is given in the description box. To go through that link, join the test series. After that, Engineering Services exam is waiting for you. And why? 60 plus tests, detailed mock analysis, virtual scientific calculator is available, curated by the GATE expert. All India open mock, 4,000 plus practice questions are available with virtual calculator. Okay guys, and that is very, very important for you. You are on BYJU'S exam prep. Please share the link of this session, like the session and subscribe our channel. Okay, और बस wait कीजिए within 2 minutes, within 1 minute, Asu Jangra sir will join you. Okay, okay then. Thank you very much. Happy Republic Day और बसंत पंचमी की हार्दिक शुभकामनाएं. Thank you.
Hello everyone. So good afternoon and happy Republic Day, and I hope you all are fine there. Please tell me, is audio video clear? Is audio video clear? Tell me guys, is audio video clear? Okay, perfect. So I hope you are enjoying, and Rathi sir was discussing about analog electronics. So now it's time for the network and control system. Okay, so we'll start with the network and control system. So let's start guys. But before that, let me tell you guys, there is one mega workshop which will be on 29th of January, and it will be taken by Rakesh Talreja sir for GATE 2024 students. So please tell your friends, inform your juniors or those students who want to prepare for GATE 2024. That will be helpful for them. So please please tell them about this mega workshop. Now this is again one more interesting announcement, that is for GATE 2023 we are planning a exam analysis session, and this session will be on 5th and 11th. For electrical electronics it will be on 5th 1 p.m. and 6 p.m. So you can come to this session and you can check your analysis, you can check your answers, so that you can get the information how much marks you are getting, and then you can plan accordingly. Okay, there is one All India Open Mega Mock Test for GATE 2023. So again, you can register for that, and the link is given in the description. So you can go there and you can register for this test. Okay. There is one more series, GATE Super 11, which is going to start from 27th of January. So it is for EE, EC, and IN Computer Science. Okay, so you can also join this series. Also, you can also watch this series. Okay, so that's all for the information. I think it's time to start the network theory. Okay, guys. So let's start with the question 1. So this is actually question number 54. So the question is the Norton circuit parameter of below circuit through AB terminal. So AB terminals are given to you, and I want to calculate the Norton resistance and the Norton current. So please solve this question, guys. I hope this question is clear to everyone. So please solve this and tell me which option is correct. This is 2-mark question. Wait a minute, yes, this is 2 marks question. Okay, do it, guys, do it fast. Do it fast. I'm giving you 2 minutes, not more than that. Do it fast. Tell me the answer. So tell me the answer, guys. Do it fast. Do it fast, do it fast. Which answer you are getting? Question is very simple. Do it fast. You are not replying. I think the time is over. Please like this session, guys. Those students who have not liked this session, please like it. Okay, so that we can make the century of the likes. So it is like this session. Like this session. Okay, let's try this question, guys. So we need to calculate Rn, or maybe the Norton resistance and the Norton current. Then the Norton current can be calculated by just sorting these 2 points. You can calculate the Norton current. What will be the short circuit current? That will be the Norton current. And if you want to calculate the Norton resistance, then you need to deactivate it, and then you have to calculate the Norton resistance. Let's calculate the Norton resistance first. So if you want to calculate the Norton resistance, then you have to deactivate this. So the resultant circuit will look like this. We have one resistance of 6 ohm, and then this current source is open. So I don't need to connect a current source here. There is a dependent source, and the dependent source value is 2Vx. 2Vx. And then you have 2 ohm resistance. You have 2 ohm resistance. And it is given that this voltage is Vx. This voltage is Vx. What I need to do is to calculate the Norton resistance, just connect a current source here. Current source of 1 ampere. Apply the multimeter method. We call it multimeter method. So I applied a current source, and then we need to calculate the voltage across this current source. The voltage across the current source is Vx itself. So if somehow we can find this Vx divided by 1 is equal to the Norton resistance. So it's very simple. How to calculate this Vx? You can apply the nodal. Assume that this is grounded. If this is grounded, we call it Vx point. This voltage is Vx. Now we can apply nodal here. First you have to calculate this Vx. Vx will be the voltage across the current source. Vx divided by 1 will be the Norton resistance. So it's very simple. Now how to calculate this Vx? You can apply the nodal. So you can write the direct nodal equation. The coefficient of Vx will be 1 by 2 plus 1 by 6. Okay, 1 by 2 plus 1 by 6 equal to entering current. Tell me the entering current. Entering current is 1 from this side, and this source will try to leave the current. Okay, so here I have to take minus 2Vx upon 6. I don't know how many of you are aware of writing the direct nodal equation. Okay, so this is the direct nodal equation. Now Vx, what is Vx? Okay, Vx, Vx is the variable which we need to find. So we can take this Vx, this coefficient on this side. So if you take this Vx on this side, then it will be 1 by 2 plus 1 by 6 plus 2 by 6 is equal to 1. Okay, now you can see that Vx came out to be 1. Is it fine? You can see that Vx came out to be 1. If Vx is 1, then the R Norton is equal to 1 ohm. Okay, R Norton is 1 ohm because the Norton resistance is Vx divided by 1. Okay, so R Norton is 1 ohm. It means either option A is correct or option C is correct. Now the next thing is short circuit current. To calculate the short circuit current, we have to sort it. So sort this point, and I need to calculate this short circuit current, or we call it Norton current. If you are sorting this, then Vx will become 0. Vx will become 0. If Vx becomes 0, this source will also become 0 volt. It means this source is also sorted. Okay, this source is also sorted. There is no meaning of this dependent source. If Vx is 0, because you have sorted these 2 points, so if Vx is 0, then this 2Vx will also become 0. It means this source becomes sorted. Now we need to calculate this current. We know that there is no current in this resistance. Why? Because these 2 points are sorted. So whatever this 10 ampere current, that 10 ampere current entirely will go via this path. This current will again be 0. Why this current be 0? Because the voltage difference between this point and this point is 0. It is sorted. Let's assume that this point is 0 volt. If this point is 0 volt, the upper point will also be at 0 volt. Why? Because it's sorted. If this is 0, this will also be 0, this will also be 0. Okay, so you can see that there is no voltage difference. There is 0 voltage difference across this 6 ohm, so there will be no current. So entire 10 ampere will flow through this. So the Norton current came out to be 10 ampere. Okay, so Norton current came out to be 10 ampere. Answer is Calcutta. Okay, answer is Calcutta. Tell me guys, answer is Calcutta. C option is correct. C option, Calcutta option is correct. Let's come to the next question. Okay, so the next question on your screen is, we need to find I and Vx. I is this current, and it should be Vs. We need to find I and Vs in the following circuit. It is given that the initial current is 5 ampere. Initial current in this inductor is 5 ampere. We need to calculate the expression for I and the expression for this voltage. Now tell me guys, how to calculate the expression for this current and the expression for this voltage? It's very simple. It's very simple. You can solve it, and again it's a 2-mark question. Try to solve this question. Again it's a 2-mark question. 2 marks question. I am providing you 2 to 3 minutes. Okay, I am providing you 2 to 3 minutes. Do it fast. Do it fast. I'm not using the timer, but we'll approximately calculate this. Okay, calculate the time. So do it fast guys. Do it fast. Let's see how many of you can solve this question. Do it fast. Do it fast. Do it fast. You can apply the direct method. You can apply the direct method. It's easy. Use the direct method. Use the direct method. Tell me which option is correct. There are some basic points that you need to understand. Initial current is given as 5 ampere, and obviously it is downward. So at t equal to 0, the current has to be 5. But if you look at this expression and look at this expression, it is minus 5. At t equal to 0, it is minus 5. So you have to cancel them. Okay, these two are cancelled, that's for sure. Now let's come to this point. Now A and D. We know that if initial current is 5 ampere in this side, so this initial voltage has to be minus 20 volt, because the polarity will be like this, and Vs is of this polarity. So you can say that the initial voltage of this polarity is minus 20. It means at t equal to 0, this voltage has to be minus 20. Now if you look at this A option, at t equal to 0, it is plus 20. It should not be correct answer. Okay. So the correct answer should be D. Okay. You don't need to solve this question. You don't need to solve this question. You have to be smart. Don't try to apply Laplace or don't try to apply some equations. Okay. You can directly calculate using the initial current and the initial voltage. So the initial voltage has to be 20 volt because the initial current is 5 ampere in this direction. Na? So if the initial current is 5 ampere, this voltage of this polarity has to be 20 volt. But we require this polarity. It means initial voltage has to be minus 20 volt. Okay. At t equal to 0, it is minus 20. D option is correct. Because in A option, it was plus 20. That's why A option is wrong. Now you can see that the initial current has to be 5 ampere. It has to be positive in this direction. And in A option, it is again positive. In D option also it is positive, but B and C are wrong because of the initial current. And A option is wrong because of this voltage. That's why option D is correct. I hope it is clear. Let's come to the next question. Guys. So, I mean, you have to be smart. Don't waste your time in calculation of everything that, there are many students who try to apply the Laplace transform, or maybe they want to calculate the Thevenin equivalent or whatever. Okay. So don't do it. Don't do like that. So what you can do is, let's come to the next question, guys. And the next question is, in this question, Thevenin resistance from the terminal AB. It's a 1 mark question. Okay. Now calculate the Thevenin resistance between the terminal A and B. This is A point and this is B point. We need to calculate the Thevenin resistance between the point A and B. Do it fast. Do it fast, guys. It's very simple. This question is very simple. Do it fast. What is the Thevenin resistance between the terminals A and B? Tell me the Thevenin resistance. Do it fast. Tell me what is the Thevenin resistance. We need to calculate the Thevenin resistance. Do it fast, everyone. No problem, Payas. Please solve this. Please try to solve this question. It's again very simple. Do some calculation. It's 1 mark question. You can do it fast. Okay, so there are some students who are saying Bombay. B answer is correct. Let's see. Let's try. Let's wait for some other students also. Please do it fast, guys. Those students who have not liked this session, please like this session. It's important. Let's make the century of likes. Okay. So tell me how to calculate the equivalent resistance or the Thevenin resistance. For that, there is no independent source in this circuit. So what we can do is, we can connect a current source here. Connect a current source of 1 ampere and calculate this voltage. Calculate this voltage. V divided by 1 will be the Thevenin resistance. So if you have assumed that this current is 1 ampere, then I has to be 1 ampere. I has to be equal to 1 ampere, and this current will become 1 by 4 ampere. Okay, because I is 1 ampere, so you can put the value of I here. So this current will be 1 by 4 ampere. You know that this current is 1 ampere. Out of 1 ampere, 1 by 4 will go on this side. So you can say that 3 by 4 ampere will go on this side. Okay. Now what about this voltage? This voltage came out to be 3 by 4 into 4. That is 3 volt. So this voltage is 3 volt. And we know that this is in parallel with this current source. So this V will also be 3 volt. Fine. Now we can calculate the Thevenin resistance. 3 upon 1. Answer is Bombay. Okay. Answer is Bombay. So it's very simple question. Let's come to the next question, guys. So the next question on your screen is, find I infinity in the following circuit. We need to calculate I infinity. this I infinity. This is again 1 mark question. This is again 1 mark question. So do it, guys. We need to calculate I infinity. Under steady state, what will be the value of this current? What will be the value of this current? Tell me, guys. Tell me what will be the value of this current. Do it fast. Under steady state, how to calculate this current? It's a 1 mark question. It's a 1 mark question. Do it fast. Let's see how many of you can solve it. We need to calculate I infinity. Do it fast. Do it fast. Let's see how many of you can solve it. Tell me, everyone. Is it Calcutta? So there are some students who are saying Calcutta. I think the time is over. I mean, this question doesn't require that much time. So it's simple. There are 2-3 methods via which you can solve this question. First, we know that under steady state, if the switch is closed, under steady state, this inductor will behave like sorted. This inductor will also behave like sorted. So the net current which will flow will be 10 upon 5, because this is sorted under steady state. So you can say that 10 upon 5 will be the steady state current. So 2 ampere will come from this side. 2 ampere will come from this side. Now the question is, how much current will go in this branch and how much current will go in this branch? How to decide that? For that you can apply current division. But you will say, sir, under steady state it will be sorted now. Then why we are applying current division? Yes, let's first apply the current division. That's a good question. I'll tell you why. Why I am applying current division. So the total current is 2 and the inductance will behave like resistance. You know that. They are not coupled inductances. So they will behave like resistances. So what we can do is, we need to calculate this current now. So that will be 4 divided by the total 6. So it has to be 4 by 3 ampere. It has to be 4 by 3 ampere. Is it fine? This current has to be 4 by 3 ampere according to the current division rule. But the question is, why you are applying current division? It is sorted, both the branches are sorted. So it should be either equal, na? 1 ampere in this side, 1 ampere in this side. Or since it is sorted, you can say that entire current will go in this side. So how can you judge that? Why you are applying current division rule? What you can do, guys, actually this is behaving like sort at steady state, but not before that. Before that it is not sorted and the current is coming from this side, and these 2 inductances are connected in parallel. So obviously if you look at the current value before steady state is reached, then this current has to be divided using current division rule. So you can apply the same rule under steady state also, because before steady state the current is divided in 2 parts and we will divide the current according to the current division rule. So even at the steady state you can also apply the current division rule. What's the problem? There is one more way. If you have not understood this point, if you have not understood this argument, then there is one more point. You can use the Laplace transform. If you apply the Laplace transform will also give you direct answer. This is a 10 by S and this is 5 ohm. This is 5 ohm and we know that this will act like 4S and it will also act like 2S. Okay. So this is the Laplace transform. Now what we can do is, we are going to calculate this total current and then we apply current division rule to calculate this current, and then we will apply final value theorem. Then we will apply the final value theorem to calculate this current under steady state. It's very simple. So let's calculate the total current first. So to calculate the net current, what we are going to do, we are going to take the parallel of these 2 inductances. That will be 4S into 2S divided by 6S. Okay, S will be cancelled. So it will be 4S by 3. This is the equivalent inductance of these two inductances plus 5. Okay, so the current IS will be equal to, this current IS will be equal to, IS you can calculate as 10 by S divided by 5 plus Laplace equivalent of these two. So it will be 4S by 3. Is it fine, guys? Now you can simplify this. It will be 30 divided by S into 4S plus 15. 4S plus 15. Is it clear, guys? Take this 3 in the numerator. So it will be 30 divided by S into 4S plus 15. This is my IS. Now you can apply the current division on this current, on this total current. So if you apply current division, it will be 30 divided by S into 4S plus 15 into, we need to calculate this current. So this impedance, that is 4S, divided by the total 6S. Okay. So we have calculated this current, but we want the steady state value of this current. So what we can do is we can apply final value theorem on this current. How to apply the final value theorem on this current? Just multiply with S and put limit S tends to 0. We'll get the final steady state current. So if you multiply with S, this S will be cancelled, and now you are putting S tends to 0. If you put S tends to 0, you can see that this will go on, and this 15 into 30, you will get 2 here. 2 is cancelled with this 6, it will be 3 here. So the answer will be 4 by 3 ampere. Is it fine, guys? So you can also apply final value theorem to calculate this current. This has to be 4 by 3. Answer is Delhi. Okay. Now there are some question. Durga Prasad, sir, why 10 by S in 57th question? Okay. You are saying why in Laplace transform you have replaced this source with 10 by S, because this source is applicable after t equal to 0. So for this circuit, if you look at this circuit, for this circuit 10 volt will appear after t equal to 0. So it's a kind of 10 UT. It's kind of 10 UT source. UT means it is coming after t equal to 0. So you can say that after t equal to 0 you are applying this source. So the source will act like 10 UT, and the Laplace transform of UT is 1 by S. That's why it will become 10 by S. Okay. I hope it is clear. So I have replaced this with 10 by S, and using that you can solve this question. I think it's easy peasy. Okay. So answer is Delhi. D option is correct. Let's come to the next question. This question is again 2 marks question. Okay. 2 marks. Try this question, guys. Tell me, guys. Ravi Shankar, if before, what do you mean? I'm not getting your doubt. Please ask me again. Yes, the value of Vs for which the value of Vs which leads to the maximum power transfer to the load. This is the load. The load is non-linear because of the presence of this Vs. So he is asking what should be the value of Vs. Okay, we need to calculate that. If before omega t is Laplace of voltage, I'm not getting your doubt. If before omega t is Laplace of voltage, I'm not getting your point, what you are saying. Maybe you are saying that if you are closing this before t equal to 0, whatever the instant the switch is closed, you can assume that instant at t equal to 0. Okay, you can assume that instant at t equal to 0. Okay. Yes, I am telling you, let's say you are closing this switch at t equal to t naught. Okay, you are closing the switch at t equal to, assume that t naught is 0 instant. Okay, that t naught you can take it equivalent to 0, because at the instant at which the circuit start working, you can assume that instant at 0 instant for the circuit, not for you. Let's say the switch is closed at t equal to t naught. Then you can assume that this t naught becomes 0 for this circuit, because the instant at which this circuit start working, we call that instant at t equal to 0. Okay, but according to you, it's time t naught. So whatever the current equation you are getting, you just delay that current equation by t naught time. Okay, you can delay that current equation by t naught time. Nothing, no change. But the steady state current will remain same. There is no change in the steady state current. I don't know, I hope you understood this point or not. Okay, so though it's t equal to 0, so even if it is t equal to t naught, no problem. This current will remain same because it's a steady state current. It doesn't matter at what instant this switch was closed. Okay, but let me tell you guys, the problem will be with this source, no? Because after t equal to 0 it is closing, so you are taking this source as 10 ut. Now there are many students who think that, sir, if the switch is closed at t equal to t naught, then what will happen? How to take this source? You can take this t naught as t equal to equivalent to t equal to 0, okay, and then take it ut and calculate the equation for this current and this current. Whatever the time domain equation for this current or this current or this current, whatever the time domain equation, you just delay that equation by t naught. You'll get the correct answer. Okay, I hope you understood it. Let's come to the next question. So in this question, it's a numerical type question, guys. It's a numerical answer type. Okay, you have to tell me the numerical value of this Vs. What should be the Vs so that the power transfer to this load, this entire load, is maximum? Okay, we need to maximize the power transfer to this load. Now tell me what should be the Vs value. Do it fast. It's a 2-mark question. It's a 2-mark question and you have to give me the numerical value of the answer. Tell me, guys, do it fast. 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 This is 2-mark question. We need to find the value of Vs, this source. We need to find the value of this source so that the power transfer to the load is maximum. The power transfer to this non-linear load is maximum. We need to calculate the value of this Vs. Do it fast. Let's see how many of you can solve it. Do it fast. So let's try this question, guys. I think it's easy peasy. You are taking much time. Do it fast, do it fast. I'm giving you 1 more minute. Giving you 1 more minute. Do it fast. Try to solve this. Try to solve this question. It's not that much difficult. You can solve it in 1 minute, maximum 2 minutes. Okay, not more than that. So I'm giving you 1 more minute. Do it fast, everyone, and don't forget to like this session. Those students who have joined and those students who have not liked this session, please like it. We need to make the century of likes. Okay, so please do like this session. So tell me, guys, let's start this. Let's start solving the let me solve this question. So what you can do is, first you calculate the Thevenin equivalent of this side circuit. What is the Thevenin equivalent of this side circuit? The Thevenin resistance has to be 100 ohm because this current source will be open. So Thevenin resistance has to be 100 ohm. Thevenin resistance is 100 ohm, and the Thevenin voltage, look at the Thevenin voltage. So the Thevenin voltage has to be, this 1 ampere will go on this side because I have removed this load now, and I'm checking the open circuit voltage. So if you are looking at the open circuit voltage, we call it Thevenin voltage. So that voltage will be 1 into 100 because the 1 ampere will circulate here. So it will be 100 volt. I hope it is clear. And then I have to connect the non-linear load here. This load should be connected here. Okay. And the load is like this. Let me connect the load also. This is 200 volt, 200 ohm. Okay. And here you have 5 ohm. Here you have 5 ohm. and then you have Vs here. Okay, this is my Vs. Now to maximize the power, if you want to maximize the power, you should remember that this voltage has to be half of this VTH. This voltage has to be 50 volt. This voltage has to be 50 volt. It has to be half of the VTH value. VTH is 100. It has to be 50 volt. Okay. If it is 50 volt, then what you can do is you can calculate the Vs by applying the nodal. Let's assume that this point is 0 volt. If this point is at 0 volt, then this upper point has to be at 50 volt. Fine, because the difference is 50 volt now. So if you are assuming that this point is 0 volt, then the upper point has to be 50 volt. Now you can calculate this current now. If you want to calculate this current, you can calculate from this point to this point, the current will be equal to 100 minus 50, 100 minus 50 divided by 10, divided by 100. Okay, so it will be 50 by 100, that will be half. So this current has to be half ampere. This current has to be half ampere. Is it clear, guys? So we found that this current is half ampere. This current has to be half ampere so that the maximum power can be transferred to the next circuit. Now we know that this voltage is 50 volt and this voltage is 0. What about this current? This current has to be 50 upon 200. That is 1 by 4 ampere. So from this half ampere, out of this half ampere, 1 by 4 ampere will flow through this 200 ohm. The remaining 1 by 4 ampere, half minus 1 by 4 is 1 by 4 ampere. The remaining 1 by 4 ampere will go in this branch. Now we can apply nodal, or we can apply, we can calculate the current in terms of Vs, and this current has to be 1 by 4. So if you calculate this current has to be 50 minus Vs minus 0 divided by 5. 50 minus Vs minus 0 divided by 5. It has to be 1 by 4 ampere. Okay. We have calculated this branch current, 50 minus Vs minus 0 divided by 5. It has to be 1 by 4 ampere. Okay. From here you can see that Vs will be equal to, wait a minute, this is not 5, this is 50 ohm. Okay, please correct it. This has to be, so I made a mistake here. Okay. Yes, it is not 5, it is 50. It is 50 ohm. Okay. So now what you can do is, you have to replace here 50. Okay. 50 minus Vs minus 0 divided by 50 ohm, you will get the current as 1 by 4. Now from this relation you can calculate the Vs value. So Vs will be equal to, tell me the value of Vs, guys. Tell me the value of Vs. So Vs will be 50 minus 50 by 4. So that is 150 by 4. I think it is correct. 150 by 4 volt. Please check this. Please check the calculation. Is it 150 by 4? So the Vs value came out to be 37.5. Okay. 37.5. 37.5. That's correct. Okay. So this question was very simple. You need to remember that whenever you want to transfer the maximum power to some non-linear load or any load, then this voltage, the terminal voltage, has to be half of the Thevenin voltage. It has to be half of the Thevenin voltage. We know that the Thevenin equivalent for this circuit is, we have calculated the Thevenin equivalent as 100 volt and 100 ohm. Now we know that this voltage has to be half of VTH, it means 50 volt. If you assume that this voltage is 0, then this point has to be at 50 volt, and this current, you can calculate this current, 100 minus 50 upon 100, that came out to be 1 by 2. Out of this 1 by 2, this current, you can calculate this current, because this voltage is 50 volt, 50 by 200, that is 1 by 4. This current is 1 by 4. You subtract 1 by 4 from half, you will get 1 by 4 ampere on this side. Now you can apply the nodal or the KVL in this branch, or the maybe whatever. Okay, you can apply the nodal in this branch and you can equate this current equal to 1 by 4. So the current will be 50 minus Vs minus 0 upon 50. Okay, it came out to be 1 by 4. So using this you can calculate Vs. Vs came out to be 37.5. Let's come to the next question. Let's come to the next question. This is, I think, MSQ. This is MSQ. Okay, and 2 marks. And 2 marks. Okay, please solve this. Solve this question. Consider the following circuit with ideal op-amp. Okay, we have ideal op-amp. Which of the option is true regarding the above circuit? Okay, which of the circuit is which of the options is true? Z11 is R1. I hope you can see it. Z11, it's Z11. Z11 is R1. Okay, this is R1, this is R2, this is Z21, this is Z12. Okay, this is Z11. Okay, so in the option it is given that Z11 is R1, Z12 is 0, Z21 is R2. Y parameter does not exist. So you have to tell me which options are correct. Do it fast, guys. Do it fast. This resistance is R1. If you can't see it, this resistance is R1, this resistance is R2. Okay, do it fast. Let's see how many of you can solve it. Don't forget to like this session. Those students who haven't liked this session, please like it. Like this session, guys. Solve this question. It's a good question. Try to solve this question. Do it fast, guys. Do it fast. Do it fast. Let's see which options are correct. It may be possible that only one option is correct. Okay, it may be possible. I mean, in MSQ, it's not necessary that more than one options are correct. It might be possible that only one option is correct. This can be the subset of MSQ also. No? Durga Prasad is saying AB, Agra, Bombay. Okay, anyone else? Do it fast, guys. Do it fast. Do it fast. Let's see how many of you can solve this question. This is based on analog and two-port network theory. This is based on analog and two-port network theory. Do it fast. Munishwarudu, P. Munishwarudu. I hope I am pronouncing your name correctly. So he is saying Agra, Bombay, Ketki Verma, ABCD. Okay. Durga Prasad has changed his answer. D, Delhi. Okay, let's see, guys. I think I have given you enough time. So let's try to solve this question. We know that there is a negative feedback and this point is 0 volt. If this point is 0 volt, this point has to be at 0 volt. Okay, there is a virtual short point. Now you can calculate this I1 has to be equal to V1 by R1. So from here you can say that V1 is equal to R1 into I1. So Z11 is R1, that's correct. If you find the Z parameter, then Z parameter should be written like this. V1, V2 can be represented in terms of I1, I2. So V1 came out to be I1 into R1. We know that. So it has to be R1 and this has to be 0. If you write this equation in matrix form, then the coefficient of I1 is 0 and Z12 is 0. Okay. So A is correct, B is correct. Z11 is R1, Z12 is 0. Now let's come to the other side. We know that this is I1. I1 came out to be V1 by R1, or simply you can say this current is I1. We know that this current is I1, then the op-amp will not take any current, so the entire current will flow in this side. This will also be I1. So this voltage will become I1 into R2. So if this point is 0 volt, then this voltage has to be minus of, because you are going from plus to minus, so you have to take minus of I1 into R2. Is it fine, guys? So this V2 has to be minus of I1 into R2. Okay, you can check it. Is it clear, guys? This V2 has to be minus of I1 into R2. But the problem is, we need to calculate this V2 in terms of I1 and I2, but we are not able to calculate V2 in terms of I2. So you can say that if you write this, then V2 has to be, this coefficient has to be minus of R2 and this has to be 0. Is it clear, guys? Is it clear? Tell me. So Z21 has to be minus R2, but it is written as plus R2. So this is not correct. Is it clear, guys? Tell me. Have you understood this? So we have calculated this V2. How I have calculated? We know that this current is I1 and this is virtual short here. So whatever current I1 is, the same current will go on this side because the op-amp will take 0 ampere. Okay. So you can say that this current is I1. So this voltage has to be I1 into R2. If this voltage is 0, then output voltage V2 has to be I1 into R, minus of I1 into R2. Okay. So there is no coefficient of I2 here. So you can say that this is 0 and this is minus R2. Okay. So Z21 has to be minus R2. It is not plus R2. So this C option is wrong. Now, can you calculate the Y parameter? Y parameter are Z inverse. We cannot take the inverse of this matrix because the determinant is 0. That's why the Y parameter does not exist. That is also correct. Okay. That is also correct. So now tell me, Agra, Bombay and Delhi, ABD are correct. Nobody have given me the correct answer. ABD, Agra, Bombay and Delhi. Okay. Is it fine, guys? Can I proceed? Tell me. So this was again good question. It's a combination of analog and network theory, two-port network. Okay. I hope it is clear to everyone. Is there any doubt? Is there any doubt? Can I proceed? Let's come to the next question. So now what I have done is I have completed the network theory. Now let's come to the next thing, and the next question is okay. I think something is missing here. So let me write, because I think some information is missing here. So wait a minute. Let me write. Let me check the original file so that I can put the information, because this is good question and you should solve this question. Wait a minute. Yes. So the question is given as S plus 2 GS equal to S plus 2 divided by S minus 1 into S plus 3 into S plus 4. Okay. It is given. Which of the following statement is true about the Nyquist plot of this? Okay. And the right half contour is given like this. Right half contour is given like this. Okay. This is my right half contour, S plane. S plane contour is given like this. Now we have to comment on the 4 options. Tell me, guys, which options are correct. Okay, this is again only single option is correct. So you have to tell me, and this is 2-mark question. This is 2-mark question. Please do it. This is 2-mark question. Please solve this question. Solve this question, guys. Tell me what should be the correct answer. Which of the following statement is true about the Nyquist plot? Okay. GS is given like this. Tell me which option is correct. And HS is not given. So obviously HS I have to take as 1. HS I have to take as 1. If HS is not provided, then I have to take HS equal to 1. Now tell me how to check the encirclement of origin and minus 1. I have to check the encirclement of origin and minus 1. Okay. If you want to, okay, you want to solve this question or you want me to solve this question? Tell me, guys, which option is correct. Do it fast. Let's take 2-3 minutes. At least try this question. Na? Try this question. This question is of 2-mark question. So try this, everyone. I want you to try this question. Do it fast, everyone. Try to solve this question. Try to solve this question. This is a very good question. It's a 2-mark question. Let's see how many of you can solve it. Only one option is correct. Do it fast. Do it fast, everyone. Do it fast, do it fast. You want me to solve this? Kate ki Kelgda chin mein Agra. Okay. Let's see. Let's try. Let's wait for some other student also, and then I'll try. Okay. After that, I'll try this question. So do it fast, guys. You are taking much time. You are taking longer time. Don't take that much time. This is not a lengthy question. It's a simple question, and you can easily solve it. Okay. I think it's time to solve this question. Let's try to solve this question, guys. We know that we are looking at the encirclement of origin and -1. When you look at the encirclement of origin, what does it mean? And when do you look at the encirclement of -1? If you are looking the closed loop stability, closed loop system stability, then you look for the -1 encirclement. And if you are looking for open loop system stability, only GS, then you look at the origin encirclement. We know that the open loop system GS is unstable because of this one pole in the right half. Okay, so there is one pole in the right half, one pole in the right half. For this open loop system, one pole in the right half. So if you are mapping this entire S plane in the GS, then you can say that the number of encirclement of origin, will be number of pole minus number of zeros, wait a minute. So it should be number of pole minus number of zeros, or zeros minus, whichever formula you can apply. No problem, but n should be positive. You have to check from which formula you are getting n positive. Okay. So now tell me, how many poles are in the right half and how many zeros are in the right half? Only one pole is in the right half and there is no zero in the right half. So number of encirclement will be P minus Z. Using this formula, you can calculate number of encirclement. Using this formula, n will be negative. I don't want n negative. I want n positive always. So you can apply this formula, and using this formula, n came out to be 1. So there will be one encirclement of origin. Okay, because you are looking GS only. And you are commenting on the stability of GS only. We know that the GS is unstable and there is one pole of GS in the right half of the S plane and there is no zeros of GS in the right half of the S plane. So if you are looking at the origin encirclement, then you look at the pole and the zeros of GS only. Okay, because you are looking at the encirclement of origin. Okay, so P is 1, Z is 1, so the number of encirclement has to be 1. And since the number of encirclement has equal to 1 using this formula, I get n equal to 1 using this formula. P minus Z is there. If P minus Z is used, then the direction of the encirclement will be opposite to this. Okay, if you use this formula, then the direction of encirclement is the same direction. Okay, but we know that using this formula I am getting n negative, so obviously this is not correct. I'm getting n positive. I should get n positive. N positive came from this formula, so you can say that it's P minus Z. Since it is P minus Z, so the number of encirclement will be 1. That's correct. Number of encirclement will be 1 and it will be opposite, anti-clockwise. So it will encircle origin once in clockwise. So this is not correct. Okay, this is not correct. Let's come to the, it will encircle origin once in anti-clockwise. It may be correct. Okay, it will encircle origin once in anti-clockwise. It is also, it may also be correct and it may also be correct. So one option is eliminated. I don't know how many of you have understood it, because those students who have studied from some other teacher, control system, you might study some other from some other faculty also. Then every faculty has its own way. This is my way. Okay, I look at the encirclement like this. So if you are looking at the origin encirclement, look at the GS only. But now you have to calculate the number of encirclement of -1 also. When we look at the number of encirclement of -1, then we are looking at the closed loop stability. Now, how to check whether the system is closed loop stable or not? Using Routh. Okay, let's first apply Routh. First calculate the characteristic equation. So I know that the characteristic equation is 1 plus GSHS equal to 1. 1 plus GSS equal to 0. So what we can do is, we can calculate the characteristic equation. It should be S minus 1 into S plus 3 into S plus 4 plus S plus 2 equal to 0. This is my characteristic equation. 1 plus GSS equal to 0. So I have simplified this, and the characteristic, I have calculated the characteristic equation. This is my characteristic equation. So let's simplify it. Let's multiply it. So S square minus S square plus 2S. Okay, plus 2S minus 3 multiply by S plus 4 plus S plus 2 equal to 0. Is it fine? Now you can further simplify it. So it will be S cube plus 4S square plus 2S square, 6S square, plus the coefficient of S will be 8 minus 3. 8 minus 3 is 5. So 5S minus 12 plus S plus 2 equal to 0. This is the characteristic equation. So it will be S cube plus 6S square plus 4S plus 6S. Okay, it should be 6S minus 10 equal to 0. Okay, this is my characteristic equation. You can check the calculation, guys. You can check the calculation. So what I have done is, I have taken 1 plus GSS equal to 0 and I calculated the characteristic equation because I want to calculate the closed loop stability. Okay. So you can see that this is the characteristic equation. So I just multiplied it. So it will be S square plus 2S minus 3 into S plus 4, and then I multiplied this S plus 4 with this. So it will become S cube plus 2S square plus 2S square plus 4S square. So it will be 6S square, and then the coefficient of S will be 8 minus 3, that is 5S minus 12. I think this is correct. Okay, so it will be S cube plus 6S square plus 6S minus 10. I think this is correct. So this is my characteristic equation. Now you can apply the Routh criteria. Now you can apply Routh criteria to check the closed loop stability. So if I apply the Routh criteria, let me apply the Routh criteria at this position. Okay, let's look at this. S cube S square. So S cube coefficient will be 1 6 1 6, and the S square coefficient will be 6 minus 10. Now S to the power 1, so it will be 36 minus 10, so it will be 46 upon 6. Is it clear, guys? 46 upon 6. 36 plus 10 is 46 divided by 6. Okay, and this is 0. So S to the power 0, the coefficient of S to the power 0 is minus 10. Is it clear, guys? Tell me. Is it clear? This into this minus this into this divided by this is minus 10. Now you can see the number of changes. Only one sign change is there. So you can say that closed loop system is unstable again, and there should be one pole in the right half of the S-plane. In the closed loop system, one pole is in the right half of the S-plane. For closed loop system, one pole in right half. Okay, there should be one pole in the right half. Now we know that for closed loop system, again I have to calculate the number of encirclement. So the number of encirclement P minus Z has to be, the Z is 1. Now you are looking at the closed loop system stability. So for the closed loop system, this Z will act like the closed loop pole. So there is one pole in the right half of the S-plane. Okay, one pole in the right half of the S-plane. So Z is 1, and P is the number of pole of this GS. So P is 1 and Z is also 1. So it came out to be 0. Okay, it means in closed loop system there is no encirclement of -1. Okay, so there will be no encirclement of -1. I hope it is clear. So now you can see that it will encircle origin once in anti-clockwise and -1 twice in clockwise. So this is wrong. Now it will encircle origin once in anti-clockwise and should not encirclement. So answer is Calcutta. Answer is Calcutta. Okay. Answer is Calcutta. I hope it is clear, guys. Answer is Calcutta. Okay. So this answer is Calcutta. Now it may be possible that you have not understood my way, because my way is different way. You might have studied some other way from some other faculty. So obviously everyone has his own way. So I have my own way. According to my method, answer is Calcutta. You can check your own method. Okay. You can check it by using your own method. Okay. I hope it is clear. How many of you have studied control system from me? Is there anyone who has studied control system from me? I hope there are very few students who have studied control system from me. So anyway, so answer is Calcutta. You can check it by using your own method. Let's come to the next question. So this was again very good question, 2-mark question. Now let's come to the next question, and let me correct this question, because again there is a requirement of correction. So let me check the correction. In this question, the lead compensator has pole at s equal to -4 and 0 at s equal to -2. Then the maximum phase lead phi m and the corresponding frequency omega m. Okay, so there are 4 options. Let me write these 4 options, guys. So in the first option, phi m, the maximum phase provided, it is 20, you know, A option. In B it is 30, in C it is 20, and in D it is 30. Okay, and then omega m. So tell me, guys, which option is correct? This is 1-mark question. Root 2 here. Here in B option it is root 8. Here it is root 8 and root 2. Now tell me which option is correct. Which option is correct? Do it fast. Let's see how many of you can solve it. There is a lead compensator. There is a lead compensator, and pole location is -4. And a 0 at s equal to -2. The maximum phase lead and the corresponding frequency. At what frequency you are getting the maximum phase? Tell me, guys. Just try to solve this question. It's very simple again. It's very simple. So it's a 1-mark question. It's a 1-mark question. Do it fast. Let's see how many of you can solve it. Try to solve this question, guys. It's easy again. Do it fast, do it fast. So it's very simple. It's very simple. Do it fast. Tell me which option is correct. It's a 1-mark question. Chinmay, Calcutta. Kitaki. It's Calcutta. Okay. Anyone else? Try this question, guys. It's very simple question. I think you can solve it. I think you can solve it. Do it fast. It's very simple. It's not formula dependent. This question is not formula dependent. If you have remembered some formula, don't try to apply this. You can solve it using simple mathematics. You can apply simple maths. Okay. So P Munis Varudu. Okay. Abid Basir, Calcutta. Okay, Abid. Let's see. I think everybody has done it, because it's very simple question. You don't need more than 1 minute to solve this question. If you remember the formula, it will be very helpful for you, but how many formula you are going to remember? Don't try to remember anything. Okay. Don't try, just apply simple mathematics. You know that it's a lead compensator and pole is at -4. So let's write the compensator. You can see that the pole is at -4 and the 0 is at -2. So s upon 2 plus 1. You can check the 0 also. Why I have written in denominator? Because I want to get the gain as 1, the steady state gain as 1. Okay, that's why I have written it in denominator. Okay, if you write it in this form, in pole 0 form, let's say you write it this form, then it has some gain, and we want that the compensator gain should be 1. That's why I have written. I mean, the answer will not change. Answer will not change whether you write it like this or the second case, no problem. So in the first, so I have written this compensator like this. Pole is given and zeros are also provided to us. So I have written the compensator like this. Now what you can do is you can calculate the angle of this. So angle provided, you replace this s with j omega. So it will be j omega by 2 plus 1 divided by j omega by 4 plus 1. Now what is the angle which is provided by this compensator? So the angle will be tan inverse of omega by 2 minus tan inverse of omega by 4. Okay, this is my theta provided by the compensator. Now we need to maximize this. To maximize this, what you need to do is you need to take the derivative of this. So we want this maximum theta. So you take with respect to omega, take the derivative with respect to omega and make it equal to 0. So what is the derivative here? What is the derivative of tan inverse omega by 2? Tell me guys. It will be 1 over 1 plus omega by 2 square. Is it correct guys? Into 1 by 2. Minus, what will be the derivative of this? It will be 1 over 1 plus omega by 4 square into 1 by 4. Is it clear guys? Tell me. And make it equal to 0. Put it equal to 0. Okay. Put it equal to 0. I think this derivative is correct. What is the derivative of tan inverse x? What is the derivative of tan inverse x with respect to x? Tell me guys. Will it be 1 over 1 plus x square? Is it clear? Yes, I think it's correct. Okay. So I have written like this. Now I make it equal to 0 because I have to maximize this angle. Na? So make it equal to 0. Take this negative side on the other side, on the right side. Take the negative quantity on this right side. So you'll get 1 by 2. So you'll get 1 by 2 into 1 over 1 plus omega by 2 whole square will be equal to 1 by 4 into 1 over 1 plus omega by 4 whole square. Okay. I think this is correct. So what you can do is you can cancel this 4 with 2. Take this 2 in the side. I mean the cross, you just do the cross multiplication. So it will be 2 plus 1 by omega by 4 whole square. Omega by 4. Wait a minute. This is slow. Okay. 1 plus omega by 4 whole square is equal to 1 plus omega by 2 whole square. Okay. So I think it's easy peasy. Now what you can do is you can simplify it. It will be omega square by 8. It will be omega square by 8 plus 2 is equal to 1 plus omega square by 4. Is it clear guys? Take this omega square by 8 on this side. So and take this 1 on this side. So 1 is equal to omega square by 8. So from here omega came out to be 2 root 2. So this is the frequency at which you are getting the maximum phase. 2 root 2 means root 8. So either Bombay is correct or Calcutta is correct. Okay. Either Bombay is correct or the Calcutta is correct. I hope it is clear. I have calculated the phase provided by this compensator and I maximized the phase. I applied the maxima rule. Okay. From here I get the omega. Omega is 2 root 2. Now what is the maximum phase? To calculate the theta m, you put omega equal to 2 root 2 and you will get the theta m value. So maximum phase theta m or phi m you can say. So the maximum phase which is provided by this compensator will be tan inverse of 2 root 2 by 2. So it will become 2 root 2 only minus tan inverse of 1 by root 2. 1 by root 2 and you can calculate this value. Tell me guys. It is greater than 1. So it is greater than 45 degree. It is less than 45 degree. So I hope the answer will be, now you can calculate this value. Now please calculate this value and tell me which option is correct. Out of Bombay and Calcutta, which option is correct? So this is the maximum phase which is provided by the compensator. Tan inverse root 2. Tan inverse root 2 is greater than 1. Na? So it will be greater than 45 degree. Okay. So it is minus, what about this? It is 0.7. It is 0.7. 0.7 is approximately, I don't know whether it is, yes, it is approximately more than 30 degree, I suppose. It is more than 30 degree. So if you take the difference, yes, approximately it is 20. Answer is Calcutta. Okay. Even you don't need to calculate this. You don't need the calculator for that. Because we know that tan inverse of 1 by root 3. Tan inverse of 1 by root 3 is 30 degree. We know that. Okay. So it is more than that. 1 by root 3. The value of 1 by root 3 is less than the value 1 by root 2. So 1 by root 2 is more than 1 by root 3. So it means this angle has to be greater than 30 degree and this angle has to be greater than 45 degree. Approximately it will be within 50 to 60, 45 to maybe 55. So this has to be between 45 to 55 minus this has to be between 30 to 40 degree. Okay, so the difference is approximately, you can say 25 or 20 degree. Okay, it's not more than 25 degree. Okay, so answer is 20 degree. You can do it some manipulation, you don't need to calculate this entirely, but if you have the calculator you can calculate it and you can get the exact answer. Answer is Calcutta. Okay, so this was again very simple question on the compensator. Let's come to the next question. So there is a characteristic, let me write the characteristic because there is a missing term. So let me check the original file again. In the original file, the characteristic equation is given as s to the power 5 minus 2s to the power 4 minus 2s cube minus 2s cube plus 4s square plus s minus 2. This is my characteristic equation, guys, equal to 0. This is the characteristic equation. The number of symmetric pole in the right half of the S-plane. I need to calculate the number of complex pole in the right half. Number of complex pole, remember. The number of complex pole or symmetric pole in the right half of the S-plane. Okay. How many symmetric pole are in the right half of the S-plane? Number of complex pole. Complex pole cannot be 3, cannot be 1. Either they can be 2 or 4. Why? Because complex pole will always be in conjugate pair. That's why the complex pole can be either 2 or can be 4. So 3 and 1 is cancelled. Now you have to check how many poles, whether it is 2 or 4. How many poles are in the right half of the S-plane? So you can apply the route. So s to the power 4, s to the power 5, s to the power 4. So it will be 1 minus 2, 1. Okay. And it will be minus 2, 4, minus 2, 4, minus 2. Okay. So now you can check that s cube. What is the s cube term? It will be 0 and it will be 0 again. So it will be a characteristic equation. Okay. It will be a, auxiliary equation. It will be a auxiliary equation. So you can write this equation as, tell me guys, you can write this auxiliary equation as minus 2s to the power 4 plus 4s square minus 2 equal to 0. This is my auxiliary equation. This is my auxiliary equation. Okay. Now what you can do is, you can take the derivative. So it will be minus 8 here and 8 here. Is it fine, guys? Is it fine? So it will be minus 8 and 8. I think it's correct. Now tell me about s square. So it will be minus 32 plus 16. Minus 32 plus 16 is minus 16. Divided by minus 8 is 2. Okay. And then this is this into this minus this into this divided by minus 8, it will be minus 2. Okay. Then again you are getting s to the power 1 and s to the power 1 is again, tell me, it's a characteristic again auxiliary equation. Okay, this into this minus this into this divided by this auxiliary equation. So if you are getting auxiliary equation, you can write this like this, 2s to the power 2 minus 2. Okay, you take the derivative, you will get 4 here and 0 here. Okay. Now s to the power 0 is, tell me the s to the power 0. So it will be, tell me, it will be minus 2. Is it fine, guys? Is it fine? Now you can check the number of sign. Now you can check the number of sign change. Okay. So 1, 2 and 3. So there are 3 sign changes. It means there are 3 poles in the right half of the S-plane. Now out of these 3 poles, one has to be on real axis and other 2 pole can be complex. Other 2 pole can be complex. So answer is Delhi. Is it fine, guys? Tell me. Answer is Delhi. Because 3 pole cannot be in complex plane. Nah? 3 pole cannot be complex. Okay. 3 cannot be complex. One has to be on real axis. Is it fine, everyone? I hope it is clear. I hope this question is clear to everyone. Okay. So be careful about this. It's very simple. Let's come to the next question. This is again a very good question. Please try this. Please try this. The second order system have a step response shown in the figure below. This is the step response. Okay. and the zeta value is 0.5, damping ratio is given as 0.5, the value of x, I need to calculate this value of x. What is this x value? Okay, I need to calculate this value x. Tell me what is this x value. Do it fast. Do it fast. Let's see how many of you can solve it. Do it fast, guys. Do it fast. Do it fast. It's a 2-mark question. It's a 2-mark question. Okay. Try to solve this question, guys. Do it fast. Do it fast. Let's see how many of you can solve it. Tell me, guys, do it fast. Do it fast, everyone. Try to solve this question. It's a simple question. It's a simple question. Do it fast. Chinmay saying Calcutta. Okay. Vishal Badri, Calcutta. Let's see. Anyone else? Anyone else? 2.16. So you are getting Agra. Sibu. Sibu is getting Agra. Okay. Sibu is getting Agra. Okay, let's see. Let's see how many of you can solve it. Do it fast. Do it fast. Only 2-3 students have given me the answer. It's a simple question, guys. Do it fast. Okay, let me try. You want me to try? You want me to try this question? Okay, let's see, guys. We know that, let's say I have a second order system. So if the second order system is like this, k omega n square divided by s square plus 2 zeta omega n s plus omega n square. And if the input is k naught ut, I'm not taking unit step input. No, the steady state gain of this system is k and the steady state value of this input is k naught. So the output yt, if you remember this yt, it will be k naught into 1 minus e to the power minus zeta omega n t divided by root of 1 minus zeta square sine of omega dt plus phi. You know that. You should remember this expression. This will be my output yt. Okay, this will be my output. Now under steady state, if you look at the steady state value, the steady state value of this output will be kk naught. So it has to be kk naught. This 2 has to be kk naught. So kk naught has to be 2. Okay. Now what is this height? We call it peak time, and peak time is pi by omega d. Pi by omega d. So at t equal to, if you put t equal to pi by omega d, then you can say that this height will become kk naught into, if you can put this t equal to pi by omega d, it will be kk naught into 1 plus e to the power minus zeta pi divided by root of 1 minus zeta square. Okay, you'll get this. This height is this, and kk naught is 2. Kk naught is the steady state value of output. So you can put this kk naught as 2. 2 into 1 plus, so it will be 2 into 1 plus e to the power minus pi zeta. Zeta is half, divided by 1 minus 1 by 4. Is it fine, guys? So you can calculate this value. and you'll get the answer. So obviously this answer has to be greater than 2 because this factor is greater than 1. Okay, so this answer has to be greater than 2. Now you have to calculate this value. What is this value, guys? 2 into 1 plus e to the power minus pi by 2 into, this will be 2 by root 3. Is it fine? This 2 is cancelled, so you will get this pi by root 3 value here. 2 into 1 plus, so the answer is 2 into 1 plus e to the power minus of pi by root 3. This is the correct answer. Okay, this is the correct answer. Now tell me, what is the value of this? What is the value of this? This quantity. Tell me, 2 into 1 plus e to the power minus pi by root 3. So it is approximately double, you can say. E to the power minus 2, approximately it will become e to the power minus 2. E to the power minus 2 is 1 by 4 approximately. So 2 into, this is approximately 2 into 1 plus 0.5, 0.25, okay. So approximate answer is 2.5. This is approximation. I'm not getting the correct answer, okay. You have to calculate this correctly, okay. This is not correct actually. So please tell me which option is correct. Are you getting A? Are you getting Agra or Calcutta? Are you getting Agra or Calcutta? Tell me, guys. Are you getting Agra or Calcutta? What is this value? You have to calculate this value because I think everything is fine here. I have calculated correctly. Everything is fine. So, is it Calcutta? Okay, so you are getting Calcutta answer. Please check the calculation. I don't have the calculator. So, you can calculate this value and check the answer. So, you are getting Calcutta answer. Okay. So, it's simple. It's easy peasy. Let's move to the next question, guys. Okay, this is again a 2-mark question and this is very good question, 2 marks question. Now in this question, the block diagram of a control system is shown in the figure. So the figure is given, this is 10 into alpha by S. If you can see it, this is alpha by S, 10 plus alpha by S. This is alpha divided by S and this is 10, okay. So 10 plus alpha by S, let me write it correctly. This is 10 plus alpha by S, okay. This is 10 plus alpha by S. I hope it is clear now, okay. And this is 1 over S into S plus 6, okay, S into S plus 6, okay. So the block diagram of a control system shown in the figure, the root locus of the system as the parameter alpha varies from 0 to infinity, the break points are. So we need to calculate the break-in points. Do it fast, guys. This is very good question. This is very good question, okay. Do it fast. Do it fast. This is very good question. Let's see how many of you can solve it. This is based on the root locus. Do it fast. After that, we'll solve the last question, okay. And those students who have not liked this session, please like it. Please like this session. We need to make the century of the likes, okay. And I am very far behind that, okay. It's 78 likes only. Second one not visible, okay. Let me write. It's 1 over S into S plus 6. It is S over S into S plus 6, okay. I hope it is clear. S into S plus 6, okay. It is S 1 over S into S plus 6. Let me write it clearly. 1 over, this is S plus 6. Okay. Now I think it's clear. Now tell me which options are correct. Tell me, guys, which options are correct. Do it fast. Those students who have not liked this session, please like it. We need to make the century of likes. Don't forget that. Okay, that will be Guru Dakshina. Okay. So is it Bombay? Solve this question, guys. This question is simple. You can solve it easily. It's not difficult. It's a critical question, by the way. I mean, it's a good question, but you have to be, you can easily solve it. It's nothing new. Okay, you can solve this. It's a good question. Solve this question, everyone. You want me to solve this? You want me to solve this question? Sivu, Bombay. Chinmay, Bombay. Ravi is saying Bombay. Okay, let's see. Any other student? Try this, everyone. This is a very good question again. Try to solve this question. Try to solve this question. Okay, let's try to solve this question. So what is GS? Overall GS will be equal to, because HS is 1 and overall GS came out to be 10S plus alpha upon S into S plus 6. Is it clear, guys? This is my overall GS. So let me write it separately. This is 10S plus alpha divided by S square into S plus 6. Now what is GSHS? So GSHS came out to be this value only. Okay, HS is 1. Now calculate the transfer function TS, because I want to separate out this alpha. Okay, I want to separate out this alpha. Okay, so what you can do is you can calculate the transfer function. The transfer function is equal to GS divided by 1 plus GSHS. So it will be 10S plus alpha divided by S cube plus 6S square plus 10S plus alpha. Okay, is it clear, guys? So this will be my transfer function TS. Now what you can do is, we can take this coefficient as common. Okay, take this as common. Leave this alpha, leave this alpha and take this as common. Okay, if you take this, because I want to convert this in terms of the alpha should be outside. From this transfer function, I want to calculate GSHS. And in that GSHS, alpha should be outside. Okay, alpha should be outside. It's like K. Alpha should be K. Now, how can I make it like this? How can I make it like this? So there is a way to make it like this. And what is that way? What is that way, guys? Tell me. Is there any way such that we can make the alpha outside like this? Tell me. Is there any way so that we can make this alpha out? It will act like a K now. It will act like K. Now, how to make it like this in this form? How to achieve this? Tell me. How to achieve this? How to achieve this? Tell me. Is there any way? Take characteristic. Oh yes, I can take characteristic equation. Obviously, I can take characteristic equation and then I can make, because we know that how to calculate the breakaway point. Breakaway point can be calculated as dk by ds equal to 0. Okay, so we know that this is my characteristic equation. Okay, this is my characteristic equation, and from that equation you calculate the alpha first and then take d alpha by ds equal to 0. Is it fine? You can do it like this also, but I want to modify this. I want to see whether we can modify this and accordingly we can solve it. Okay, so there cannot be the way, like, you cannot do it like this. You cannot make alpha common. You cannot make alpha common, because if you take somehow you can make this alpha common, then I think it will be more easier for us. It will be more easier, but anyway, we can do it. So what we can do is we can calculate the characteristic equation. Okay, better we can calculate the characteristic equation. So the characteristic equation came out to be this value. Okay, or you can say 1 plus GSHS is this value. This is GSHS, so you can put it here, 1 plus GSHS, 1 plus 10s plus alpha divided by s square into s plus 6. Okay, this came out to be 0. This is my characteristic equation. So from here you can calculate the value of alpha. Okay, so alpha came out to be minus of s square into s plus 6 divide by 10s. Is it clear, guys? Is it clear? Tell me. I think this is clear. I think this is simple. So please check it. I have taken this on this side and then no. I think it should be minus. It should not be in the denominator. It should be minus. Wait a minute. So alpha has to be equal to minus s square into s plus 6 minus 10s. Okay, so you can calculate it like this. Is it fine? I think you can do it like this and then take the derivative and then calculate d alpha by ds. Okay, now you can calculate d alpha by ds and make it equal to 0. Okay, and then you can calculate the value of alpha. Do it, guys. Now it's simple. So we have calculated alpha from this characteristic equation and then took d alpha by ds equal to 0. Okay, please check it and tell me what answer you are getting. Tell me, guys. Tell me which answer you are getting. Is it Bombay? Okay, let me check one more method. Let me apply one more method because there should be one more method. And what this method can be? Okay, wait a minute. Let me see. Yes, you can easily solve via this. No, you can easily solve via this. But I want to try it in a different way. I want to take this alpha out. In GSHS, I want to take this alpha out, and these terms should be without alpha. So what I can do is I can take this common. Na? If you take this common, then it will be TS will be equal to, in the denominator you have this s cube. In the denominator you have s cube plus 6s square plus 10s. That will be out 1 plus alpha divided by the same term, s cube plus 6s square plus 10s. Okay, you can solve it like this. Now the problem is actually you can't do it. There is a problem with that. No, you can't do it because in the numerator you have 10s plus alpha. So if you write it, if you make this as ZS, then no, it's not correct way. Okay, it's not correct way. Okay, it's not correct way. So I think you have to apply this method only. There is no other way. There is no other way, guys. So what I need to do is I need to take the characteristic equation, calculate alpha, and take the derivative with respect to s, make it equal to 0, and then calculate the value of s. Calculate the value of s. Is it fine, guys? This is the only way. So you have calculated 2 points. Is it Bombay? Tell me, guys. Is it Bombay? So it will be minus s cube minus 6s square minus 10s equal to 0. I mean, this is my alpha. Take the derivative. So if you take the derivative, it will be minus 3s square minus 12s minus 10. Okay, and make it equal to 0 and calculate the value of s. From here you can calculate the value of s. Okay, so you'll get the answer Bombay. I think it's correct. Let's come to the next thing. But actually, out of these 2 points, you have to look which points are on the root locus. Okay, let's see, because it is not over yet. Okay, we have to see whether these points lie on the root locus or not. Okay, so how to check whether these points are on the root locus or not? Okay, so you have to calculate it. This is a typical question, I think. You can't do it. You can't plot the root locus directly. Okay, because this alpha is not outside. It's not like k. It's acting like a 0. It's acting like a 0. If you are changing alpha, the zeros are changing. Okay, the zeros are changing, and the closed loop poles are also changing. Obviously, the zeros are also changing, and the closed loop poles are also changing. That's why I want to take this alpha out. That's why I want to take this alpha out. But I think there is no way we can calculate the alpha out. Okay, there is no way we can calculate the alpha out. Okay, there is only this way, and we can't even check using root locus. Okay, we can't even check using root locus. So for the time being, let's take it correct, and maybe I'll check it. I'll check this question and then I'll come back to it. Okay, sir, is the function 10 alpha by s is a lag or lead compensator added? Okay, so it's the proportional controller, and this is my integrator. Okay, so proportional plus integrator is there. Proportional plus integrator is there. But if you look at the root locus, because I want to plot the root locus of this system. So this is my GS. This is my GS. Now what I want to do is I want to make this alpha as parameter. It's a variable parameter, because generally in root locus you have this type of function, k into s plus z1 divided by s plus p1 into s plus p2. Then you plot the root locus. This is my GSHS, if you remember. So that variable should be outside the zeros. Okay, that's why what I'm doing is I want to calculate the transfer function. Using this transfer function, I want to modify the GSHS. I want to modify the GSHS such that I want to modify the GSHS such that this alpha came outside. Okay, we can modify it. Wait a minute. Okay, wait a minute. Okay, guys. So this is my transfer function TS. Okay. Don't do it like this. Okay. Okay, let's see. So this is my TS. What we can do is we can take this common out. So it will be 10s plus alpha divided by s cube plus 6s square plus 10s 1 plus alpha divided by s cube plus 6s square plus 10s. Okay, so now this is my GS and this is GSHS, and I am interested in GSHS. Okay, when you are plotting the root locus, this will become GS. Let's call it GS. Okay, and it will be my GSHS. I hope it is clear. Okay, this is my GS and this will be GSHS. Is it fine, guys? So I have calculated GSHS as alpha divided by s into, take the s common, s into s square plus 6s plus 10. Is it clear, guys? Why I need to modify this? Tell me, guys. Why should I modify this? Why should I modify this transfer function? Why should I modify this transfer function? The problem is, generally we plot the root locus, and in the root locus the k should be outside, if you remember. Because if you vary the k, the closed loop poles and the zeros will change. Okay, the closed loop poles will change. Okay, the poles will move on the root locus if you vary the k, but that k should be outside. But the problem here is this k is not outside. Okay, this alpha is not outside. If you look at this GSHS, again in GSHS this alpha is there. It is not outside. It is not like this. So we have to make it like this. So what I did is I calculated the closed loop transfer function. This is my closed loop transfer function. Then what I did is I take this common out. Okay, so now it will act like GS divided by 1 plus, it will act like GSHS. Okay, so now this is my GSHS. I hope it is clear. Okay, I hope it is clear. So this is my GSHS. Using this GSHS, I have to comment on the breakaway point or break-in point. Now the characteristic equation will be, if you take the characteristic equation will be s into s square plus 6s plus 10 plus alpha equal to 0. This is my characteristic equation, and you can calculate alpha from here and you can take the derivative and you will get the same answer. Okay, you'll get the same answer. So alpha will be minus of s cube plus 6s square plus 10s. Now you take d alpha by ds. Okay, so it will be equal to it will be equal to minus of 3s square minus 12s plus minus 10. Okay, so it will be minus 3s square minus 12s minus 10. This is correct. Okay, make it equal to 0 and calculate the value of s. Now out of these two values of s, we have to check which value will lie on the root locus. So you are getting the B answer. The roots of this equation are these two options. Okay, let's wait. Now let's plot the root locus of this system. Now how to plot the root locus? The pole is at this position and there are two other poles. Now tell me, the two other poles are at the complex pole. Okay, these are the complex pole, and the real part will be at minus 3. This will be minus 3 plus minus j. You can calculate that, minus 3 plus minus j. Okay, so you can calculate the coefficient of j. Okay, so you'll get the pole location here. So now you can see that the entire real axis will be the part of root locus. The entire real axis will be the part of the root locus. Okay, and these 2 points lie on the real axis, so you can say that these 2 points are on the root locus. That's why the answer B is correct, because once you calculate the s value, you have to check now. You have to check whether these points are lying on the root locus or not. If these points are not lying on the root locus, then you can't take them. Okay, you have to pick that point only which is on the root locus. So that's why if GSHS is this, we can plot the root locus. So one pole is this, one pole is this, one pole is in the lower half. So what you can do is you can check that entire real axis will be the part of the root locus, and these points are lying on the real axis. So these points will lie on the root locus. That's why answer Bombay is correct. Okay, so don't put it don't guess. Okay, because you have solved it half correct. Okay, though the answer was correct previously, but this is the proper way. This is the right way to solve it. Okay, because you have to check on whether these 2 points are lying on the root locus or not. That's why I have solved it like this, and that's why I have to make it like this. That's why I have to make it like this. And GSHS should be this. This is my GS. So 1 plus GSHS. This will act like GSHS, and we require GSHS. So this is my GSHS. Okay. From that onwards, we can solve it. Now let's come to the next question. So let me correct the question. Let me check the original file. Okay, because this question again needs some modification. Yes, in this question, the open loop transfer function of a unity feedback system is, that is GS equal to K divided by S into S plus A into S plus B. Okay, the system will oscillate with frequency. So we need to calculate the critical frequency of oscillation. Tell me guys, which method you will apply? Tell me the frequency of oscillation we need to calculate. Now tell me how to calculate the frequency of oscillation. Tell me at what frequency the system will oscillate. Obviously for some particular value of K, it will be oscillatory system. And for that value of K, we need to calculate the frequency of oscillation. So how to calculate that frequency of oscillation? Tell me guys, how to calculate the frequency using Routh. You can apply Routh. So tell me, apply the Routh and tell me what is the value of frequency of oscillation. Tell me guys, do it fast. How to calculate the frequency of oscillation? What will be the frequency of oscillation? Do it fast. Do it fast. Let's see how many of you can solve it. You can also use polar plot. You can also use polar plot. Now, if HS is 1, then we can also say that this is GSHS. Now remember, in polar plot, let's say the polar plot is like this. Okay, let's say this is my polar plot. Wait a minute. Let's say you have this polar plot. Okay, I think the polar plot will be like this only. At S equal to if you write the phase, it will be 90 minus 10 inverse of omega by A minus tan inverse of omega by B. Okay, is it fine, guys? So this will be my you can say phase. This is my phase. Okay, so at omega equal to 0, the phase it will be at minus 90, and for omega equal to infinity, it will be minus 270. I think this polar plot is approximately correct. Okay, this is the polar plot. In polar plot, look at this frequency only. This frequency is phase crossover frequency. Okay, this is my phase crossover frequency. That phase crossover frequency will become the frequency of oscillation in root locus. Okay, this phase crossover frequency itself will become the frequency of oscillation. You can try it with Raut also, no problem. You can do it using Raut. You can do it using polar plot also. The phase crossover frequency will act like the frequency of oscillation. Will act like frequency of oscillation. We have to calculate this frequency. How to calculate this? Because we know that at this frequency, this phase has to be minus 180. So calculate the omega at which this phase become minus 180. So take this 90 on this side. So you will get tan inverse of omega by A plus tan inverse of omega by B, and you will get 90 on this side. Okay, so that will be tan inverse of A plus B divided by 1 minus AB. Okay, and it has to be 90 degree. Now it will become 90 degree only if the denominator becomes 0. So what you can do is 1 minus omega square upon AB equal to 0. So from here you can calculate the omega. Omega will be equal to root AB. Okay, this is my omega PC. That omega PC itself will act like the frequency of oscillation. Answer is Bombay. Do you know that? Tell me, guys. Do you know that? This is my easy method, na? In 2 lines you have calculated it. If you apply Raut, let's say you apply Raut. In Raut criteria, first you have to calculate the value of K. Okay, so that the system will become marginally stable. Okay, you have to write the characteristic equation. So the characteristic equation will be SQ plus A plus B S square plus ABS plus K. Okay, this is my characteristic equation. Now first you have to calculate the value of K for which the system is marginally stable. You have to calculate the auxiliary equation, and then you have to calculate the frequency of oscillation. That's again easy, but remember this point also, na? Using root locus, using polar plot also you can calculate. In polar plot, remember omega PC itself will be my frequency of oscillation. Okay, just remember this point. I hope it is clear to everyone. I cannot tell you why this is correct, why this omega PC will act like. In root locus, you show that, let's say the root locus is like this. If you plot the root locus, let's say the root locus is like this. Maybe the root locus is like this. So this frequency is frequency of oscillation, and this will be equal to omega PC. That's correct. Okay, this will be my omega PC. Just remember this point. If you want to compare the polar plot with the root locus, then you can easily compare that, and this omega PC itself will become omega. This omega PC will be this frequency. Okay, the frequency of oscillation. So just remember this point. Okay, remember this point, because I don't want to tell you the proof of this statement. Okay, so I hope it is clear to everyone. So now this was the last question, guys. I hope you enjoyed. Don't forget to join our test series. Okay, so BYJU'S exam prep is also providing you the test series, and in this test series you will get 60 plus tests, and along with that, the interface is exactly same as the provided by the GATE exam, and there are 4,000 plus practice questions. So you will get multiple tests, subject-wise test also, and full-length mock test also. So don't forget to join this test series and attempt this test series. It's not that much costly. You can join it. Okay, guys. So now it's time to subscribe this channel and like this session, because it's 80 likes, and I told you I want to make centuries of likes, but unfortunately we are 20 likes behind. Okay, but anyway, it's okay. So thank you for showing patience, and please subscribe it, press the bell icon so that you get the notification whenever you get the video live. And that's all for today's session, guys. I hope you enjoyed. Don't forget to install our mobile app. On this mobile app also you'll get some free classes. So you can join those classes also, you can attend those classes also, and you will be benefited from those classes for sure. Okay, so that's all for today's session. Thank you for attending this session, and I hope you enjoyed. See you in the other session. Thank you and take care. Bye.